Reports
ये
like
तो है
bills of
कुछ
materials, BOM, can be automatically generated, which
erano Good morning, ladies and gentlemen. Let me welcome on our second day of the conference. I hope you had a restful night, you have enjoyed the evening reception, and you are ready for the next day. We have some changes in the agenda. As I said, the first speaker is unfortunately cancelled. So we're moving forward the agenda 25 minutes earlier. So all our speakers are aware of that fact and ready to present earlier. So we might also end our second day a little bit earlier. From the organization side of view, all the coffee breaks will again take place in the lobby in front of the conference room, lunch in the restaurant, and then for your departures, again, you can use the shuttle bus. As some of you already asked me about the presentations, so the presentations will be available in 2, maximum 3 weeks after the conference, because we want also our speakers allow them to make some possible changes to the presentation. So for all participants in 2, maximum 3 weeks, you will receive it, and you will also receive the recordings of both days of the conference. I would like to also remind you to fill in the evaluation form. Please rate our speakers so they can have a feedback about their performance, also for our organization and everything. Thank you very much. And I'm handing the word to our chairman, Mr. Gunnar Hollen. Thank you. The stage is yours.
Yes, thank you all, and welcome to the second day. I think we had a very interesting day yesterday with several project developer and a lot of sort of other players, stakeholders in the industry. So we're looking forward to a new very interesting day. And first up, we'll hear about the development of an ammonia project in northeast of Brazil. So welcome Estela Corbacho.
Hola, hello. Okay, so my name is Estela Corbacho. I work for FRV on the development of hydrogen and derivatives projects. Actually, I'm the project manager for the project we are presenting today. First of all, I would like to thank LEAP Event for inviting us here today and giving us the opportunity to share our experiences in Brazil with you. So, yeah, so I would like to have a quick intro of FRV and FRV, so you know who is presenting. And afterwards, I would like to go over the core topics of the presentation. Okay, so FRV started in Spain almost 20 years ago as a PV developer. It expanded into other geographies. So today we are strong in Australia and LATAM and other countries in Europe. And the most important milestone in the history of the company occurred in 2015. We were acquired by Abdulatif Jameel. That is a family-owned company from Saudi Arabia. Which is presence in 30 countries, 11,000 employees, strong presence in several sectors like automotive, water, and energy. We are part of that energy branch, and that step allow us to become an IPP. So today we have almost 4 gigawatts in construction and operation, and indeed we are not developers anymore, but we keep the assets and we look for long relationships with this project. Myself, I belong to FRVX, which is the innovation department of the company. When we say innovation, we refer to new business lines. So we look for new business lines that have synergies with the core business, renewable generation, and it should work as it did actually for batteries. So we start with a pilot that should be escalated and then grow into a business line in its own. So that is what occurred with batteries, and that's what we are looking forward to do with hydrogen. So that is the priority number one today in the department. So first of all, I would like to summarize what we think are the key elements that a project should have. So when I say offtake, I think it's no surprise for anyone. So if you want to project to fly, you need to have a credible partner with the willingness to pay and enter into a long-term relationship with you, ideally as a partner in the project. In terms of energy, what we have seen is that it's important to have a reliable supply compliant with EU regulation, unless you want to have the market. But yeah, if you are compliant with EU, then you are compliant with every other market. And you need to find as well a bankable partner there. The rest of the factors maybe are not or do not seem that relevant, but can be a killer for your project. In terms of infrastructure, the grid capacity is very important and not that easy to achieve sometimes. Water access is as well key. I mean, it won't have a crucial impact on your cost for the end customer, but with the amount of droughts and climate events we are seeing, and having a reliable supply in terms of availability and quality over the time, non-competing with human use is very important for your project. It's yeah, one of the basics actually. In terms of permitting, we see that sometimes a permitting process gets complicated, so it's very important to have a clear process, a soil administration which is not bringing it back to you again with changes. And of course, if you are intending to export, it's the ammonia license for the port. It's one of the greatest risks. In terms of design, so we are developing, and I think for every developer, sometimes rushing or being fastest, the fastest one is one of the priorities. However, we should not forget about having a solid design, because that will revert in a solid operation and the most efficient use of the energy. In terms of support, we see it is important to have local support, but also support in when you are exporting, international support at the location you are sending your product. And last but not least is the logistics. What we are seeing is that sometimes even that is a sort of a filter that some potential customers are applying. You should have quick access to maritime logistics, avoiding rail or train transport if possible, because that will not only impact on your cost, but will impact on your CO2 footprint, putting at risk the compliance with the regulation. So with all these elements, we are trying to pursue, and we are it's our sort of checklist that we are complying with our project Kumbuko. Okay, we are developing this Kumbuko project in PESEM. Our scope is actually within the orange line. It's a 500 megawatt electrolysis project. 1,200 ton of ammonia capacity per day. Okay, the issue is not drawn there, but of course it's in the scope as well. And this is indeed FRV project. However, this project would not be relevant or feasible if it was not in the ecosystem of the Port of PESEM. So if we go upstream, it is a grid connected project. It is energy negotiations are ongoing at the moment. Water has been secured. So we are in discussions with Utilitas. We have visited their installations. It's the current supplier for the industrial uses at the port. It's reused water from the city of Fortaleza, which makes the project non-competing with human use. And especially at a place with such high population, we think this is quite important as well. And if we go downstream, Thank you. If we go downstream, we see the terminal operator. This is a multi-producer terminal at the port that will be shared with other producers, allowing for cost optimization in terms of infra with direct access to the port for shipping purposes. So if we look over the value chain, the project is full compliant with our FMBO requirements. So it's ready for the European market. It is located in the northeast. That means 90% of the energy in the grid, above 90% actually, has a renewable origin, which makes it decarbonized compared to European regulation. And the cost of energy is the most competitive we have detected in the different regions we are working today. So that will allow for competitive project of the end product, but not only that, that will revert as well in a very stable operation, reducing the technology risk. So additionally, we see, as mentioned, 500 megawatt electrolysis, 400,000 ton ammonia capacity per year, and that will result in an estimated investment of $1.2 billion. In terms of permitting, the first phase has been completed. We are working on the second phase and secure land in the CPE. So the port has reserved land in the tax-free zone, so with tax incentives for the export projects. And the timeline we are pursuing is having an FID in the first half of 2026 and a COD in 2029. I would like to talk about the institutional support we are receiving as not only project, but hub as well. So the Port of Pesem is originally property of the state of Ceará. And the port started developing this hub about 6 years ago, asking the Port of Rotterdam, hey guys, can you help us doing this study to understand if indeed there is potential or not for a hydrogen hub? The Port of Rotterdam did this study, and seeing the results, they decided to acquire 30% of the share. So you can see Prime Minister Rutte, well, at the moment, Prime Minister Rutte signing the agreement with the governor of Ceará. You also see FRV signing the pre-agreement for securing the land at the port. And something that we see as a crucial sign is that the hydrogen law in Brazil was signed in the same location. So we feel very welcome in that area developing hydrogen, actually. I wanted to show, well, first of all, these are not FIV numbers, these are BNF numbers. And what we wanted to show here is that, and I think we all know that the energy cost is indeed the key cost together with the CapEx in the equation. And the transport in the end, it is a cost, but it won't impact that much the end cost of the customer. So we think we can compete. We see the competitiveness of the project in markets like the European, but as well in markets like the Asian one. So the challenges we are currently facing and what we are seeing as we further develop, of course, the project size is the first of a kind in Brazil. It requires technology integration. It will require qualified labor in a region which is not the most industrialized of Brazil. This is not Sao Paulo. So we see challenges ahead in that sense. In terms of offtake, we do see interest. We still see some points of discussion who need to be worked out, like the term of the contract. I think this was mentioned yesterday by Pierre from Uniper. Today, the ammonia is not bought in 10-year contract. Especially if you go to the shipping sector, the fuel is not bought in 10-year contract. Maximum you will get 3, even 5, but that is tops, you know. So The term of the contract is something that needs to be worked out. And also the indexation. Today, ammonia is indexed to the gas indexes, who have no impact on the cost of electricity we will be using. So that will need to be worked out as well. In terms of procurement, it's a huge project. The kind, any amount of equipment and materials that will be purchased is exceptional. And we need to think that it won't be only FRV's project, it will be the terminal project, it will be other producers' project, it will be the infra for water, the infra for electricity. So that will be indeed a huge challenge. In terms of securing energy, we need to think as well, it's a huge volume. I mean, we are talking here about half nuclear plant. The guarantees that you need for that are huge. So indeed, we are in discussions with the biggest players in the country, but still it's to be worked out. I mean, I think we start talking here sometimes about gigawatts and huge projects, but the amount of energy, only this project would be like the second or third biggest plant in the country. And lastly, the partnerships. We are, I think it was indeed the people from Uniper again, and probably other colleagues that said, yeah, you can't do this alone. So you need reliable partners. The bank is going to look at your consortia. You need to be reliable. Your partners need to be reliable. They need to be bankable, and you need to cover properly the value chain. So that's indeed something we are working on at the moment. Said this, with the ongoing challenges and the ones that still lay ahead, we do see the competitiveness in this project. We think it can be one of the most competitive in the sector, and we will be pushing until we start the construction in 2026 to make it a reality. So yeah, this is indeed my presentation for today. If you have any questions, I will be available. Thank you.
So any questions? Yes, start here.
Thank you very much for this very practical presentation. Let me know if it's possible. What is the purpose of that green ammonia? Will it be transformed chemical products or fertilizer or whatever, or will it reflect hydrogen as a just hydrogen transporter?
So we are looking at different markets, as I mentioned, the European one and the Japanese one. And for Europe, we see two possibilities. One is the replacement of ammonia, of current gray ammonia consumers. We do see some increasing interest in ammonia as a carrier. So there are some companies in Europe that are looking into decarbonization, and indeed that you would require to be cracked back. Additionally, we are looking into the Asian market, and over there, apparently they want to do different thing, which is the co-firing, and that's something we are studying as well.
Question on the renewable energy. What is the factor of the renewables that you get? How much fluctuations do you expect?
We do not get fluctuations. So indeed, the grid is decarbonized. We will be connecting to the grid, and actually we are our intention is to close a PPA, but that's more a financial risk. So for the plant, we expect to have base load, so 24/7.
Yeah, two questions. Thank you very much for the presentation. The first one, the price seems very aggressive. I mean, I know it's not for me from BNF, but the sort of pricing we plan to achieve in Brazil would be quite interesting, because it's for the I don't know, in terms of hydrogen production, it's probably 2 or 3 easily euro per ton less than any other project. So could be. And the second one is, in Europe, we see that lots of ports are actually quite concerned about increasing their capacity to offload ammonia, because it's extremely difficult to handle. is there any consideration of that sort in Brazil? Because it looks like easy, but
No, it's not easy, of course. I mean, I think nothing on this project is easy. I mean, it seems it's a very short presentation. I can tell it in 10 minutes, but the work behind this it's already months, and it will be even more. So indeed, in Brazil there is as well concern on this. However, the port has today a operation license for other fuels, and they have requested an alteration. Well, I hope I'm translating it right. Of this operation license, and they expect to have the ammonia export license in the beginning of 2025. Actually, it's a port which is indeed in Ceará, and they are getting water from Fortaleza city, which is 3 or several millions of inhabitants, but it's 40 kilometers away. So in terms of license and potential impact, there is no huge population close by. So it's a port sort of in the middle of nowhere. So of course there is concern. In the end, we are talking ammonia. It's something toxic. I mean, that's the thing. But I think it's feasible, and it will come in the coming months. In the end, if you look at Rotterdam, for example, you have your ammonia terminal, which is relatively close to some population, and it's in operation. So there is concern, but there is also a way to do it, a safe way to do it, as it's happening in Rotterdam.
sorry, on the first question on the price.
On the price, yes, indeed. The price. Which price are you asking for? Electricity or?
No, I'm asking for the price of hydrogen to start with. I mean, even if you have a cheap electricity in Brazil, which I guess for now is probably used by somebody else, but that's another topic. How come you get to that level of pricing?
No, the pricing that was over there is not FRVs. That is BNEF. Okay, so that what I wanted to show with those numbers is that we will be the transport is not the heavy cost in the equation. Those are not the numbers of the project itself. Those are the numbers. You mean those? Yeah, these are BNEF numbers. So these are not our numbers. Actually, we are way cheaper than the European hydrogen, but please do not link this to the project economics. Still, we are targeting a very competitive energy price. I cannot tell you that we will be close or far from this, but in terms of cost, we are competitive with the last auctions that were the H2 Global that was granted, I think, a couple of months ago. Okay, so thanks a lot.
Thank you. Then we continue with Claes Fredriksson, the CEO, founder of Liquid Wind.
Thank you. I'm going to try this walk around version. I saw Tobias did it so well, so I thought I'll see if I can float around as well and create some interactivity. But very welcome to my presentation about electrofuel, and I think it's what we all know, right? We go from renewable energy and some biomass, and we make some fuel, and it's pretty easy thing, right? We're all in the same plan to do it, and we've done it perhaps for a little longer than some of you, and I'll share sort of the experiences that we have and a little bit about how far we've come. We have a vision, which we all do, but I think our vision is trying to be far out there, and it's really about avoiding fossil fuel in the long term, or at least avoiding the dependency on fossil fuel. And I think we all know it's going to take us a long time to get there, but it's at least a place. It's not even a place. It's an area we're trying to go for the future. We've said that to get that a bit more tangible, we need to go after a segment or a market, and the market that we focus on is the shipping space. And yesterday we heard a lot about the shipping space and then the airline space and so on, but I think we've found it quite helpful to have one place to go after, and that's the shipping space. And I think really when we chose it, it's because we knew we needed to do project financing and we needed big customers. And we found in shipping, it's the biggest customers that we could see, at least at the time. Our purpose is to develop facilities, but also to enable that other facilities are developed. So we hope to help all of us in here to develop facilities and make sure that we get this market going, because we've been trying now for a while, but it's a little bit slow. But we want to keep pushing so that happens. So far, we have 5 fuel projects in process, if we call it so. We have one with Brogan down here in Juniper, in Östersund, which is the little yellow dot sort of on the top left. And then we have a few others. I'll get to them soon. And we are doing that very focused, as you can see, in Sweden and Finland. That's where we want to be. That's where the power is cheap. That's where the biomass is available. That's where there's an interest in getting this thing done soon. We also want to be fairly green. The green dots are our offices. We have now about 70 people in a couple of different places, mainly in Copenhagen, in Gothenburg, and in Stockholm. We have a few spread out in Finland, Germany, and England as well. But we've actually come to 70 people, which we think is quite phenomenal. And I know I spoke to Mr. Schneider down there. He has 139,999 colleagues, and I only have 69 colleagues. But we still think it's pretty good to have come to 70 people, because the people that come to work for you when you're a small startup are quite special. They look for something more. They have a stronger vision. They want to do something. And we've managed, I think, to collect very, very good people that help us now go further. And as we get bigger, I would say it gets actually quite a lot easier to get people, but it's slightly different people than those first guys that came in the beginning. We have 4 partners, and that's absolutely key for us. But we also have 200 investors. And it's not necessarily because we wanted to have 200 investors, but it's because we started with crowdfunding. Who knows about crowdfunding? It was $200 to get involved in our company. You could buy 2 shares at $100 each. Quite a lot of people actually bought shares, which was quite fascinating also. And that got us going in the beginning. So we got up to, fairly soon, we were up to almost 200 shareholders. But then we have our bigger partners, the OEMs, which are also our shareholders. And this was something we did very, very early. We felt we need bigger friends, and we need friends that know what they're doing. And these companies, you may not know Carbon Clean. Now you probably know Carbon Clean as well. I mean, they know what they're doing. I think Siemens tells me they're 149 years old. Topsoe is about 92 years old, I think. Alfa Laval is, who knows, 100+ years old as well. So these guys know what they're doing. And we were able to attract them and to make them interested in what we were doing when we were very, very small. We started with this in 2018, and we had a what do we call it, a speed dating event where we invited quite a few companies that could do this. And there were not so many in 2018. We got them in, and then we selected our partners. And since 2018, these have been our partners. And then since then, we've also had the benefit of having a few more investors. And there are names here in the bottom that I think we've all saw them yesterday in different constellations. Elise from France, they were in very early with us. HiCap, that have other friends here with us. And Juniper, of course, as a very big investor in Liquid Wind. So this is our core team, if you will. And we think we might need to grow the core team with 1 or 2 more skills or 1 or 2 more players to become really good. But that's sort of where we are and what we kind of lean on. And now it's up to us after all these years to make sure that we make enough money so we don't have to go ask them for more money. So the problem we solve, I think, is the problem maybe we all solve, but slightly differently. But for us, this is what it was. It was shipping. 100,000 ships need a new source of fuel in 25, 30 years. 100,000 ships. They burn about 300 million tons of fuel. I don't know how big that lake is, but it's just an absolutely enormous number. And it's still a lot less than what we do on road transport. But we thought this was a good opportunity. We call that, if we take within the methanol sector some 30–40%, it's a 250 million ton methanol business opportunity, which when we all get to the 1,000 euros a ton that we want to be at, it's a decent business opportunity. So it's worth going after. I think the ammonia one is probably similar. The SAF, whatever SAF you have, is also similar. But it's a big space. And we were happy to see that when we started in 2017–18, Maersk started also to think about the same thing. And they made a big announcement in 2020 that they're buying all these methanol ships. And since then, in our estimate, there are 330 methanol ships either built or under construction, which you can say is only 330 of the 100,000. But those 330 need way more fuel than all of us together can produce. And we have to start to produce that fuel, because if they don't get it, they have to find other solutions, right? They can always go back to the fossil, but we need to get it there for their sake and for ours. So how do we do it? Well, we are really a developer, or we normally call it, we're a party fixer. We fix the party. We get everybody together so the party can happen. We don't have any IP. That's not true. We have IP now, but we don't really have anything of our own other than the ability to collect all the players. And in so doing, the key pieces, of course, is where are you going to be? I think Brogan shared with us very well yesterday that the site is super important. I think we heard that this morning as well. The site is super important. So we select sites very, very carefully. And then you do all the things that is around. And of course, you found your off-taker, which is very important. And then the power. And of course, somebody needs to bring the money as well. But it can all be done. And we can all learn how to do this. And we've practiced now on all these facilities here. And some of you might know that this one here, the one that we call Övik, that's what was called Flagship 1, or is also called Flagship 1, that we actually sold to Ørsted in 2022. Ørsted took FID in late 2022 and then started execution. And then they decided to pause execution or stop execution a few months ago. And there are many reasons. They give some reasons in their information or in their announcement. But I think the reason why they stopped is also because what we're doing is very difficult. It's difficult to build chemical plants. And we have to have respect for that. And I think somebody said it here yesterday, I think maybe it was the banking lady, that you cannot start sort of make a huge projects. You got to start sort of somewhat carefully, or at least start with people that know what they're doing, because it is a difficult game. So you know that this is the process, and it looks easy. Pop an electrolyzer in, do some carbon capture, do your methanol synthesis, and off you go, right? But it shows up that to do this, and where's the top gents? They know this quite well. It takes a lot of skills, and it takes a lot of sort of things to come together. And then you need to get that EPC contractor that doesn't want to show up because it's too risky, et cetera, et cetera. You kind of know the drill. But so what we've figured out is that if we can make this simpler, if we can standardize what we do, and then do the same thing again and again and again, then we believe we have a better chance of succeeding, and a better chance of succeeding on time and on budget. So from now on, and I say from now on because Flagship 1 was a 50,000 ton plant, everything thereafter is a 100,000 ton plant. 100,000 tons, roughly 150 megawatt power in and 140 megawatt electrolyzer. But we do it standardized and we do it modularized so that we don't have to do it again and again. And we think we're on to something here which works. We had to, of course, find a suitable size. So we're big enough, yet small enough, and we can be attractive to enough people. But I think we've come now after a few years to like this size and to see that others can appreciate that size as well. And we have quite a few, if you will, customers or interested parties to work with us on that one size only. We've then made sure that we digitize the whole thing as well. So we have the design completely done digitally in a software or in a system where all our partners work together. Either they work in the software itself or we import the stuff to the software. As you may know, different technology providers tend to have different companies they work with and different software they work with, but we're getting there. So we're actually beginning to work in the same system. And this is crucial for us because once we do this, we can pretty much bring all the learnings together in one place, and then we can more or less copy paste for the next one. And Flagship 5, North Star H2, will be the first plant that benefits from everything that we've learned from the previous 4 plants as we basically download the design into Flagship 5. And we'll have a good chunk done by what we've done before, so we don't have to start from the beginning. I think what the digital twin also helps us do is that we can upload information from the operations. It's not happening yet, but as we start to operate, we will also upload so that we get our system better and the system learns and understands what needs to be done for future plants. So we can then, almost like on your phone or your computer, we can then download the updated software so you can get another percentage point or something out of your plant. And we're doing this within the twin. We're using the Siemens system, the COMOS from Siemens. We've spent a lot of time and a lot of funds on getting this right or getting this going. But as I said, from Flagship 5, we think this will work very well. In addition to the digital twin, we've also figured out that if we work even more tightly together with our OEM partners, we can get smarter. And we've created what we call the Design and Performance Center. It's a physical space in Copenhagen where all the partners that you see in the bottom have people working at least 3 days a week. So we come together 3 days a week in this place and work on the next generation or the next generation or something in the plant that needs to improve for the next generation. We agree on what we should improve, and then we all help out to make that improvement. And the liaison officers, as we call them, they go back to their home office, pick up all the resources they need, and then come back and deliver this. We even have a target price, LCOM, for where we need to be in 2027. I hope we will get there. I don't know, but I hope we will get there because it has to get more cost efficient and we have to get cost out of the system, right? But to bring this together, looks easy when the photo is there and everybody's smiling, but it took us about 1.5 years of negotiating to figure out whose IP is in, whose IP is out, what is mine, what is yours. If we find something together, how do we share it? And just getting all these pieces together has been a lot of effort. But now we have the system in place, people come and work together. We have a board that overlooks what they're doing and guides them as they move forward. We think this is going to be very valuable for us and will allow us to get smarter together quicker. And all these learnings are what we then want to offer to others that want to work with us so that we can provide these systems to other folks, either that we develop ourselves or that we let other develops for us, or that we simply sell what we call our core methanol plant to other customers. I started with this 2015, which is now almost 8 years ago, I think. I came across the idea of making methanol late 2015, thought it was a great idea. Let's get in and build the factory. Once the factory is done in 2018 or 2019, the fuel will be selling, the money will roll in, everything will be good. I used to work for a company called Tetra Pak. I was all about always about how do you create recurring revenue? And recurring revenue we had in Tetra Pak in a very elegant way. I thought fuel must be exactly the same. You build a factory, money comes in. We're now in 2024. There's not too much money coming in yet, but we have sent 2 invoices since I started for services that we do. So that's a good thing. The rest is money that we're collecting. But I think it takes some time to figure this out. In the beginning here, I mean, I spent most of my time trying to explain that you can actually put hydrogen and CO2 together, because nobody knew that in the 15, 16, 17. Once kind of that was over, we had to figure out the partners that we did, as I said, there in the early days. And then in 22, 23, we had our first customer. We had to work with Ørsted, and we thought we were really, really getting going. But then we went through, as we all did, there was some COVID and some Ukraine wars and other things. So it's been kind of a bit of a rocky road here, but I think we've got a pretty decent base. And with that base and now everything that we've learned, and I think what I've heard here, to a large extent, I can say, yeah, we've kind of been through that. We've been through that. We've been through that. We're more or less ready to take off. We now have the teams. We have the partners. I think we also have a little bit of, if we call it, credibility in the market, even though we haven't sold, or we've sold something, we haven't built anything, we still seem to have some credibility in the market. People seem to believe that Liquid Wind has a sense of what they're doing. But I think there's a next phase now coming, which is really delivering the value. And it's delivering the value to the customers, of course, but also delivering the value to what we call the hosts, of the people that have the feedstock. And I think that's where we're going to see things evolving in the future, because we all have to think about how do we work on the CO2 side, now that there's different sort of sets of values within the CO2. But I'm very hopeful that the fact that we've managed to get through all the way to 2024, we've seen a lot of people disappear along the way. We're still here. We still have money in the bank. We can still keep working. We have customers. That's very promising. We have, as I said before, a number of partners, both partners and a number of projects in Sweden. And we now also see that we're getting projects in other parts of the world. Because really the difference that we see now as we go forward with our own strategy is that we don't need to develop everything ourselves. We will be happy to develop with others. So for instance, with Brogan or with others who want to come to us and say, we kind of like your black box, but we'll work on it together. And we're totally ready for that and want to work with that. So this is, I guess, a little bit what it feels like. We got started. We thought this was going to be easy. It's been a little bit bumpy, but we think with a somewhat updated strategy and continued focus, one project, one product, let me say one project, one product, one size, I think it's going to be possible to do it. And if there's any recommendation, if I can provide that to you, is don't try to boil the ocean right away. I mean, try to keep it fairly simple, because it's always going to be difficult and more difficult in the end. But partners are key. Regulators are key, we know that. And then, of course, your own team is key. And when you get the right team and you get everybody going in the same direction, it's like, we're going to make this work, right? It's going to happen. But we're building an industry. It's only been 8 years or 10 years. And think about if you look back at some other industries, it takes time to get going. And I think we're on our way. It feels slow sometimes. I think for all of us, it feels slow and frustrating. But I think we're on our way, and we're changing a lot of stuff. And as I say, to make electrons to molecules is such a big change that people don't even know what you're doing. Tell me about that again. What do you mean you're making electricity into fuel? How can you do that? And then you start again. So that's us, and that's where you can find us. The QR code works. If you want to take a picture, that works as well. Now open to questions.
Hi. Well, first of all, congratulations. It's challenging, but a very nice project. I was curious about how you decided to go for this size at the $100,000 per year. I can imagine it's a compromise between scale and yeah, CO2 sources that, yeah. Is that right?
It's a bit of different things. We actually started with 15,000 tons. We had a perfect site for 15,000 tons, and they were figuring, nah, that doesn't work. We can't make any money on that, and we can't build there anyway. So then we went to 25, and we thought that was really good. And we were on 25 for a long time. And then the 25 site didn't work out for totally different reasons. So then we settled at 50. And at 50, we found a site that could do the power, that could do the CO2, and that had the physical space to do it. So the 50,000 was a good one. But as we kept going with that one, we figured out, I mean, why not do it bigger? I mean, why do it small if we can do it somewhat bigger? And then we tried to go to 200, and then we went to 1,000, so 1 gigawatt. And the 1 gigawatt, that was too complicated because we're going to build it in multiple phases. It was going to take too much time. There was going to be too much capital locked up. So then we sort of pulled back again. And in the end, we settled at the 100. And I think the combination is the power we could get in the Swedish power plants where we're going would be about 150. That was reasonable. The CO2, it was a little bit on the top end for them, but we could potentially make it work. In one case, we have to import some CO2. And then it's also the physical space, that the physical space was normally not difficult to find there. So it's really kind of a trial and error and figured it out. And then so happens that when Siemens came with their new electrolyzers, we could fit 4 in for the 50,000 ton system and then 8 in for the next one. And that kind of was also an important factor. So it's not super scientific, it's more trial and error, and this seems to work well.
Thank you very much. Very inspiring story. I'm coming from academic background from University of Staffordshire, England, and I'm looking to partners for Horizon Europe funding. My question is, have you ever applied for research fundings, or do you suggest to go for private fundings, or combination of those?
We all apply for funding all the time. I mean, that's all we do, right? So, I mean, we've been from the sort of the smallest of the small. We had a grant from our local city to help us get started, when we could have we set people's time against city money, and we could combine those two. Then we've been up to what in Sweden is called the Climate Leap. We applied for Climate Leap. We actually got Climate Leap for $15 million for flagship one, 50 million euros. So that one's good. We've done EU Innovation Fund for 2 or 3 times. We never got it. It was a lot of effort. You spend a lot of money, you write a lot of papers, and in the end, there's a lot of disappointment. We did the Hydrogen Bank as well. So I think, do I recommend funding or not? It's free money if you get it, right? But it's not free. But what I find fascinating is it's almost the bigger you get, my sense, the easier it is to get that funding because you're a safe player. So maybe it's don't start too soon because you're just going to be disappointed. But if you can find a big player and then work with them, your chance of success is probably better. I think just to keep going on that, we have in Sweden, there's since fairly recently a CCS support that is quite generous, if we call it so. And now we are doing a lot of work to get the CCS to also include CCU so that we can be part of it.
So when people talk about it, we usually talk about the economics of CO2 conversion and the price of the electrolyzers. Can you kind of go into how you got to a good, good economics, good feeling, or so Siemens because of this reason? How did that work out?
That's a big question. I mean, I think you're basically talking about this capital cost, and you need to get all your capital costs together as efficiently as possible. And you can choose different players. You can choose Siemens PEM, which is kind of their Rolls Royce, and push them as much as you can to get a decent price. So you can choose a Chinese version, which is different, right? We never were interested in the Chinese version because we were interested in the partnership with the suppliers. And And even if we would pay the same or maybe even an inch more, it's probably worth it for the partnership and for the long-term sort of durability of your partner. Because what we're going through right now with Ørsted sort of coming back on the deal, then they go back to our partners and say, sorry, the thing you sold me, I don't want it any longer. And that's, you need strong partners to be able to push back or at least come to an agreement with that and still look at us in good light. So capital cost, do what you can to get it down. But of course, it's the operating cost that is the big thing. And where do you get your power? How can you get power deals that are decent? And our choice was go north, go north, go north, right? Because in the north, it's cheaper with power in Sweden. Then came Northvolt and H2 Green Steel and a few others that also wanted power. So it became suddenly crowded in the north. But that's the power part. The CO2 part was never such a big issue. We just went into our partners and said, if you want to play with us, you give us your CO2 for free.
Okay, thank you, Claes. I think
And they said, well, what are you going to give us? Well, we're going to buy utilities from you. We're going to rent land from you. We're going to work with you. You can run our plant. You can do a lot of stuff. So it became sort of more of a deal. Now, I don't think I could do that today and go in and say, give us a CO2 for free, because they think they know better. But that's where we started.
Okay, time's up. So thank you very much, Claes. And
Thank you.
our next presentation is from SLB Capture. So welcome, Pim. Okay.
Well, it's stripping me. Yeah. So good. Well, we turned ahead. Yeah, feels great. Yeah. Yeah. Good. Cool. Hey, good to see you.
Nice to see you. Yeah.
The thing is over here. Good morning, all. Thank you for having me this morning. I think it's great to be after class. I'm here then to show actually how we do carbon capture, not for free, unfortunately, but yes, I think you made a good point. It's quite a complex challenge we're facing with e-fuels. You need to bring technologies that have been around for 100 years together and then make a business case work. So key takeaways, I always give them up front so they can sit back and relax and don't have to pay attention all the time, is we actually do this. We're building carbon capture plants, and we're actually commissioning them at the moment. And as Claes said, modular, modular, modular. That is going to be the key message of today. SLB Capture, most of you probably don't know the company. So I'll go into that, explain who we are, what our heritage is, then explain a bit about carbon capture, but I think most of you must have heard it by now. And if not, then there's some good websites or ChatGPT. And then we get into the fun stuff, engineering, building, construction projects. And then finally, some nice pictures, and I'll give you some costs, not for free again. Right, so who are we? We're actually formerly known as Aker Carbon Capture, maybe a name that rings a bell to anyone that is in the carbon capture space. So we come from the carbon capture branch of Aker Group. And 2 weeks ago, I believe, the last conference we were at, Gunnar and I, we actually had the formal name change launch of SLB Capture, because we're now part of SLB, formerly known as Schlumberger, a company that is well known for its well services in the oil and gas industry and is now expanding into the CO2 storage industry. So what is the driver behind that merger is to actually be across the value chain to deliver at scale globally, not just in the Nordics, Northern European, US, but globally, using a proven technology as well as emerging technology, be our own disruptors. And as I said, along the value chain, just not from the emitter, but also transport and storage. So we started 1996 in the Aker Group with the first offshore carbon capture facility on a rig in the North Sea off the coast of Norway. And that was the start of a journey in which we found that conventional amine technology, that was not the route to go. That was a nightmare. That project was not easy. It was successful, but we found that that is not something you want to develop on land, potentially close to urban areas. So we set out to develop the solvent, which is the blood of the system. That's actually the liquid that absorbs the CO2. To develop that on a number of aspects, HSE, energy consumption, corrosivity, to find the next generation. And we did so in a program of 8 years. And then we combined that with technology development. And as you see in the picture, the third picture, that's already where the modular concept comes in. And that modular concept was developed to test it, because now we're going to test a solvent, a technology, in all sorts of different flue gases. But flue gases are basically waste streams of plants. There's anything in there, they're never constant. So you need to assess whether your technology works there and validate that before you can actually upscale to full plant size. We did that. So the first full plant size was the technology center Mongstad facility, 80,000 ton per annum. And we ran our testing facility parallel to that one to validate that the testing facility, the mobile test unit, actually delivers data that is corresponding to full scale operation. So the small one is about 1,000 tons per annum, the big one, 80,000 tons per annum. And from that point onwards, scaling up to megatons is relatively easy. Relatively, still a challenge. So what do? We're not just a technology supplier. We basically help customers from developing the concept with feasibility, engineer. So it could be either the engineering of a modular or providing a process design package, realization, delivery of equipment, and then finally support of the operation, both in the management of the solvent as well as in benchmarking the performance, optimizing the performance, and potentially revamping if future technology offers benefits. And where are we now today? We're building 3 projects, in total 7 plants, and we're going to deliver 1 megaton per annum. Klaus already indicated that for e-fuels, we're looking at about 9 megatons of methanol, which is roughly about 14 megatons of CO2. Ambitions globally are to capture about 1 gigaton of CO2 in 2030. So that means we have to ramp up in the coming 5 years by a factor of 1,000, which is going to be a massive challenge. So our technology has been proven. So we have the amine technology, which is the basis of the projects we're building now. But the SLB family brought novel technologies, the next generation, the disruptors that are going to replace or find a separate market in the future, which are the non-aqueous solvents and the sorbents, which have their different applications and benefits. And we combine that with our 2 product deliveries, the Just Catch and the Big Catch. And I'll talk about those 2 later on. But let's go back to what this forum is about. It's about e-fuels, and you've heard a presentation this morning where nitrogen is the hydrogen carrier, and a lot of them use CO2 as the hydrogen carrier, because that's in essence an e-fuel, unless you use hydrogen as the final fuel. And so how do you actually extract this CO2? And that is CO2 you're going to extract from industrial processes or potentially energy production, biomass. You can do direct air capture, And there are some underground deposits, but that sounds a bit silly to extract CO2 to make that into fuels, whilst we're emitting CO2 globally. So it ties into what other presentations say. It's all driven by a business case in the end. I mean, you can have sustainability ambitions, you can be very visionary, but in the end, you need to make the project work. So you have a CO2 molecule, and the first thing you're going to think about as an emitter, you're not going to give it away for free. Maybe you do. That'd be fantastic. Great emitter. If I find one, I'll send them to you. But if it's a fossil CO2, that CO2 is going to be expensive in the future. It's now about 66 euros a ton ETS, and that's projected to go to 130, 150, depends on which consultancy you look at. So that is something you need to consider in your future budgeting, your future operation. What am I going to do to mitigate those costs? Right, so capture it, store it, but that needs to then be cheaper than a penalty you pay, right? Otherwise, you're not going to do it. However, if you've got biogenic CO2, you don't have that threat of this penalty. You've got a CO2 that you can freely emit. No one's going to charge you for it. But in e-fuels, that is a welcome molecule. The molecule actually doesn't know it's biogenic, but we qualify it as biogenic. So that CO2 then has a value in the value chain of e-fuels. But you compete with CDRs, because I can also capture that CO2, stick it in the ground, and sell that reduction to whoever wants to buy it. And the people who want to buy it at the moment have deep pockets, the likes of Facebook, Microsoft. And maybe you've heard some of the CDR prices. I think the last conference we were at, someone mentioned 300 euros a ton. Well, if you use that in your e-fuel project financing model, and you try to get to the 1,000 euros a ton of of methanol, it's not going to work. That's going to be a very difficult case. So you, as a project developer, want to have cheap CO2, but obviously the emitter who has this biogenic CO2, he's got slightly different drivers. He's going to probably say, well, actually, I prefer to sell it as a CDR. This is a phase where we are in now, where you get some perverse incentives in the market, where maybe that is not for the greater good, but that's the way what we're facing at the moment, and one of the challenges. The second thing is, okay, do I actually have access to storage? I mean, I can have this concept of selling CDRs, but if I'm stuck in northern Spain, right? And all the storage is developing in the North Sea. So then I have to transport my CO2 molecule all the way up to Northern Lights or Portos Aramis or the UK fields. Those are going to be massive costs. So now the business case may change a bit. I can actually maybe have cheap source of electricity, then e-fuels may become interesting. Green value of product. There's been some discussions around and some numbers floating in the market on, okay, what is green methanol price, right? I think at one point I heard 1,500 euros a ton. I think what you said, Klaas, is more realistic, 800 to 1,000. But when it's 1,500, then people start to see quite quickly a business case. But if there is that willingness to pay that extra, and there is obviously if you ship iPhones, but probably not if you ship cheap Chinese plastic toys, then there might be a market where you can actually get that premium. Subsidies, because a lot of this in this phase is driven by subsidies, funding, local, national, European. That may actually kickstart your project. And then finally, it may be a decision to make your company sustainability ratings more favorable and improve your access to capital. There is some benefits there. And sadly, those are the first considerations in any project, financial. Because technical, electrolyzers have been around for 130 years, 120 years. Methanol synthesis, I think somewhere around, high pressure was somewhere around 1919, low pressure was early 60s. Reverse water gas shift, ancient technology, CO2 capture has been happening since the original ammonia plants, maybe not on flue gas, but so the technologies are there. But it's getting them all together, that's the big challenge. Right, so not going to spend too much time on the actual process, just going to say that amine-based solvent, amine solvent-based carbon capture is a scrubber stripper system. So I have a scrubber in which I absorb the CO2 from the process gas or the flue gas, and then I bring it to a stripper where I put in energy, because absorption is exothermic. I need to put in energy in an endothermic process to release the CO2. And the CO2 comes out at a relatively high purity, 99.99%, even higher, depending on how I post-treat it. So that's this technology. There are other technologies like membranes, oxyfuel, you name it, but this is the technology we use. And the key points to consider are environment. As I said earlier, a lot of the emitters are now in urban areas. So you need to think about, okay, what are my emissions? What's my environmental footprint? Am I not replacing one environmental challenge of CO2 emission by emissions of carcinogenic or poisonous or whatever components? Second is the energy consumption. You do not want to have a high parasitic energy consumption. You don't want to have to fire extra to capture the CO2. So ideally, you recover as much as possible waste heat, integrate that as much as possible to minimize the extra energy demand, or use only energy that you're throwing away anyway. But finally, and maybe most important, is no one wants to operate a carbon capture facility if they've got an asset. Their core business is to produce whatever, cement, get rid of municipal waste, convert that into energy. No one's interested in that carbon capture. So it needs to be reliable, basically a fit and forget. Not completely fit and forget, but we've shown that with our operational experience, with the proven performance, that it can handle variations in composition. It can handle variations in flow rates, that it's not an issue, and it will never trip your plant. And that's quite critical to the operations of an asset, because any operational director is going to say, well, first question, what's going to happen to my plant? Is it going to trip my plant? No, it's not. Right, so first, when you start with a new technology, you start from scratch. You design a plant with a blank piece of paper. You've got the concept in your head, and you design it, you engineer it, more detailed, and then you execute it. We do that for the large plants, anything over 60 tons an hour, roughly about 500 kilotons per annum. That goes up to 10, 12, 14 megatons per annum plants. Smaller plants, modular. Try to do as much as possible the engineering upfront, use standard components, because that improves your predictability. That improves your supply chain, improves the costs. And I'm going to show you the impact on what it means for a product development. So this is if I go for a bespoke design, so a design that's not based on a standard modular delivery. I now have to go through all the engineering stages and the stage gates of my management to get approval, to get more development investment, to go to the next stage. And every time, need to check, is there still a business case? So you start with a technology consultation, then you look at feasibility, quick check. So can I actually construct it? Does it do what I need to do? What are the first costs? Right, then I'm convinced that is working. So now I'm going to sharpen up on the costs. So I want to have a class 3 estimate. I do a pre-feed. And then finally, we go to a point where we make a decision to go to a feed. And that's probably maybe the point where we start ordering long lead items. So finally, after 3 years, and that's quick, you're at the point where you can put the spade in the ground and start the project. And then you need to construct it. And if you do it from scratch, that's going to take about 3 to 4 years construction. So that's whole period is about 6 years. Right, so we're now nearly at the end of 24. Our ambition is 1 gigaton per annum in 2030. We are building, and we're the only ones actually building, well, there's no one other building, 1 megaton per annum. So we need to start now with 999 projects to get to that 1 gigaton per annum to be in time for that ambition of 2030. That is going to be such a challenge. Here's a project that's based on that model. It's at Brevik in Norway. It's a cement facility owned and operated by Heidelberg Materials. And this ties into the Northern Lights project. So in the Northern Lights project, heavily funded by the Norwegian government to show that a value chain of carbon capture and storage is possible. In that, the CO2 is captured at a number of facilities, liquefied, then transported in ships, long ship, they are Vikings after all, and then stored in the Northern Lights project. And that project is now currently in the final phases of the mechanical erection, and then hopefully it'll be up and running next year. And maybe you've read the news last week, the official opening of the Northern Lights terminal took place. So that's well timed. And this is the column that's lifted for all the engineers here. And this is to show you what the quantity is of CO2 that we're talking about. This is a site where we capture 50 tons an hour of CO2. That's roughly 1.25 truck of CO2 an hour. So for every truck of cement that leaves the site, 1 truck of CO2 is currently being emitted into the atmosphere. Just imagine trucks go up. So we need to store that locally because the ship has a transfer time. And this is about 6 or 7 days worth of storage. So you can see the field operator standing next to it. So that's the amount that we're looking at for 400,000 ton per annum. That's relatively small in the world of carbon capture. So just imagine that you have to change a massive power plant and install a carbon capture facility, how many of these tanks you need to have, and the safety implications. You see a wall, for example. Well, one does not want to have a breach of one of these tanks and then have a flood of CO2 hitting the local community. So that's one of the challenges you face there. Additionally, it's not just capacity that's a challenge to get to this 1 gigatons per annum in 2030, but it's also the number of sites. And this is, for example, the waste to energy in Europe. This is taken from Endrava. It's a database that maps all emission points globally. And this is what one calls a hard-to-abate industry. I cannot switch the waste energy to hydrogen because then they lose their primary purpose, which is to combust all the stuff that we throw out that we don't want. So they will always be generating CO2. Roughly 50% of that is fossil, and the other 50% is biogenic. The Netherlands fossil part is slightly lower because we have, I don't know how many of these bins that we need to separate or are garbage, but that is roughly what you have. And that's 50%. Okay, which 50% are you then going to capture? That goes back to that discussion. Am I going to avoid ETS emissions, or can I actually sell the biogenic? So that's, I think it was 104 facilities, or even more. And then the cement industry is another one. The CO2 comes from 2 sources. One is the heat I put in the calcination process. But the other is actually the decomposition of the carbonates to oxides which releases the CO2. You can call it geogenic. That's one way to call it, but it's still fossil because it comes from solid fossils, and that's also a massive industry. But they do have a big challenge because their fossil or their fuel part is relatively small, so they don't have an awful lot of extra heat, but they do have a lot of CO2 to capture. So their energy is critical. But that is a topic we can cover on another conference, considering I only have another 2.3 minutes. Right. So to get to this ambition of another 999 times the projects that we are doing, and luckily we're not the only ones. There's some very solid competitors, colleagues out there that have the same ambitions. But we found that going modular is key, and that our modularity is based on the plant that we originally built in Mongstad refinery at the time, Statoil, and now Equinor, with our mobile test unit, and we are now delivering 100,000 tons per annum CO2 plants and 400,000 tons per annum CO2 plants in a modular size, which is completely wrong for liquid wind, unfortunately, because they need slightly bigger. But for many of the e-fuel projects we see, they're actually a bit smaller than this. They run around 8 tons an hour, some around 4 tons an hour. The 400s seem to be a good fit. What's our driver is more the emitters. That's a slightly different driver for our range. So we see the 100 as a good fit for waste energy, for example, 400 as a good fit for cement industry. Also, the 100 actually allows this upscaling because these are complex projects. It takes people or asset owners outside of their comfort zone, so they want to trial a relatively small scale first. So the 100 is a good size. Big advantages, a lot of the equipment is prefabricated, modularized, and delivered to site, which allows a quick erection on sites. That shortens the delivery time, reduces the costs of construction, allows a lot of pre-testing off-site, allows construction in controlled environments, so you're not welding in the rain, you do that in your warehouse. So that's a big advantage, and this is the 100. So we have a delivery time roughly about, it depends a bit on the project, somewhere around 2 years from purchase order to commissioning, and it's extremely compact, which is necessary because most of the assets around the flue gas or around the stack do not have a lot of space. They've got already a massive list of requirements to reduce their emissions, and they don't have the space left. And this is a 400,000, slightly bigger, obviously, would be a bit strange if it wasn't. Takes a bit longer to deliver, but still quite short. And this is the impact then on your delivery schedule. You can actually condense your engineering because a lot of the equipment has already been sized, engineered. So instead of fully designing it, it becomes more of a system integration story. How does it fit into a modular component-based value chain if you go for an e-fuel? And also in the execution, you bring it down from 3.5 years to 2.5 years. Good, some examples. So we're delivering 5 at Ørsted, 2 at Esnes power station, and I believe 3 at Everdura. They're all biogenic fired, so they create biogenic CO2, and they capture that CO2 and store it, and thereby create credits, and these credits are partially bought by Microsoft. Time's up. I'll quickly press. So this is the example. And the other one's here in the Netherlands, waste energy. This is how it looks. You see what's called the ski boot, not our design, That was unfortunately the architect of the waste energy facility. He needed to blend in with it. But under it is a fantastic piece of equipment, a carbon capture plant. You see the Lego block at the bottom. Those are the air coolers. Then you see a block left to it next to the purple tanks. That's the compressor house. There's a liquefaction train and then the storage. And this is actually a utilization project where the CO2 goes into existing CO2 markets as well as greenhouses. Nearly there, Gunnar, nearly there. So this is how it looks in real life. And because I'm an engineer by background, I always like to show you this this one. And this actually showed the true value of modular. We started in the morning, about 6 o'clock, lifting the first column. About 6:30, the first column, that's this little silver one here, was in place. Then after a cup of coffee, the large one was put in place. Another round of coffees, the third one was put in place. And basically by mid-afternoon, we put in all the columns. So instead of having to do that over a long period of time, it just one time blocking the roads, organizing the transport from the laydown area, lifting it, and thereby rapidly accelerating the delivery. So in summary, we don't just study, we actually build. We can do that because we tested at industrial scale, which gives us a massive experience in all sorts of industries, from coal-powered fire stations, bio mass facilities to waste energy, smelters, you name it. Like others, we can't do it all by ourselves. We need to team up with partners. We're experts at carbon capture. We team up for compression. We team up for synthesis. In there, no, and Siemens Energy. Compressors already set. So we team up and we again try to de-risk as much as possible, speed up by modularization. And that was my presentation, and I thank you for your attention. Oh, you don't have to read those. Thank you.
Okay, thank you, Pim. So I think you sort of used your time so that you can take questions in the break, and we can continue. So next up is Hortense Becourt, business developer in EIT Energy. So please go ahead.
You want this?
Hortense.
No, I left it on the. Yeah.
So hello, everybody. I'm going to start with a quick question. Who here knows InnoEnergy? You can raise your hand. Oh, okay. I'm quite surprised. But I'm gonna today present you, I would say, InnoEnergy a bit. So you have a reminder for those who knows InnoEnergy, and for the other one, you have, I would say, the overview. Then I'm going to focus on the green hydrogen department of InnoEnergy. And at the end, I'm going to present you our next, I would say, NewCo, our next project. And that's the first time we present it publicly, so be kind. And this is very early stage. I'm not going to have all the answers, but very happy then to discuss with you about the project during the pause. So first, InnoEnergy, we are very peculiar in a sense that we are what we call a public-private partnership. We have been co-created by the European Commission almost 15 years ago now, but we have as well as shareholders 36 partners from universities, from industrial, I would say, sectors, and from financial entities. I can see here a few of them, like Schneider Electric or Siemens, ING as well. And we have as well, I would say, two core activities. I can imagine that the ones who knows InnoEnergy here, you know InnoEnergy as VC investors. This is one of our core business. We invested into, for example, H2 Green Steel, Attaway, FlexiDAO. We have roughly 200 startups in our portfolio. But we have as well another activity since 5-6 years now, which is, I would say, to launch, animate what we call strategic value chains. This is under mandate from the European Commission, and we are in charge of the European Battery Alliance, the European Green Hydrogen Acceleration Center, and the third one is the Solar Alliance. And in this case, we don't invest into startups, but we create from scratch, from a PowerPoint, what we call NewCos, which is, I would say, an industrial player. So we have done this in the past now. We have a quite good, I would say, a track record. We launched with Schneider Electric, for example, Vercor. We launched as well 3 years ago now, Gravity in France, Fertigy in France as well, Repono, Holosolis, and Basquevolt. This is, I would say, they are all in Europe, and the idea each time is to create one fork and then to duplicate. So now I'm going to focus directly on what we call EGAC internally, the European Green Hydrogen Acceleration Center, so the value chain on green hydrogen. What do we do exactly? We came across the fact that today green hydrogen, it doesn't work very well. I would say the big issue we are facing is the price. We have a crazy price, because when we launch this kind of project, we have like several key actors that we are going to, I would say, gather around the same table, but each one is going to take care of its own margin. So at the end, we have a price totally, I would say, off markets. So what we do is the integrated value chain. We are going to gather around the same table all the value chain actors, and each one we are going together to create from scratch a new venture, and we are going to be shareholders of this venture. At the end, we are going to have like each party is taking care of the margin of the venture they are shareholders of, and not of the own margin. I have an example I'm going to show you afterwards. So in a nutshell, we do that. I would say it works quite well because we are neutral. We are not a competitor. We are not from the sectors we are addressing. We are going to do, I would say, we are going to build the network to look for the first investors, to pick the ones we think they make sense in the sector we address, and as the CEO of Liquid Wind told, we are going to make the party happen. And we have as well, I would say, this footprint on how to take care of very early stage ventures through the VC activities we have. So we are going to hire the CEO, the CTO. We are going to take care of the team during 2-3 years. During what we call the death valley of a startup, when they are like between seed and Series A, Series B, because we are talking about like very huge project, but the first 2 years, there are 2-3 people in an offices and they have to handle everything, and they are quite alone. So one concrete example, Gravity. Gravity, they are going to produce green DRI in the south of France. I have like one figure quite that I like a lot, because you can see like how at scale Gravity is. Gravity is going to produce 1 Eiffel Tower per day of green DRI. They are now between Paris and Marseille. They are between 30 and 40. They are closing their Series A, and this is the same. We gather around the same table all the value chain actors, from the renewable producers to off-takers. Off-takers are key, as we are all telling that since yesterday. Having off-takers already on board with the right of first off-take it's the key for this kind of venture. So now, why am I here today? I'm here because we have a new project. The name of this new project is CarbFlex. This is going to be a new co for 2025. And this time we are addressing a new value chain that we are going to launch, the biogenic CO2 value chains. A couple of slides just to show you a bit, I would say, the background, but I can imagine that you all know perfectly. The CCUS is key to is a key lever to reach climate neutrality. The Euro-industrial carbon management strategy requires 450 million tons of CO2 captured. This is huge, and this is going to be like I would say increasing in the next couple of decades in order to reach out the targets. And this will enable for sure, I would say, the production of fuels, concrete, methanol, polymers, and so on. So today we focus a lot on fuels, but this is not the only commodity we can produce with that. But we are facing one problem, and the main problem is that over the past 2 years, we were building, as several of you today, eSAF and e-methanol venture in Europe. So myself, I'm based in Spain, but French. So we have another colleague in Portugal. We have another colleague in the Nordics, and we were like screening biogenic CO2 sources, trying to complete the Tetris game of finding a plot with access to electricity, with biogenic CO2, with the right size nearby in every, I would say, every geographies. And the outcome is quite terrific in a sense that we have my colleague in the Nordics, he has like a playground, phenomenal. He has like 60, 70 biogenic CO2 sources to play with. I was struggling a lot in France and Spain with roughly 15 sources per country with the right size, excluding waste management sources. That I was able to play with. So there is like, on a geographical manner in Europe, there is like a huge disparity between Nordics and other geographies. But the problem is that the RFNBO fuel, we need it in Europe in general manner. So from this work and this consultation, we decided to launch a new venture called CarbFlex. CarbFlex is going to capture biogenic CO2 and to then transport the biogenic CO2 both for CCS and CCU. In this image, you think that we're going to capture only in the Nordics to supply the biogenic CO2 in the south and in France. This is not true. I would say the right image would be mostly this one. We are going to capture biogenic CO2 where we have biogenic CO2, so mostly in the Nordics, but if we have other sources, for example, in Spain, where we have, we struggle a lot to get RFNBO compliant fuel for the next 10 years, I think. This is as well a possibility. And there we are going to transport it and to sell it for CCS and CCU. We want to have a mix of biogenic CO2 sources to be able to have a steady supply. So we want to have for sure CHP plants, but we want to have as well a supply during summer. So having a pulp mill, for example, in the cap table would be as well, I would say, mandatory. The idea here is to, I would say, answer to several bottlenecks we are facing in Europe today. As mentioned, in the south of Europe, there is like few biogenic CO2, which is a problem. If you have like one source and you have a problem because your only source is going to shutting down for 1 month, 1 year, how do you do? You're going to rely only on one source, and you can like, you're totally dependent of one external sources. You're not like leading with. you're locked with a cement biogenic CO2 provider up to 2041. How do you do? You have as well, for example, you have a lack of biogenic CO2 in your steady supply. Carflex will be able to provide you a steady supply complementary for your first supply. And as well, another problem we were facing ourselves when building our ESAF project, from a bankability perspective, to rely on only one biogenic CO2 source, this is a problem. Banks, they are like, they see a risk, and because there is a risk. So having this, I would say, a security to be able to show the bank that you have plan B in case of shutting down, this is, I would say, something very, very important in order to secure then the other rounds you're going to raise. So as mentioned, we have done the screening of biogenic CO2 sources in Europe over the last 2 years. So we have already, I would say, an extensive view about biogenic CO2 sources in the Nordics we would like to use for. We are currently negotiating with them. So the project of Carflex is early stage, but relying on already quite some work. We talked about this project to eFuels developers in the past few months, and they were like all very interested by the solution. And we are already in an official partnership with business in Finland. A time plan where we stand. As you can see, we are here, so very, very early stage. But this is as well a good point for you because everything is, I would say, we have to draw everything. So that's the moment you can as well work with us. We want to build now the network of the CO2 sources, negotiating as well the uptake and so on. And we are at the same time building the network of the consumers, CCS and CCU. The idea would be like to incorporate the NewCo by the end of 2025 with the same approach. So this value chain approach, we are thinking about now assessing if we want a CO2 capture provider in the consortium or not, if we want a storage provider in the consortium or not, how we want to, I would say, to address the transportation, land, sea, road, everything, and if we want to have them on board as well as shareholders. Yeah, so now we are, I would say, looking for early stage partners on CCS. We look for as well off-takers of biogenic CO2 with projects in Europe. That's, I would say, the first interest would be with projects in the Nordics. But if you have projects as well in other geographies for the first try, could be as well something we can discuss. And if you have as well biogenic CO2, happy to discuss about it. But I can imagine we are all in the same situation. And that's it for me. Thank you very much.
So questions?
Hi, I have a question regarding the CCS and CCU business model that we are using, because it gives a different value to the CO2 in the long term. Go towards the utilization and go towards the storage now. And there might be chances that CCS can increase the cost of the CO2 level so high that some of the utilization people who are going to CCU can have been exposed to that high cost. What do you think that, this is something the European Union is looking towards, the biogenic CO2 not going to be used in the CCS part?
Yeah, that's a fair point. We had as well internal discussions about CCS and biogenic CO2 because this is perhaps not the best option to store in the ground biogenic CO2 when we are all looking for this commodity. But in this case, having both CCS and CCU, at least for the first years, it's going to help us to balance I would say the supply. So it helps us to have a steady supply and to be able to store it accordingly and to deliver in time to the right, I would say, CCU users as well. But again, this is very early stage and everything is still, I would say, to discuss.
Hi, good morning. Kate Cook, Transport and Environment. So I'm very interested in this push towards biogenic CO2 for e-fuels. But of course, a lot of your whole business case kind of depends on also the 2040 deadline for fossil carbon CCU in e-fuels. Like, so I would want to hear your comment about like if that 2040 deadline is opened up, what does that mean for your business case? Like if that would be the case, because I've heard a lot of critical comments here about why don't we use fossil carbon for a bit longer? So I was just wondering whether you could comment on that.
Yeah, that's a fair question as well. This is the kind of discussions we have as well with our counterpart in Brussels, since all of our projects are relying on mandates and decisions they are taking in Brussels. But from our perspective, they are not going to change their mind. This is going to happen like the same way they are telling it. So if we think that from the base they are going to take this decision as accountable, we want to move forward with the solutions we can provide in order to face these limits.
Thank you very much for this very interesting initiative. My personal understanding, but of course I may have been wrong, was that transporting CO2 was quickly raising very high costs that make it useless. I mean, to go further than a few hundred kilometers. So your whole business model here is to have a lot of transportation of CO2, a lot of storage of CO2, in order to bring the good insurance to your customer that they will receive biogenic CO2 for being paid if necessary. So why was my understanding wrong, or what is it that makes it possible to have a business model using so much transportation of CO2?
Yeah, Carflex is not going to be like your plan A. You have to still work on your biogenic CO2 source nearby your facility. Carflex is going to be a plan B, and with your plan B, you're able to, I would say, to have this cost plus that we are going to have. Now that we see that, for example, in summer you rely on a CHP plant and you need 2 months of Carflex CO2. Yes, you're going to pay your CO2 with a cost plus. It's going to depend if you need like a road transportation, sea transportation, and it's going to depend as well on the transportation mode. But definitely there is going to be like a cost plus with the transportation. But as plan B, this is something we are assessing with the fuel producers, and that they are willing to pay for this bankability and so on.
Even if everyone has the same plan B, I mean, summertime, for example, because of seasonality of the CHP plants, there may be some kind of big usage of biogenic CO2 for plan B in summertime, no?
Yeah. We can have like this peak in summer, but it looks to be the case, and you can have as well a rundown of your pulp mill in Spain in November, and yeah.
I'm Martin next. Yeah. Robina Gerling from NOV Germany. Hi. 2 questions. The previous speaker, Finn, said he estimates the readiness to pay at €300 or dollars. I'm not sure per ton. Do you agree with that range? And second question, How about, we just discussed the transport of the CO2, how do you see the discussion of CO2 pipelines within Europe developing, and is there enough attention on it? Is it progressing fast enough? Where do you see this?
Yeah, for the first question, I can't answer you. I can't disclose anything about the prices we see at this stage. And regarding the pipelines, the TSO's pipeline and the refurbishing they are doing, that's totally something we are assessing as well. We are in touch with TSOs in the Nordics as well as the ones in France and Spain to see how we can make partnership as well. And this is the kind of project they are totally as well interested by.
Is there enough political attention on this?
That's a good point. There is an interest, and there is I would say, we are providing a solution to a problem everybody's facing in Europe. So if we want to reach out to the mandates and we want to still focus on biogenic CO2, we have to face solutions. And so far, we are presenting the biogenic CO2 value chain in Brussels, and they are, I would say, quite interested. So let's see how they see it.
My question is, maybe similar. So is it, and I'm not sure if you've been asked already, but does Refuel EU or RED III need to evolve? Is it in keeping with it? We've just responded as a consortium to a September deadline for policy and governance development for Horizon Europe project. So it's of course, think about energy supply for the future for mobility as well. So it is looking into what policy is, what we need to basically make for the future. How does your project completely fit with policy at the moment? Does it need to, are you encouraging policy change due to it, and how does it sit?
What do you mean exactly? If our... Can you reformulate?
Let me. Does policy need to keep evolving? Because I'm also now starting to work in SMRs too, as part of nuclear power for e-fuels for the future. So we've written SMRs and nuclear energy into the supply chain need for this policy proposal. So that it does need some policy information, but obviously, does this completely fit with current policy? Presumably it does, but what do you see with policy? Do we still need to involve RED III, Refuel EU, or is it satisfactory at the moment?
I'm not sure if I get it, but I'm gonna try to to make an answer. We are building that because politically we have all those mandates, and that we have in Europe a lot of differences between geographies, and everything is very, very slow. And because we have been in your shoes building an ISAF project, so we know well that getting finance and so on, this is very tricky. So yeah, we think that we are totally, I would say, aligned with what we see from Brussels so far. And it looks like to be the case at this stage. So we can take it during the pause if you want.
Okay, I think that's time's up. So thank you so much, Hortense. And we have our next speaker coming up, which is Dr. Asif Ansar from the German Aerospace Center. Go ahead. Thanks.
All right. I don't have a slide to tell you who I am. Asif Ansar is my name, but I would rather like to start with this 0.2%. And you will wonder, what the hell is that? And if I tell you 0.2% is the whole surface area of all the cities compared to the whole Earth, yet are the driving force of our economies. But there's something, this doesn't make sense in an e-fuel summit, right? The 0.2% is also the amount of renewable methanol in the total methanol market today. Only Europe consumed 10 million tons already. Shipping industry hardly take any now, but I take it. shipping industry is up and coming. 10 million tons only in Europe, 0.2% of e-methanol. Probably many reasons to it, but one reason, just to simplify it, is this one. August 2024, $689 per million ton, metric ton, 472 in EU, Amsterdam or Rotterdam, 301 in China, steam reforming, put the CO2 out, get the methanol afterwards, methanol synthesis, CO2 based, and the things are done. We want to make it renewable. Liquid wind, other peoples want to make it renewable. The challenge is this. We're looking at $1,310 per metric ton for the price. 4 times the price. This analysis is not a small scale analysis. We did a lot of number crunching around that for many other people. Looking at, you have been seeing the whole day yesterday and today, that electrolysis appearing like this box. And then a synthesis reactor trying to make sense. Will we be able to sell it? Somebody will catch it. Can we do that to actually come down with this price? And mind it that H2 to methanol efficiency is rather high, 81.5%. The overall CO2 efficiency, when we talk about the renewable methanol, 93.2% CO2 efficiency. Where is our catch? How do we do that? It is the hydrogen generation efficiency that we have to look at. And this is the cost of hydrogen. So the tall building, we have been doing almost 10 people in a couple of projects, only looking at the cost analysis. We went down to the power electronics stack and component of each electrolyzer and the synthesis just to get those numbers. And see every cost here and see every cost there. And they are negligible. There's one thing and one thing that need to be addressed, the elephant in the room. This is my dear blue column. It's the hydrogen or the green hydrogen. You solve it, you solve the methanol problem, at least the cost problem, not the manufacturing problem. That still has to come. And this is not a small scale. We're talking about large scale calculation that has been done. Hence, intensification. I'm Asif Ansar from German Aerospace Center. And what we try to do is to study and to build intensified processes for e-fuels based on electrolysis. And today, I'm going to talk about only one thing and one unit which is done and dusted, which is 120 years old, but holds the key to the green methanol. I'm trying to do something that is only a box in our sites. I'm trying to intensify the electrolyzer. Can we gain something there? That's exactly what we're trying to do. So our department, my department, is working on enabling electrochemical technologies for decarbonizing hard-to-abate transport. Shipping, aircraft. We have a flying demonstrator, 2-passenger and 4-passenger aircraft that we're flying with. We get the certification done. We have a ship. We met some of the people in Luzern last year where we talk only about shipping and how methanol and other fuels can decarbonize shipping. But today I'm going to talk about the second point, the green hydrogen and synthesis. We start from very much the modeling and really the system modeling goes into the experimental reactors, the so-called humble stacks and components testing and development, go all the way on the transient capabilities of a plant. Why do we choose Siemens Energy PEM and not alkaline? Because alkaline cannot transient. Can we do something about that? So there is kind of the transient capabilities we try to study and develop. And then we go all the way in developing what we called the next in line prototypes. We put them together. We run them, we test them in our laboratories, but we take them out in the field. 100 kilowatt to 500 kilowatt, that's the sweet spots we develop and we leave it there. But we work all this line with the partners who are working, OEMs, the plant manufacturers who are working with us, that this process is then taken by the industries. We are not for profit, but these technologies need to come into the market, into the industry. All right. I'm going to talk today electrolyzers, but only two type of electrolyzers because there are many. Alkaline system, the most legacy, most established one in the market. And probably everybody in this room assume that, this is already done and dusted deal. And I want to provoke the idea that there's probably something more to gain from it. And of course, the highest efficiency one, the solid oxide operating at high temperature, but also the most expensive one. What will we gain? And then, of course, the PEM, and I will talk through, we're going to put a lot of numbers, and I'm going to put a lot of drawings. It will be very technical, get technical. So if you get, if it's getting, too sticky, please raise your hand and I will go soft on those things. All right, so these are the two things, and we start to realize that how do we do it to go from 1,000, the ultimate aim is one concept, not only on paper, but really a proven concept in the laboratory and in the test field that we do not have to pay $1,310 per million ton, metric ton for methanol and come down to it. And so we do go about doing three types of intensifications or improvement, if you may like. The voltage intensification, the voltage, these are electrochemical devices. They always operate at a voltage and the current level. Voltage means efficiency. Voltage means the electricity you consume. Low voltage means lesser energy per kilogram of hydrogen required. All we want is an electrolyzer that is operating at lowest voltage possible. Then pressure intensification. Electrolyzers, as we know, most of them operate because for electrolysis OEMs, it's easy to have or easier to have a non-pressurized system. Methanol requires pressurization. And typically this pressurization happens, so some of the alkalines are typically operating at 30 bars, but methanol still will require some stages of pressurization. This pressurization is efficiency loss, capex, and operating cost. Can we get rid of that? That is a pressurization, intensification, integration. And the third one is heat. There will be a lot of heat available, but probably not sufficient to just operate as solid oxide electrolysis. Where is our sweet spot, and how do we recover the heat in order to increase the efficiency? So these are the three intensification processes that we have been looking and developing and testing in order to come to a price value that is probably more reasonable than the value we started with. Does it make sense? All right, let's try that. So we did go to an alkaline one, and one of our partners sitting here, where Bijan is in a project. Hey, Bijan, yeah. So we work with them very closely. So thank you for being such a valuable partner. In one of the alkaline electrolysis. And what we did is that we simply, by 19%, improved the voltage, simply the voltage efficiency by developing the very boring components, the diaphragms, the catalyst, the membrane, the stack design, the flow fields into them. Bijan's teams comes with us. We did it, a lot of testing of ourselves. Quite many development happened within the DLR. And this is where the testing come up. And this results in what I was mentioning, a reduction in kilowatt hour per kg of hydrogen produced. And if we look into it, the system perspective overall, this is a conventional one, the blue line, a conventional alkaline electrolysis, which will give a system efficiency with all the calculation. And if we put our new electrolyzer, suddenly we see a clear jump going from somewhere close to 55% in the range of 65, 66%. So all other losses in the system level remain the same, but only the voltage improvements allow us to get to 10 to 11% improvement in overall system. And this system is a 10 kilowatt system, a prototype, a test field. But this is what is a proof of the, when we start to now pressurize this is at atmospheric condition, but when we try to pressurize it, put a compressor afterwards, a lot of energy, all the gains that we have taken actually get lost because the compressor requires electricity. You have to compress the hydrogen. Methanol reaction requires 100 bars, right? And this energy is gone, almost gone. And then we started to do, what if we start to pressurize the alkaline electrolyzer? And that's what we did. We went to 100 bars of pre-pressurized and alkaline system that does not only have better voltage efficiency, but can operate at higher pressures, 100 bars. The reason is very simple. I mean, most of you know, it is much easier and less energy intensive to pressurize a liquid, water in this case, than pressurize a gas, especially hydrogen. And this saving is what we will bring it. So you will say, and I will take it, I'll get it also. The capex of the electrolyzer system will increase, and yes, it will. But ultimately, it's not just the capex of the electrolyzer system. We said that the most expensive part in the hydrogen production was the electricity. So what we are covering, all right, can we increase this capex of the alkaline system, but be able to still produce a methanol at lower cost? That is the challenge, right? Not to produce the cheapest possible alkaline system. So I'm very focused to the mission here. And that's why we are increasing most likely the capex by going to the very high pressures, but then this capex is returned because we are not using any compressors anymore, right? OPEX and capex recovery is done by not having the compressors anymore. That's what we did. This is a prototype built in our laboratory. If you will come to Stuttgart, I will be happy to show you. It's been commissioned. It's running right now only at 50 bar because the stack assemblies that we have available was still not qualified by a TÜV system to be able to operate at 100 bars. The overall system already been qualified. We need to run it and did all the data before we go to 100 bars. But this is the system which has been built by our engineers and operating in Stuttgart. And this together give us the high voltage intensification, but also high pressure intensification. Now, if we look at the whole spectrum of the data from different suppliers, and I'm not competing there, I'm not for profit organization, right? So all of them, so I just took the data which is available in their websites. From SOCs and alkaline, and we look into it that in alkaline space at least, and PEM has the same, and mostly they give their efficiency at highest point. So I remember, if you remember my chart from previous one, the voltage efficiency is decreasing as you start to operate at higher currents, because we're producing more and more hydrogen, but efficiency decays. Most of the people, most of the companies, of course, I would do the same if I'm the company, will operate the highest efficiency possible. I'm saying that this is an efficiency done by our engineers at 1 ampere centimeter square. And if I may say that, there's no second alkaline electrolyzer that operates at 1 ampere centimeter square but ours. So therefore, there's a bit unfair comparison. So that's what we did. And then when we do the compressors are removed, then overall efficiency of systems goes very high. So we are good. We are very good when it comes to the alkaline, thankfully, because of this intensification. But we are not as good as all that space, because that space is covered by the Topsoe guys. Rob, you guys are good, right? You're standing somewhere up top here. So all the turquoise color one are the one when heat is not available, right? So that you have to generate the heat yourself. Some of the high temperature will recuperate heat and you reutilize. But if a waste heat is available, and methanol reactors will have the waste heat available, and if this can be utilized, then overall efficiency is rather high. We are looking at efficiencies almost touching 90%. The secret is, some of our calculations says that even this high efficiencies, SOCs with the capex and with the change of degradation, it still has to catch up to both PEM and alkaline. Probably Rob will say different things tomorrow that they probably have it, but I don't know that right now. I think that's so. But I want that the system, can we do a third level of intensification where we can utilize that heat as well and develop a system that is combining both the alkaline SOCs, and that's what we did. So we take one of Rob's stack, Topsoe's stack, but also some others, Sunfire, Solidera, many others, and we build a whole pressure vessel around it and start to test them under pressurization. Can we get the same kind of gain as in alkaline also in SOEC? And we do. The pressurization is, however, marginal, but we do see that initially there's a negative impact of pressurization on the voltage efficiency of high temperature electrolyzers, but there comes a point which is typically at 0.4, after which the flow improvements that happen within the stack, within the reactor, that overcomes the voltage losses. So that means at high current, the pressurization will help. We wanted to operate at high currents. We wanted to operate at 1 ampere. because operating at high currents mean the footprint of the overall plant will be smaller. We will need smaller surface area of the stack in order to gain the same amount of hydrogen. So what we did, we went to a new system, which is under commissioning. It goes up to 25 to 50 bars, a first of its kind. The first trials will be up to 25 bars, a pressurized solid oxide electrolysis unit. The whole electrolysis unit will be sitting here. These are all the balance of plant. It's a small one. It's only we will start testing at 10 kilowatt with a capability of going to 50 kilowatt. This is innovation. This is not about a plant development that we're talking about, but this is developed by our engineers. We built it together. And these are the two things we are trying to couple to maximize the third intensification, which is the heat integration intensification. All right. So I take our intensified alkaline electrolyzers, and I take this also pressurized SOEL, and see this thing that if the heat could be maximized in order to get to the methode synthesis. Without going the all number crunching, there is the SOEC will operate good, if you remember from the first chart, if the heat is available. But many other processes in the plant requires heat as well. So all the heat that is generated by the synthesis process cannot be given to SOEL because there are also the compressors. Some of the compressors will be generating heats, and this could also be recuperated and given to the, but not all the processes, there is less heat than required. Therefore, there is a balancing between the alkaline and SOEC that has been done. And we are looking at somewhere a 70% conversion with combination of hybrid combination of solid oxide cells and alkaline electrolyzer cells. And if we do that, this allows us to reduce the compression losses. It's allow us to utilize, because any other point, then additional heat has to be brought in, which will be a negative efficiency. And at 70%, we have a balanced system where alkaline and SOEL are producing hydrogen. The heat is fully reutilized, and there's a very reduced need of a compressor necessary, right? We are looking at a system which is typically around 41 kilowatt hour, and after the pressurization, and it will go down to 38 kilowatt hour for each kilogram of hydrogen produced. Typical alkaline systems that we mentioned require at the system level provision 61 kilowatt hours for each kg. After intensifications, we come down to the 51, but we are now in the stage where we're looking at even going below 50 kilowatt hour per kg. And from ethanol, another 0.9 kilowatt hour will be required for the conversion possibility. Right, and these are the combinations of different scenarios when only one or other looks into it, and will again show you that at 70 to 30 ratios, you have the optimal plant design, and I'm only talking about on the experimental level. Right, we went on doing the whole again analysis. This was the similar way of analysis which requires our models called Celeste, very much looking at down to the component in electrolysis models, Aspen based, and then Aspen based. I'm sorry, the Aspen-based plant design, but it is Python-based Celeste models, very much thermodynamics and electrochemistry-based models that were utilized on the component level, and combined doing both the life cycle assessment as well as the techno-economical assessment of each and every component, going down from the catalyst level, electrode, membrane, stack, system, power electronics, compressor, each and every component is separately calculated and given. Quite many papers that you can see to get to know more what level of details we go into. And there we are. So if we have at a conventional level, we were starting at 1,310 US$, which was somewhere around close to 1,200 euros per metric ton. With these intensification, we're seeing today, this intensification will allow us to come to 830 to 955 at a plant level with all these, but the capex of electrolyzer system will increase, right? But overall production, the net cost of production will go down to these levels. And we expect that if these are the technologies that are going forward, by 2030, we will have a price categories. A lot of assumptions are, of course, then taken. We will come down in the range of 722 to 874 euros per. But this is all in laboratory scale. We are still far from, we are good compared to the non-intensified processes, but far from still the fossil-based methanol. So the simple case is we still need to work hard. We need to work hard in order to get at a level which becomes attractive. I do think that the carbon credit will come in and help us in closing this gap. But this is what we have achieved so far. And there are two projects which are coming out. H2 Mare, which is already ongoing. We have an offshore platform where we will be putting our e-Explore, this pressurized SOC, as well as our alkaline system will be put. The Siemens Energy is providing the electricity. We have a contract with them. They also bring in their PEM technology, and we will be operating. So the DLR team will be operating all the three systems. The downstream processes will come with Thyssen, Ude, and also the KIT colleagues will be stepping in and operating the synthesis reactors, and we will be taking care of the electrolysis part of it. And then there's a DLR own project, which is emission-free Hafen, so emission-free harbors, where we are modeling Hamburg harbor and trying to bring this intensified electrolyzers and synthesis, particularly for methanol, to be a large demonstrator. With that, thank you very much. And hope is that we will be able to increase it from 0.2% to a much larger value. Thank you for your attention.
So, questions?
Really interested in the presentation again. Thank you so much for sharing that with us. And so I'm speaking on behalf of Pyro. We're a green hydrogen developer in the UK. And one of the big challenges we're seeing when it comes to securing investment and giving kind of assurance to the investors is technical readiness and guarantees of performance of the electrolyzers. As this is a relatively cutting edge technology, how are you managing that expectation from your financiers?
Right. So we have a whole infrastructure which is primarily focused on testing. So we develop our own proprietary technologies. We also test for OEMs, for other partners, but we spend a lot of time, a majority of our time, testing whatever is developed. Before it goes out already in field, there's typically a 1 to 2 years of testing time from components to stack to the system level at different stages done. 400 square meters, only electrolyzer testing laboratories that we have in Stuttgart. And that's what primarily does get all the data, performance data, lifetime data, and special cycling data are what make us understand the overall performance before we go out in the field. I hope that answers your question. Yeah. Mm-hmm.
Thank you. Electrolysis is having a small share of hydrogen generation in the market, roughly about 2-3%. What about other technologies? Are you looking into reforming technologies and other method, or mixing and merging different technologies, heat recovery, adding solar, for instance, heat into the process to make it more viable? For the amount of hydrogen we need for e-fuel, definitely electrolysis might not be the solution.
Mm-hmm. So I think the statement can be discussed. Different people will have different opinion that if electrolysis is the solution or not. I mean, I will state my opinion on that side. Coming back to the first part of your question, DLR, besides my department, there are many sister departments that are working on pyrolysis technology or direct sun conversion of steam into hydrogen. What we do not do is steam methane reforming. What we do not do is fossil-based technologies. Even if it's a biogenic, or again, the legacy technologies, we do not do. What we do is electrochemical technologies, what I'm taking care of it. Therefore, electrolysis was the topic today. There are other sister departments who are looking at the pyrolysis because we are very much in the depth of the technology, and one department cannot cover all. So there's other departments which coming, the expertise of those are looking into pyrolysis technology or direct steam reforming technologies. Yeah.
Okay. Thank you so much, Asif.
Thank you.
So this sort of ends the first session of today. We will now have a half an hour networking and coffee break. And then we reconvene here at approximately 11:25. well, there's some out, but I think we just go ahead. And the first speaker now is Anders Nimgård-Schulz from Ramboll.
Yes, thank you. So, welcome back. I hope you all have enjoyed the day until now, and also the day yesterday, and the break as well. Got a cup of coffee. It's always a hard job to start just after a break, and I know also that part of why we are here is actually to network and discuss between colleagues. So that is, of course, also understandable. As introduced, my name is Anders Schulz. I represent a company called Ramboll. I will tell a little bit about the company later. I will talk about the bio and e-fuels pathways, because I think there's some good learnings in that, challenges and perspective. I will not necessarily take it in that order, and I will only put it in a European context. Ramboll is traditionally working in the technical space. We are a technical company, but I have actually tried to step back and try to look at the business here based on the discussions I have across the value chain, because that's one of the benefits of being a consultant, that we talk with many and without a lot of interest. So I will try to convey some of the observations that we have done during the development of this market or this space, which is not that old. But first of all, I think I will have to press this one. Yes. Ramboll is an independent architect, engineering and consultancy company. We were founded in 1945, so we have some years experience right now. We are owned by a foundation, so all the money we earn go back to the company, or we invest in something that support our visions in the society. It is also so that we are completely technical agnostic, so we are not linked to any technology providers at all, and that provides us with a great opportunity to be completely independent. We have 300 offices in 35 countries, and we are 18,000 employees around the globe, so have been some size. We are active in these markets, and I would say all of these markets are crucial for creating green fuels. So, you know, without permits, without energy, without infrastructure and water, there will be no projects. So we basically cover the whole value chain in our companies. These are the sizes of the different units, but that's not so important. If we zoom in on what we have done in energy, then we have 15 years worked in energy solutions, and we are today 2,000 out of the 18,000 that are working specifically with energy transition projects. And we have to date executed more than 200 PTX and hydrogen projects since 2022. So that is a little bit of background why we are here. But I will actually start with the perspective of the business, because I think some said it also yesterday. Maybe there was a bit of depressive mood in the beginning. Things didn't kick off. But if we look at the perspective of the business, what does actually the numbers say? And we have looked into in Ramboll in what we call the hydrogen hierarchy. And that is because we don't think that hydrogen should be used for anything, everything. Not anything, but everything. There's some areas where we actually today already have better solutions, and we should keep away from that. Maybe in the beginning of the what they call the hydrogen hype, there was a little bit that everybody said, okay, we have a problem, and people raised the hand and said, hydrogen was the solution. I think we have come across that period now and are more realistic what it should be used for. But you can see when we move higher up, that is where it makes benefit. And if we look for fuels, then shipping and aviation is two areas where we think it makes really sense to look into hydrogen and hydrogen derivatives. It's also chemical and refineries, as you have seen, and fertilizers, but that's more industry. So today I've focused more on the shipping and the aviation part to say, okay, what does that create? Because that's real fuel. I think we also heard some presentations yesterday talking about transport, but they are further down on our hierarchy, and where we think we should consider carefully, because there's actually already some good solutions out there that can be used. So if we look into this one, then this has been said many times. We have a lot of things already on the greenhouse gas reduction targets in the EU that actually set some quite tough targets on the business. I mean, we have these 2% in 2025, that is next year, and then that goes up to 80% in 2050. And the same goes with aviation, 70% in 2050, and also some requirements on a growing share of ESAF, which is relevant for this fora here. So we have done a little bit of numbering. What can that be translated into? And people have different numbers depending on what preconditions. But I don't think the numbers is the right thing to discuss. But if you look at the size, it's huge. I mean, it's huge amount. Of course, not in 2025, which is next year. That's the blue bar. We don't see any ammonia in 2025, but just see what happens up until 2024. And the same goes with aviation, where we look into SAF demand. I mean, it's also a huge amount. If I was a business development, now I'm not, I'm a consultant. So, but if I was a business development, this will definitely be positive. I would be exaggerated about the numbers, the market that is created here. It's really good opportunities. The thing is that if we look at the regulations that we have in, they are getting the amount needed to create a market. It's not something that should be created. It's already there. It's stated by the politicians that we should go this way. So we don't need to talk about if there's incentives to go in that direction. It's already in the RED II and RED III, the Fit for 55, the Refuel EU. They all provide really, really good foundations to create a market. So that's really positive, and that must be especially positive for this forum. So if we look at pathways, and now we come a little bit into biofuels as well, because there's a link between E and biofuels. So this is basically how we can create these sustainable fuels. They live in some sort of triangle, and we are focusing on biofuels. And I think Mr. Bloch said it really nicely yesterday. It's not a competition. They need to work together. There's room and there's space for all of them. I mean, if we go all in on biofuels, we will do something wrong. It will also be wrong if we go all in on e-fuels at the moment, because it's not there yet. So they live in some sort of symbiosis and need to find the balance, but there will be a need for all of them. The reality is, when we look at it, that this is something that we have made. It's quite complicated, I know that. But this actually collects both biofuels and e-fuels on the same chart. And if we look at it, then this part is actually the Power-to-X, or the e-fuels part. And if we then add, then we have the bio and waste-to-X on the process part. So there's an overlap. And also in the last end of the technology chain, they actually use common technologies. And why is that good? It's always easier to develop one technology path than several technologies. What investors they're looking at is technical readiness level, and of course commercial readiness. So if you can have high values on both the commercial and the technical scale, then you can make things larger. You can scale up. You can optimize operation, and that's a benefit if things work together and not separate. We also have the issue that if we look at Power-to-X, At the moment, we are talking a lot about fluctuating prices, fluctuating influx of power, etc. It's not really stable production, but if you combine, then you can get something that is more stable. Because the market we are looking at, the sustainable aviation fuel market or the sustainable fuel market for shipping, they require that fuels are available. They cannot live with a supply that fluctuates with the wind or the solar. They need a steady flow because they have commitment and obligations. So that's also why it's important that we recognize there's actually a synergy between the two the markets and the two technologies. So we should stop talking about competition, but rather see them as partners in the development. I talked about the technology readiness and the commercial readiness. So how does that actually look like? Is that one of the challenges? It could be, but not if we look at it. I think we can always discuss if some of the numbers should go up and down, and I have grouped them a little bit here in the different pathways, not to be too long a list. But in reality, a lot of the technologies, they have a high technology readiness level. It's not because a lot of new things need to be invented. It's more the commercial readiness index that are low. They're not going to the same level, so the commercial readiness index is only for 6. So technologies with 4 to 5 is quite developed, but a technology with 1 is of course not. And investors in the market and users, they need both indexes to be high in order to call it a commercial viable technology. But it's good to see that the technology is ready from a technical point of view. It means that that's not the issue. The conclusion is, if we look at the business from the outside, is that the technologies, they have high TRL, but they have little commercial use. And that's something that needs to be worked on to get more commercial use of the technologies. But it's not really a challenge because the technologies are there. Yes, we saw a fantastic presentation before. We can optimize. We have still a lot of improvements. That's what is in the commercial readiness level, that we actually improve the technology, that we get it optimized, more commercialized, etc. So that is natural that you need to go to that development. But both the incentives to create a market and also the technologies to fulfill the market is actually there. When you look at it from the outside, that's not really a barrier seen from our perspective. So then we have what we call the contractual dilemma, and many have talked about it yesterday also. The first thing is that if we look at the shipping, when you talk to the shipping business and the aviation business, they do extremely short-term contracts today. They do. I mean, a lot of the companies that I have talked to, if they can get half a year contract, they're quite fine with that. They have a trading department, so they optimize on that. Especially when we look at aviation, it's a quite easy entry business. Any one of you can rent planes and start on basically an airline. You will not be the same size as Lufthansa tomorrow, but you can actually start. And how are they operating? Yes, if we go for the cargo, we see much more biofuels and sustainable fuels in the cargo because there's companies that actually can afford to pay a premium price. So today, the contracts in sustainable fuel are more for companies that want to make sure that they have a green profile. Companies like LEGO and Novo from Denmark, as an example, they do that. But when we go to the passenger traffic, what happens? You have all traveled down here today, I assume. So you go in on a portal, you get a list of possible slots for traveling down here. It starts from what? The cheapest. And then you go down and select which time fits you. And But as soon as you move down, then you already know that now I'm not taking the cheapest one. Very few people, they go further down than maybe number 3 and number 4. And then they select the ticket. And since they have not selected the cheapest one right now, they think they have already paid an extra premium. But you should also make a little check mark to say that I want to offset my green emissions, or I want to pay for some green fuels. But people think they have already paid enough because it's not the cheapest ticket. So we have a system, we have a society that's built on that we always buy the cheapest things when we enter into the business. And that's the world that the airline companies, they're living in, they are facing every day, that they can have an empty seat, but the seat on the competing airline can have the passenger. The same goes with the container. I mean, they sail on the same route, so you can just place your container in one place or you can place it on the other place. Now, is it a problem with the green? No, but if you can get the green container from 2 different shipping companies, but for a different price, then you will select the cheapest one because you're still green. So that's why it's also important for green ship companies to get the right contract, because they're competing in the market and they're competing on marginals. And then we have the investment. We have heard it, you said it, Claes, this morning as well, that long-term offtake contracts, and I can also hear it succeeds for some, but it's not the majority. And what you didn't mention, Claes, this morning when you mentioned the Flagship 1 project that Ørsted, they abandoned, that was actually that they didn't only abandon the Flagship 1 project, they stepped completely out of green fuels. They also closed down the Green Fuels for Denmark project that actually received IPCEI funding with the same argument that the market is not ready to take the product. And we think that this is the key part. That we say, because there's stated requirements in the EU regulations that they must use sustainable fuels, then they will also take the risk and change the way they're dealing and trading today in the system. But what we don't know in this fora here, we have touched upon, we don't know the size of the penalties. That's one thing. But what if the amounts are not available? Will the government penalize someone that have not fulfilled the requirements if the means for fulfilling the requirements are not there? I don't think so. That would be unfair to the business. So, of course, then they will apply. That's also what I hear when I talk to them. But they need to be able to do it on commercial terms, so they are not out of the business tomorrow. And that's why we say we lack an instrument to bridge this gap. We need to have something so that the off-takers can still work on the short-term contract that makes sure that they maintain the business. And at the same time, make sure that we have the developers that can bid into the market on a long-term stable conditions in order to get the project financed. And seen from the discussions we have had, it seems difficult to get the business together on that point if we want to make the revolution which is needed in order to supply all the amounts I just showed on the first slide. And that's why I think it's important, and now Mr. Bloch is not here today, but I say it's not only to talk to the EU politicians about reinforcing the requirements, the stick, which is the penalties. It's actually also very important to understand the other side of the table and see how can we lean forward, who can be in the middle to bridge this gap. And I think that's an assignment also for the interest organization of this one, if the business should continue. That's the key challenge. It's not technical. It's not because the market is not there. It's to bridge this gap between the risk profile. It has been said many times, but there needs to be some instruments in between to actually balance it. And why don't they want to go into these long-term contracts? Yes, I have said it before, it's because of competition. I guess I can see a lot of people here that's as old as I am, so I'm not offending anyone. But I guess you can all remember what people said about solar PV. It will never fly commercial. It would be hippies having a few panels on the roof. That will be it. Today, it's the cheapest energy source. It has happened within the last 10 years. So now we ask a business to commit to something above 10 years, 10 and 15 years. They should basically predict the future to stay competitive if they're going to bid, or if they're going to enter into those things. And I think that's key. We cannot even predict, the banker said that, the inflation in 2 years' time from now. But the uncertainty on long-term contracts, we still need to control. So this is actually the main challenge. Someone needs to make sure there's something in between that can bridge the contracts. And then we have all the other things that are from the outside that we cannot do anything about, inflation, macroeconomic environment, geopolitical tensions, some slow approval process and consenting timeframes. That's something we can address. Others can do those things. That's also from the outside that actually influence the energy market right now. I think before, when you went out and went for capital, then the interest rates were quite close to zero. Today they are higher, so that's also is a challenge for the business. But I think that can be managed because that's equal for all. So if we make the conclusion of this, then the legal frame actually support a market. Both electro and bio pathways are feasible and have overlaps, so they actually support the development. The technologies are sufficiently developed, but we need the commercial maturation to scale up. And then a number of global events challenge the development of the market right now, especially the geopolitical, but also the financial market. And then the last point, which I think is important, some sort of instrument that can bridge between the need for long-term contracts and then the short-term requirements in the market for those that are competing internationally and are trading on very short-term contracts today. And that was all for me. So thank you.
So questions?
Hi, it's Michael Birmingham from Delta Energy in Ireland. Have any alliances emerged, kind of fuel purchasing alliances to try to address this issue?
I think they have not, so to speak. I think there's different interests. If I sit together in the same room where airlines companies are here, they say, oh yes, we are going to buy the fuel if it's there. They are quite open about the contracting form and the volatility of the business. But I have not been really discussing solutions in that term.
Hi, it's not really a question, it's more a reaction to that point. I'm not sure if you're familiar with an organization called H2 Global. They're trying to tackle exactly the challenge that you're speaking about.
Yes. Yes, and we know there's different parts that are looking into this solution here. Very much, very glad you say that. And as we also said, the Hydrogen Bank, etc., is something that works in that direction. Martin from Acadia also mentioned yesterday that the Danish, there's also some discussions going on in Denmark. But I think if we should fly on a European level, it's important that it gets a really big foothold and get support from the wider industry on both sides. And that's another comment I would like to say also, that it could actually have been really, really good to have also some representative from the off-taker side to this conference to get more kind of dialogue on that part. Because I'm not representing the airline companies or the aviation industries. I can just step back and see some of the issues and put something on the table. But in reality, it's something that needs to be developed by them. And they should also be interested in the e-fuel and participating. So that could actually have been really good. Because otherwise, I think we will just agree on between each other and everything is kind of perfect from our world. And it's good to be pushed a little bit. Good. Okay, good. Will you come into some of these things or?
This is my first e-fuel conference where I've been in bio-based stuff, so that's why, yeah, I'm going to discuss the case of Norwegian Airline and Norwegian Armed Forces, and later I'll present the case of Norwegian Armed Forces and Norwegian Air. So yes, I'm here from the architect side, and I'll discuss later. So I've actually written some notes from your presentation, and I'll describe what has happened in contracting between the Norwegian Armed Forces and the Norwegian Airline. So yeah, I look forward to actually doing that.
Happy to hear that. Look forward.
Okay, thanks. I think time's up. So now we go to the next presentation, which is Leida Genk, if I pronounced that right, from the Port of Rotterdam.
Yes, that's good. Yeah, okay, thank you. There we go. And it was perfect pronunciation, by the way, thank you.
Thanks.
So, hello everyone. As introduced, my name is Leida Genk. I work for the Port of Rotterdam as a business manager. I'm focusing on the alternative fuels and chemicals. And today I want to show you something briefly on how we see the energy and the feedstock transition, how we see the projects developing, and what we need to achieve those projects. And I think if you're a bit later on the second day, you already see a lot of subjects happening, and a lot of people mentioned a few things that I want to show here as well. So I think that shows only that we are on the same path and are on the same road here and doing it together. So first I want to show you the purpose of the port. We are saying we want to connect the world by building tomorrow's sustainable port. And that doesn't mean only that we want to improve as a Port of Rotterdam itself, but we also believe in really working together and working with other ports in Europe, but also across the world. So also as the port of, someone already mentioned, the port of Pecém, we have some shares in it. Same goes for Oman, but you see that we're also engaging in green corridors with other ports throughout the world where we can just work together. I want to share something quickly on the role as a Port of Rotterdam, or as a traditional port versus the ports that we are transitioning into. Because I think everyone here knows what a port does. Vessels come in, containers come in, and they go out again, right? So that's the only thing. Well, you see that that's a bit more traditionally what we used to do, and now we are going into a bit more the matchmaking side, because we basically earn our money in two ways: the vessels, the 130,000 vessels that are coming in every year, and we are landlords. So you see that there are around 3,000 companies in the port area. There are clients, and it's the industry, it's startups, it's very large companies, it's everything all together. My role, and my colleague is also here, you see that our roles kind of changing. We're also evolving into a new role, which is matchmaking. So we funding, or maybe you need a co-siting. Maybe you want to share your utilities with another company, or maybe you want to create a whole joint venture with another company, and we can help with that. So we are really looking into what is it that you need from us, and we will make do. So that's what I'm always telling my friends, because they never understand what I do for a living. I said, well, basically I'm a concierge of a very fancy hotel. That's what I do in the port. I'm not there to earn the big bucks immediately, but we are accommodating for everyone. We are we have very nice services that we can add to what the traditional port is. A bit more facts on the port itself. It's 42 kilometers long. For the Americans here, it's 26 miles. We have a few oil refineries, 5 of them, petrochemical companies, bio-oil refineries. We also say that we are the biggest bio hub of the world. That means that we have a lot of biofuel production, but also biofuel imports or oils. Does anyone here want to guess how much of the whole European energy consumption flows through Rotterdam? An estimate. Can I see some show of hands? 5%? Higher? How much higher? 30, 40%. Well, that's too enthusiastic, but I love it. Now it's 13%. 13% of the European power of energy consumption flows through Rotterdam. About 1/3 of German energy consumption flows through Rotterdam. It can be either in solids, in fuels, in gases, it can be everything. And it goes through there. It comes in via vessels or via containers, via trains, via inland vessels, around 130,000 of them in total. And you see that we are also the largest port in Europe, I think, and the 11th port in the world. The top 10 consists, 9 of them are Chinese ports, and 1 of them is an Australian one. So when we're looking into the energy transition, everyone has their own energy transition department these days. We have it as well. We are around 30 people working on this very heavily. So we have divided into 4 groups, 4 pillars, where we are focusing on the infrastructure, new energy systems, materials, raw feedstock materials, and a fuel system transition, and also the sustainable transport. You see that the first 2 are also very long-term projects related. So the second one, new energy system, is mostly also focused on hydrogen. I call them the hydrogen team. They do much more than that, but my colleague Duna is also here. So if you have really ammonia of hydrogen-related questions, feel free to ask her. And we also have the raw feedstock and the energy transition team, which I'm a part of. And together we have a joint ambition to reduce 55% of the CO2 emissions by 2030. And that's with regards to 1990. The thing is, however, and I will show you that in about a few slides, is that these emissions that we're focusing on and that we want to reduce, it's not a very hard goal, because it cannot be our goal because it's not our own emission. As I mentioned, as the Port of Rotterdam, we are landlords. We do not own the projects or the companies itself that are there. And these emissions are from the companies. So it is for us, sometimes can be very difficult to have these ambitions because you have a bit of influence, but not that much actually, because it's a company strategy and what they're doing. So that's why I said I'm a concierge. You're really trying to find very attractive, sexy ways to get them into that energy transition. Some of them have obligations, they have mandates, and some of them don't. So you really have to find the sweet spot for them to hopefully not invest too much of their own CapEx, but perhaps a bit, just so they can go into the energy transition as well and reduce their emissions. It's a very, very exciting role, I can say. When we're talking about the energy transition, and I think Rahul from S&P already showed this a bit yesterday, there are different pathways into the energy transition. Very traditionally, when you're talking about the transition, you're talking on the left side, the yellow side, which is the electricity, the electrons. They are coming in, they're going to a system, and then you get some electricity. Maybe you can get them directly into a hydrogen electrolyzer, whatever. And you will get some hydrogen you can use directly as a feedstock, as a power, or you can transport it to the mobility and they can use it, or you can maybe use it as an import of input for the low carbon transition. So we are also focusing, and that's what we are focusing on in the pillar 3, is the carbon transition. What you want, or what you see is happening, is you can get CO2 and biomass and waste. You can use that as an import, as a feedstock. It goes through a system, and you can get some fuels, you can get some chemicals or plastics. In an ideal world, you will use those fuels and plastics and chemicals, and the residue, your waste, it will be your input again. It doesn't always happen like that, but you see a lot of companies are getting much more creative these days, and they go into the transition looking at it that way. There's also this part of circular economy, which is a bit more on the building materials, the metals, critical materials, batteries, and you see that's a whole own mechanism, but it's also just as important. As a Port of Rotterdam, we are focusing on all of it, and you see that not every part and every feedstock or every technology is developing as quickly, but you still need it. These are the numbers of our production in 2019. So in 2019, we produced in Rotterdam approximately 42.4 megatons of chemicals and fuels, fossil ones. And like I mentioned, we have the ambition to have 20% of those renewable produced in 2030. In 2022, we already had 2.3 produced in Rotterdam physically. And in 2030, we have the ambition to have that 20%, which comes around 8.2 megatons. A part of it, that's naphtha, bio-naphtha, and part of it is fuel. I think someone also already mentioned yesterday that naphtha can be, or is a byproduct of biodiesel production, right? I see some, yeah. So that's what we are seeing in Rotterdam as well. So a part of it is already being produced because we have some biofuel production facilities already there. Those are the ones in white. So that's Neste, Alco, Viterra, and Kola. I'm sorry, this is a bit of an old slide. Kola has changed their name from Kola to Kane, but or Chain. Never know how to pronounce that one. But so there are a few biofuel production sites already there, and they also have their own byproducts, which is also categorized in that cluster. This is, I think, a lot of them here are producing SAF. So some of them are producing biodiesel and then converting to SAF, or they're producing SAF directly, or they want to do it because the white ones are already there, and the yellow and the orange ones are already planned, or FID is already taken. Some of the production facilities has already started with producing, how do you say that? To produce the location already. They're already digging in the ground and they're setting up the place, and others are still in pre-feed or feed phase. But if you're looking here at the volumes and what they can produce together, the total amount, it comes around to 6.7 megatons. So the 8.2, if you remember from the previous slide, we're already getting there, and this is not even all the clusters or all the fuel projects, because there are a few in the funnel along the way. However, I'm sad that I cannot announce them here already. I would have loved to, but you see that there's a lot of development happening. So just a very small dive into these projects. Neste, as I showed previously, they are already producing, but they also have announced that they're gonna expand their production facilities. So this is, for the people who know Rotterdam, this is the Maasvlakte, the very, very end of the 42 kilometers. And at the beginning here on the left side, that's where they're already producing HVO. And down there, They're at the moment building a facility to produce SAF. Another project which has been announced is UPM. UPM is a Finnish company, and they want to build a production site where they can make SAF from wood-based materials or wood-based waste products. But we also see some companies who are saying, wait, we went a bit too fast. Let's hold up. And that's what happened with Shell. Shell is building a HEFA plant in the Port of Rotterdam. They have on their own site at Pernis. I've already discussed this with some people here, but to be honest, they've already started designing this whole project and their plans so many years ago, I think 10, maybe 15 years ago. So what you knew then is different from what you know today. So when you design a plant today, it'll be much more efficient or maybe differently designed than back then. So what we see now, they are saying technical difficulties are blamed. I think they're I think they're pausing to see what they can change or what they can do to improve the plans. So they have paused, not stopped with the plans. So we are expecting and hoping to see continuation of the project soon. I want to take you quickly also to the transport, because as a port, like I mentioned, there are 130,000 vessels coming in every year. And those vessels, they're going into the energy transition as well. So what you see is the order book for new vessels, new build vessels. Some few years ago, it was LNG was in the rise, and then it kind of stopped because methanol took over. And then methanol had a small rise, and then that stopped, and now LNG is back on the road again. No pun intended. And what you see happening is that a lot of companies are kind of experiencing the same difficulties, which is they don't know what to do. They're experimenting with a few vessels buying on LNG, a few vessels on methanol. They're looking into ammonia, maybe they're even hydrogen. You can see a lot of things are happening. On this picture, you see the Laura Maersk from the company Maersk. And this is the first methanol vessel, container vessel in the world. This was a picture taken in Rotterdam when it was just launched and was on its way from Singapore to Copenhagen. It made a pit stop in Rotterdam to bunker green methanol. So when you're looking into the transport sector, what you see is that there are some different pathways towards the multi-fuel future. This I very briefly explained before as well. You can get your energy from electricity directly. You can get your biomass or your waste product and go to a refinery and you have your biofuel, or you can use your fossil. You can store that on a very different ways, very different mediums. It can be, you can transport everything back to hydrogen. You can do it in a methanol, LNG, fuel oils. You see that everything is happening actually. And that's also the fun part of being a port, because every company here, also literally here, has their own view on what the future will look like or should look like. And from the port, we have a view from a step back, and we can see everything happening, and everyone has their own ideas and developments and believing in their own product, which is very, very good. And we always stimulate that. But that's why we should also look into the future as a port and be prepared for everything that's coming, which also means that there's this whole chain of developments happening. So you can go from different types of storage, liquids or gas, to how you're going to bunker it, how you're going to charge it, and then it goes to different modalities. So it can also go to trucks, can go to rail, can go to inland shipping or to marine shipping. Charlie from Lloyd's also yesterday spoke briefly on the port readiness. They were, I believe, looking into how ship owners are confident in how far and how ready the ports will be. It depends on what you're doing. I think if you have the projects themselves, the production facilities, obviously we have space for that. You can come and we can produce it. But ship owners also want to know if they can come in Rotterdam and bunker their fuels, their alternative fuels. So looking into technical readiness, we have kind of copied it and made it to port readiness level. This is not projecting how technical ready a ship is, but really how the port itself is ready to bunker these fuels. And what you see for these fuels, for the procedure and permits and everything, it really doesn't matter if a molecule is green or gray or black or blue or whichever color you like. It's really on the molecule structure and what are the specifications. So for biodiesel, LNG or LBM, liquefied biomethane, you see we are already fully integrated. We've been doing that for so many years already. It's no big deal. You can do that immediately tomorrow. For methanol, like I showed you a few slides ago, we have already bunkered methanol a few times now, and you see that's going quite well. And we are now at the level 8, which means that we have seen and we've proved it can be done. We have done the permitting a few times, the procedures go through, and now we are preparing to be ready to be fully integrated by the end of this year. For ammonia and liquid hydrogen, it's a bit further, I think, in timeline, and that's okay. For ammonia, we're looking into doing a pilot bunkering next year. Not sure on the timeline which month, so please, but somewhere along next year should be happening together with the consortium, I believe. And then liquid hydrogen is also happening, but you see that's happening in much more smaller groups or smaller vessels. So that's more focused on, I think, now for initial phase and in the inland vessels, because those are easily modular designs, and you can just change into a hydrogen tank on board, and you can start with your experiments, with your pilot phase. You need a whole classification and IMO regulations, keeping that in regard, obviously, but you see that we are also helping there and looking into what the policy can be done. So when you're talking about what is needed, I think everyone here has already been talking about it. So this is our regular, very regular broad slide on it. So what's necessary? It's about policies, about availability, incentives, and everything. And the previous presenter already beat me to the punch, but I'm always talking about the carrot and the stick. So we're a lot of us are talking here on the stick. So what we need policies, we need permits, we need rules, regulations, we need the government take the lead. But we also believe in the carrot. So we are looking into what can we do as a society, as a group of investors, as a port, as the Dutch government or European Union, can be everything. So what can we do more than just wait for the policies to happen? So we're always looking into the carrot, maybe investing opportunities, maybe developments, maybe bringing companies together, matchmaking. So we are looking into that as well. I would very much like to thank you all for your attention. And if you want to contact, please, those are my contact information. Thank you very much.
Yes, then we open for questions.
Given the port readiness that you showed, how do you explain there's no e-LNG projects developed? That's with the number of methanol projects being developed.
The port readiness is really on the bunkering side of those vessels. So the port readiness level shows if you can bunker in Rotterdam already, ship-to-ship bunker. It doesn't really show or mirror anything on the project side developing. Regarding e-fuels, there are some developments going. And I think we are facing here, everyone has been facing the same problems and issues and obstacles maybe for why there are not that many e-fuel projects at the moment when you compare them to bio projects. And I think it's the same in Rotterdam. So you see the technologies to produce biofuels has been more advanced or maybe readily available, readily accepted. So that's maybe what I can share on the production project side. And yeah, I think there are some developments happening. But it's taking a bit on a slower pace, what you can see. There's one more question there.
Hi, thank you for your presentation. So I'm wondering what this matchmaking process of yours kind of looks like. Asking also as a startup that would be interested in that sort of thing, working with Port of Rotterdam. So what does that, yeah, maybe you can just kind of give like a really brief overview of what connecting companies together looks like.
Yeah, sure. It really depends on what the product is, if it's a technology or if it's if you have a license that you want to sell, or if you're looking for co-siting opportunities. Because in a port, in the 42 kilometers that I showed, you see that there are also a lot of we don't have that much big space available anymore. It's been pretty full. But you do see some companies that are already there. They have some lots available on their own places, and perhaps. I just talked with a company who has this product that they're using. They're using waste material. And I found another company who has this waste material and they're just disposing of it. And they're paying to get rid of it. So that's a very nice example. I think that you can matchmake those two companies because one is using the trash of the other one, you know? So that can be an option. It can be an option of having a startup who has this technology. For example, bioplastics, it's always a very interesting one. And then you can find a plastic producer or maybe the base product of it. And you can ask them, hey, are you interested in a company who has been researching and diving into this? And they're only on lab scale at the moment, but there's some future in it. So that can be also, but it can also be very large companies. We have huge companies in the port, the refineries, for example, and they're sometimes coming to us with a question like, hey, we're still looking for these type of technologies or these type of companies, these type of knowledge centers, can you help us out? So it's really, it can be everything. Yeah. But please contact and then love to help.
I was wondering if there are any safety concerns regarding the bunkering of ammonia.
Not at all. We're to talk about. No, just kidding. Of course. Yeah, I think the question also rose this morning, right, on ammonia. There are a lot of extensive research being done. Also for LNG, LNG bunkering is something we are doing now for 12, 13 years. And I believe the very first time we did it, 12, 13 years ago, they almost closed off 1/3 of the port. Just let that sink in. 10 kilometers of port just shut down. You couldn't go in, go out, nothing. And nowadays it's just a regular piece of business. It's not because we're getting bored by it and just doing it anyway. It's because we've done extensive research, theoretical but practical, are asking a lot of experienced people in it. We're developing our own procedures. We are learning from our mistakes. We are just getting better and better, hopefully. So I think that's also, I hope, what's going to be happening with ammonia. At the moment, we're in the stage where we're doing a lot of research. And like I mentioned, we're in a consortium, MACPI, where we are looking into what the possibilities are with ammonia. So also working together with ship owners, like how do you want to design your vessels? And what does that mean in Rotterdam? So when you go bunkering, does that connect well? Or is it literally a difference of a few meters or barriers or whatever? So you can really see, and we also have already looked in the port area where we made these safety zones, where you can, or safety areas, where you can look into where you can or cannot already maybe do something with ammonia. But yeah, we're gonna dive into that more, obviously. Yeah, but thank you. Yeah.
Actually, thank you, because I had exactly the same question regarding ammonia. But maybe you could complete with the question of public acceptance, because we understand, of course, you are doing research and all safety measures or permitting necessary.
Yeah.
But what about the public acceptance of handling so much ammonia in that very dense area?
Yeah. So the whole port, or maybe is my first slide maybe better? No, not really. Anyway, so the whole port area, I think we have 2 or 3 living rural areas also in the port. So here basically is whole Pernis Shell is there, but right across the street, there's living, I think, I don't know, 10, 20,000 people or something are living there. It also goes from here, for Rozenburg is also an area in Rotterdam. So you see, in the port, it's not only our job to look into the industry with all these companies, but also ensuring the safety of all the people that we have. For that, the same goes with all the analysis that we're doing regarding safety. We also go into conversation with the people who are living there. And also the Port of Rotterdam is for 70% owned by the municipality of Rotterdam. So you see from there's also obviously a lot of interest in keeping the people safe, and they're keeping the interest of the people living in Rotterdam constantly in their minds. So you see that there are people involved in the company as well who are constantly safeguarding everything that goes around. So it's because it's a small but very long area. You see that on both sides of the water, there are a lot of people living there. So you have to be careful and safe and do all your analysis.
Okay, thank you, Lyda. I think we will run out of time. And
No time?
no, I think you take it in the lunch break.
Please talk to me. We talk about public perception in the Dutch consortium ministry, of which Port of Rotterdam is also part of, and then we start addressing public perception.
Thank you. That's a good addition to that. So thank you, everyone.
Thank you. So now we'll have our next speaker, which is Edgar Hartsfeldt from the Stralsund University of Applied Sciences.
Just a few minutes for the setup. Maybe if your question will be really fast, we can still pose it. But really fast, like 1 minute till they set up.
Yes, it's Institute of Sustainable Process Technology, where Dutch international companies work together on ammonia, and next 2 years will be kicked off Thursday, where public perception is one. Linked to your perceived ammonia safety. In principle, the risk of something going wrong with ammonia is exactly the same as something going wrong on LNG as methanol. It's designed to effect. The probability, however, is somewhat larger on zero ammonia to now a lot of ammonia potentially in the future. And that means that in the full risk contours, you have to start addressing and mitigating effects on how we deal with ammonia leakage. And how to deal with ammonia leakage to minimize the risk for whomever is in the surroundings is, of course, a different measure than what you do with methanol and for energy. So in ammonia, you work towards avoiding harmful cloud going into, whereas on LNG and methanol, you mitigate towards fire and then explosive clouds. So it's risk management, different risk with new fuels.
Cool. Ladies and gentlemen, my name is Edgar Hartsfeldt from Stralsund University. This is a small university in the northern part of Germany. So we have 2,500 students, not so many, but we come to the conference and give you some hints for methanol storage systems. So I divided my presentation in 4 subtopics: demand analysis, system design, operation management, profitability. And I will start with the demand analysis for EV charging. So this is the topic we discuss in the university. And the question arises, are the petrol stations in Europe enough for EV charging? And so we have in Germany 14,000 petrol stations. That should be charged auto capacitor and batteries. The difference is the discharging time or charging time. Auto capacitor, we can charge very fast and discharge very fast, but the batteries needs time.
If we look for the lithium ion cell, so we see two electrodes, the electrolyte and the separator. And the ions must be moved from one electrode to the other electrode. Sorry for that, I'm an electrical engineer. And so I have to introduce to the electrons and ions. Okay, so we see here on the left side, a Tesla battery with 4,680 cells. And so we can control this or calculate. We have to switch 48 cells in parallel and 94 cells in series. And finally, we come to 4,680 cells. That's a lot. And so I developed a discharge curve, a voltage curve. This is the small equation. I'm a teacher, and so I have to show you some equation. And the voltage is 3.6 volt for each cell. And the discharge voltage is approximately 2.8 volt. It's not zero. Then what we can see here is if we assume that we can drive the car 300 kilometers and we have a segmentation of the discharge curve. So we come to two interesting voltage drops at the beginning and at the end. At the beginning is not so nice, but we can't do nothing. But at the end, so we should find a charging station or a charging point. If not, so we have trouble. And the distance here is 15 kilometers. And so we can describe the supply area for our charging station. If we start with the area of Germany, and we take this radius of 7 kilometers, so we can find that we need 2,338 charging stations in Germany. And the next step, I can calculate the number of charging points for Germany. These are 2 million charging points for EV charging. If we start with 45 million cars, the number of cars are too high. So we have to reduce the number of cars. That's clear. But interesting is that we need approximately 2 million charging points in Germany for EV charging or e-mobility. We come to the system design. So we see the supply curve. This is from the solar radiation. In the summer, we have best conditions, but in the wintertime, we have no solar or less solar radiation, but the demand in the wintertime is very high. If we look to the battery operates very well. If we have amplitudes, equal amplitudes and duration time for charging and discharging. This takes place in the transitional seasons. And if we have not these good conditions, so we need long-term storage systems, maybe power to methanol. So the level of mismatch is here shown, and we have only 2 points without mismatch. So for long-term storage, we can see hydrogen, synthetic methane, synthetic methanol. And if we look for the energy density, so we have for hydrogen 3 kilowatt hours per cubic meter, 10 kilowatt hour per cubic meter for synthetic methane. And synthetic methanol, we have 5,100 kilowatt hours per cubic meter. It's enough for a single family house with 3 residents for the winter time. That's interesting. And so we designed a new rapid standby unit or microgrid solution, consists of a power generation unit and a power refinery unit. The power refinery unit consists of a electrolysis and methanol synthesis and a reformer. The reformer is for the standby. He is producing hydrogen and CO2 from methanol. And the CHP generates electricity for the EV charging and heat. Both systems, the storage and the reconversion, produces heat. And so this system runs 24 hours per day. More or less, if we have surplus electricity, the storage will run with 100%, and the reconversion system with 20%. And if we have less surplus power from the renewables, so the storage will run with 20% or 25%, and the reconversion system runs with 100%. The heat can be stored in the heat storage, but in the underground storage. We see that we can supply EV charging and also diesel and normal combustion engines. We produce electricity, heat, gasoline, basic chemicals, and we see the new petrol station consists of 3 containers. First container is the electrolysis, second, the methanol synthesis, and the third is the reconversion to CHP. Here we see the reactions. The electrolysis, hydrogen forms, the electrolysis forms from water, hydrogen, and oxygen. The hydrogen is used in the methanol synthesis with CO2. The CO2 acts as a glue for the hydrogen. We have 3 hydrogen molecules, and the glue is the CO2. And then can we reconvert the methanol to CO2 and water? CO2 and water is evaporated and remain in a closed loop. EV charging station with power to methanol. The polygeneration microgrid solution consists of the electrolysis, methanol synthesis, methanol tank, water tank, CO2 tank, the heat pump, a gas turbine, and a generator in the basement of the charging station. So we can connect the polygeneration microgrid solution with media exchange. So we can exchange all media from one charging station to the other. And in the middle, we have the smart city, where we supply the, or we can generate the infrastructure for EV charging. So we have CO2 liquid grid, a methanol grid, a deionate grid, a district heating and cooling grid, and the DC grid. And we have also connected the farmers, the small business, big business, and our consumer for the connection to the biofarm. So we can use bio CO2 because biogas consists of 50% of methane and 50% of CO2. And the CO2 is separated and used for biomethanol. A brief summary of the results so far. A new battery analysis parameter was introduced. The supply area of a charging station was determined. The number of charging points per charging station was determined. The use of long-term storage was described. The power to methanol technology was presented. A charging station was introduced as a microgrid solution. A microgrid supply solution with media exchange and grid integration was presented. A brief overview of the next approaches. We will carry out a demand analysis, introduce a new simulation tool, determine all parameters of a supply system, introduce an independent observer, price mediator, control an energy storage system, and optimize the installation cost. Have a look. So we see Germany and a small region, Schwäbisch Hall. And for Schwäbisch Hall, we analyze the demand of EV charging. So in Germany, we have 83 million people. In Schwäbisch Hall, we have approximately 200,000 people. And so we come to 100,000 EV cars we have to supply. The number of charging stations, approximately 10. We need 4,000 charging points, 440 charging points for each charging station. And the power demand is 4.4 megawatt per charging station, in total 44 megawatt. And the energy is 440 megawatt hours per year. So this is approximately the same energy demand from the region of Schwäbisch Hall. And the students asked me in 2016, sorry, in 2016, this is an earlier time, it's too far. In 2016, they asked me how much energy or how much installation capacity in wind and PV power we need for Germany for 100% renewable. That was an interesting question. And so I go back to my office and create this small model and answer the students, would you really want to know what we have to install on wind power? Yes. So there's 800 gigawatt and 400 gigawatt PV power. So it's unbelievable high. It's not possible. And the students asked me, what should we do? So I said, what should we do? Reduce consumption. Our consumption is unbelievably high. Yeah. Okay. And so here you see the energy demand, energy supply, CO2 emissions analysis, energy storage, investment costs. And here are the results for Schwäbisch Hall from 2022 to 2030. Direct use is 77.4, but it's too much to show. What is interesting is the number of wind installation is 130.5 megawatt in wind power. PV power is 65 megawatt, and the share of PV power is 30% or 29%. That's very interesting. The installation capacity for power to methanol or power to fuel is 17.2 megawatt and 27.2 megawatt for backup systems. And this is the mass of methanol. There's a gap because we give the methanol also for cars with combustion engines, and the emissions from these engines is 1.2 kilogram CO2 per liter methanol. This is less than for super benzene, super gasoline. What are the costs? The costs are 473 million euro for this region for Schwäbisch Hall. And so I designed an independent mediator. This equation system simulates the European Energy Exchange very well. What we see here is the surplus energy. The surplus energy for the storage purchasing takes place primarily in the summertime. We see that the equation system or the algorithm is operating and buying all the surplus power in the summer and sell the energy in the wintertime. And here we have a virtual tank. There's a tank with two valves, a red and a black valve. The red valve is connected with the storage system, with the methanol synthesis, and the black valve is connected to the CHP. And so we see in the wintertime, the methanol synthesis is not running, but the CHP takes the methanol out of the tank. In the summertime, the CHP needs no methanol from the tank, but in autumn and wintertime, it takes the methanol from the tank. In the summertime, the methanol synthesis produces methanol and fill up the tank for the next period, for the next winter, for next year. Here's the heat production from the CHP and from the methanol synthesis is operating with 300 centigrade, but it's a very nice heat because we can use it for the heat pump to make cold. Profitability. So we have two passes. The first pass is electricity to electricity is 44.3%. ETA 1 is for the electrolysis, ETA 2 is for the methanol synthesis, ETA 3 is for the reconversion. And so we have to multiply this. Then heat or cold supply, we can use the heat from the methanol synthesis or from the reconversion, 30%. And finally, we get 64%, or we take the next path is electricity to methanol or basic chemicals. And here we have the electrolysis and the methanol synthesis, and we come to up to 50%. heat and cold supply, the same situation. And finally, we have approximately 79% in this space, plus and average value is 0.72, 72%. That's quite good. And we can compare it with a battery system, and the battery system have an efficiency of 80% approximately. Okay, but the battery charging and discharging cycles is limited. Our solution is not limited. Have a look to the electrolysis. This is a plug-and-play 2 megawatt electrolyzer. The costs, the specific costs are 581 euro per kW or kilowatt. Methanol synthesis, green methanol synthesis, specific cost 551 euro per kilowatt. And then we have the heat pump, wind and PV systems. Finally, we come to approximately 500 million euro per investment cost. And how we have to install this, our charging station, this solution, we have a total demand of 20 megawatt. And so we can decide we take 10 charging stations with 2 megawatt. And this is the situation. So we have a grid expansion, but we can realize this 20 megawatt or also with one charging station. But here we have a problem if we have a failure. So it could be an outage of the system. And so we can optimize this and we will find an optimized solution for 5 megawatt per charging station. Yes, this is the specific cost analysis. And we come to approximately 0.2 euro per kilowatt hour, means that 1 liter of methanol have 5 kilowatt hours, multiplied with 5 is 1 euro per liter methanol. That's the price for, but it's without taxes and profit. Yes, that's the real price for the generation. So yes, we have huge investment costs. And the question is, who should invest in this solution? So the owner should be the inhabitants of Schwäbisch Hall. So the inhabitants of Schwäbisch Hall have to invest in this new solution and get benefits by the profit after 10 or 20 years, yes? So I calculate with 10 years, after 10 years, we are in a positive range. And so the inhabitants from Schwäbisch Hall make profit and get back the money. But the new technology ensures the following key tasks: generation of charging power for EVs, emergency power supply, island grid supply, frequency and water stabilization, generation of synthetic fuels, heat and cold generation, storage of surplus power, production of basic chemicals, CO2 reduction, fossil fuel savings, and use of renewable energies. Last slide comes from my students. One-step technology like wind and power, wind PV power, the wind power station, electricity, one step. Solar radiation, solar cell, electricity, best ever. Are simple and inexpensive. However, the fluctuations of demand and supply must be handled by means of distribution and storage technologies. Two-step technologies like power to methanol are based on an innovative rapid standby unit using of state-of-the-art components. It features of the standby unit storage of wind and PV power on a short or long term together with high flexibility in production and use. The transition process should be supported by suitable planning tools like graphic interface 2 in order to design and dimensioning storage and supply systems. With this approach, we are hopeful to contribute a sustainable and resilient energy supply solution. Thank you very much for invitation and attention. Thanks.
Yes, so questions?
Question?
No
No,
question? Okay.
okay.
Thank you.
Thank you.
Then we are
Lunch.
Yes. Okay, then it's Yes, dear all, welcome back. We're now ready to have the next presentation by Kolian Jörling, of the head of division hydrogen, alternative fuels and fuel from Now GmbH. So, Koliana,
Thanks.
welcome.
Hi, welcome back. We were thinking yesterday about doing some desk yoga after the lunch to get everyone energized, but maybe we'll manage without. I will quickly introduce us. I am head of division at NOW GmbH, and I'm responsible for climate-friendly aviation, maritime applications, and renewable fuels. And we are founded in 2008 and are a company completely owned and financed by the German state. And in my case, we support the Federal Ministry for Digital and Transport in their endeavor to accelerate the uptake of climate technologies in the transport sector. So you can think about us a little bit as like an in-house consultancy sort of organization. And we provide technical expertise, but also a lot of expertise on regulation and funding programs on these technologies to the ministry. And we try to really be an interface as well between industry stakeholders, so a lot of you guys, and the policy realm, because we feel like there's a lot of need for translation as well between those worlds. And there's 3 parts to my presentation. I would like to draw your attention to a database. So look a little bit at what's already there, and then take a look at regulation, and that both on the European part and then on the member state level. So that's part 3. And I was already anticipating that this may not work. So I have a backup, of course. There we go. So what is this? It's a database on sustainable aviation fuel that emerged out of a working group that was called into life by the German government. And it includes a lot of scientific organizations, but also a lot of industry stakeholders from Germany and partly Europe, and non-governmental organizations. Actually, Ulf from Agora, who will be speaking after me, was part of the early concept and consulted on this as well. And this is funded by both the federal ministry as well as the ministry from the Bundesland, from Hessen. And what we're trying to do here is have really a comprehensive database of projects for sustainable aviation fuel, and that includes both biogenic but also PTL. I know there are other databases around, but we weren't really happy with the ones that were around because, one, we didn't have the back end, so we wouldn't be able to update, and they didn't show all the detailed information that we felt it needed, because it's too one-dimensional just to say there are 197 projects globally. That's just not detailed enough for the phase of the market where we should be now. So on this one, I was going to click through it, but as this doesn't work, it's static. But if you click, you can apply different filters when you go into the database. And this is already filtered for sustainable, for synthetic aviation fuels. It's moving around a lot. So we have 197 projects in the database overall, but globally announced projects for synthetic aviation fuels are 90. It's moving a lot. Am I doing this or are you doing it? Okay. So these are 93 globally announced SAF projects, which sounds like a lot. That would be a production volume of 6 million tons in 2030. But it's really important, and that's what we're trying to really draw attention to also on the political level in Germany and Europe, is that the rate of realization or the current degree of implementation and then the probability for realization is really key. And that's what you can see on the pie chart on the left, where only the blue, the light and the dark blue, are projects that are either in operation or under construction. And even the ones in operation, they are not yet reaching the levels of production that they are announcing for 2030. So we have a lot less in production. And we feel like policymakers are now starting to understand how difficult it is to move from one project phase to the next and to get from early enthusiastic and great ideas, but not maybe sometimes not too realistic ideas, to actual planning and construction. And what we're going to do with this is we're going to update it. We want to have an update in Q2 next year And we also ask a lot of stakeholders from industry to fill in their data and update their data so that in the next Q2, we're able to tell policymakers, look, that's what's happening, that's the trend. Because I'm going to be a bit of a pessimistic German here, I expect that we will see a lot of those projects that are currently in the database disappearing because of what we're hearing from industry. A lot of the projects were really good ideas, but the likelihood of actual realization is not as high. On the other hand, there are some projects that are really going ahead very well. So for any of you who see themselves as synthetic aviation fuel producers and see our email coming by in the next couple of weeks, please do take a few minutes to fill them in. And you can also access it here. And you will get my presentation, so you have the link. For the second part, what does it take to actually get these projects into realization? Is regulation doing what it's supposed to? I want to draw some attention to 3 regulatory packages that have already been discussed today and yesterday. And some were saying everything is there. I think Tobias Block was saying quotas need to be higher. And then Mr. Schulz from Ramboll said everything's basically there. We can get started. I think it's somewhere in between. I think there's a lot of work that has been done and done right, but there are also some really important gaps still to be filled, and I would like to take a look at them with you. So are the quotas really doing what they're supposed to? And I want to talk about the project that has been talked about before by Liquid Wind. And Mr. Frederiksen, you probably know more. You hinted that you do know more about the reasons. I can only speak to what's in the press and what we hear from the project, what they're able to disclose. And I want to draw attention to this project because this is one of the ones where we were very optimistic, because it has, in comparison to Germany at least, it had a really good position in northern Sweden geographically, and it also, it was aiming, it had all the technology it needed. They were aiming to produce 55,000 tons of methanol by 2025. And even though they had been past the final investment decision and were already building, they abandoned this project, accepting a loss of over 200 million euros, which is really quite substantial. And I think for the whole industry was a big, a bummer, if you will. And so we thought about why we think one of the reasons why this didn't work. What they said was that both the project cost increased after their final investment decision compared to what they had assumed before. And then also the offtake wasn't as they had expected. So they weren't able during the construction phase to secure the kind of offtake agreements that would have been needed. And this brings me to the FuelEU Maritime quota, and also 2 other ones that I want to mention. For FuelEU Maritime, on the one hand, it's great that we have sub-quotas for RFNBOs, but on the other hand, the target is indicative at first. So there's a target of 1% for 2031. And if that is not met, then you have another target for 2034 of 2%, but that one that has conditions for fulfillment, and those are availability of these fuels, their costs, and the possibility of distribution, which is, very fundamental. And it's really, those are really conditions that we find are too strong at the moment. And I think basically it's just not strict enough for companies in the maritime sector to really do these offtake agreements for these admittedly very, very expensive fuels at the moment. And so I see a few things that policymakers can do in the next 1 or 2 years to try and solve this problem or work towards a better signal from politics. One is a national implementation of the Renewable Energy Directive, and I get to that in part 3. Then the International Maritime Organization is thinking about an emission fee scheme to be implemented at IMO level, which I think would also help, but this probably, depending on how it goes, won't include a specific sub-target for RFNBOs either. And I think that's really what it needs. It needs to be very specific, not just please reduce your emissions, but it needs to be, very tangible for these fuels to take off. And there's also a FuelEU Maritime Revision planned in 2027, but that's, another few years away. That would, of course, be an opportunity to tighten the target and make it more reliable. And then there are initiatives like green corridors, where we put a lot of attention to at the moment, because these, I think they have been mentioned in the morning, those are initiatives where you look at a particular route in the maritime sector and then get all the stakeholders from fuel production to offtake to logistics companies to sort of sit at one table and draw up a project together. This is something that we also see with companies like Marbanaft. Alexander will be speaking in a minute as well, where we see consortia coming together covering the whole value chain, where we expect maybe a higher probability of projects actually taking off than producers going in by themselves. But those are really soft solutions at the moment. To be honest, I'm just not very happy about how this went. And we hope that the things that I just mentioned as sort of sub-solutions can help to make this regime a little bit more tighter and consistent. For Refuel EU Aviation, we have a bit of a different situation where we don't have these conditions as we see them in Fuel EU Maritime. We have very clear penalties. We also have penalties for Fuel EU. But overall, we feel like Refuel EU Aviation is a bit more reliable for the whole market as a direction of where the market's supposed to go. Still, I have stakeholders telling us that the revision Article 17 is a problem for them. And this is something, I think it's a bit of a matter of belief. So I feel like some stakeholders, like Norsk E-Fuels, for example, we just had a chat in the lunch break as well, they have been able to secure offtake agreements, and that's, really great success, really good sign. But then other producers are telling us that they're really struggling to get offtake agreements with off-takers beyond the ones that have already been successfully negotiated by Norsk E-Fuels. And we also see off-takers like large airlines really still lobbying against the regulation. And so there seems to be a bit of a problem of credibility. And I don't have a concrete solution of how to solve this. If there is a bet against a regulation that is in place and there's not really precedent for environmental or climate targets having been pulled back by the EU, so there's no real basis for this argument other than that it really takes belief. I think you need some soft power there. I'm gonna get a drink. Can you get me my tea ready? Thanks so much. That's better. Am I back with the microphone? Yes. And yeah, so I try to offer some solutions for Fuel Maritime where we can work on the regulatory regime for Refuel EU Aviation. I'm afraid it's just going to take more belief in the regulation. And hopefully projects like Norsk E-Fuels that do take off and that show the rest of the market that it's actually possible. And then finally, with the Renewable Energy Directive, I think it's really important to have the sub-quota there. But if you think about Renewable Energy Directive giving an incentive directly to the maritime or the aviation sector, I'm a bit skeptical because the sub-quota is not specific, and hydrogen used in conventional refineries is one of the options that you can use to fulfill this quota. And so the effect on these two sectors is very indirect. And this is where I would probably agree with the E-Fuel Alliance that a higher quota would maybe help, but more so a sector-specific quota. And that brings me to the national implementation as the third part. Because we always look at the regulatory regime as a whole, and we have some European regulation in place now, and what happens next is the Renewable Energy Directive will be implemented at member state level. And we really think that member states here have a chance to improve on some of the aspects that are still a little bit vague, which is also okay because it's a directive and it's supposed to be implemented by member states and made more concrete. So this is something we think is going to be very important in the next month, but also next year, as member states publish what they're aiming to do. The target that has been set by the Commission is that this must be implemented by May 2025. To be honest with you, I'm not sure if all member states are going to comply. There are some signals from member states that they will have to delay this a little bit. But let's hope that it doesn't take too long, because it's important to have this certainty as soon as possible. In Germany, which I will use as a bit of a case study here, which probably also makes sense because Germany is an important example for the rest of the EU and such an important economic stakeholder and so on. We have the Ministry for the Environment, Nature Conservation and Nuclear Safety and Consumer Protection in the lead. And they are expected to show their ministerial draft by the end of this year to the other ministries that can then agree, and then also companies will be asked about their opinion and so on. So that's sort of the rough timeline. And in Germany, this will be implemented within the Federal Emission Protection Act as part of sort of an amendment to the German greenhouse gas quota, which I'm sure many of you are aware of. And let's take a look at the main key design elements that we think are important and that I would also advise you to have a look at and sort of look at the discussion as it unfolds in the coming months and year, because it's, yeah, just those are really important guidelines, I think, for the industry to be comfortable. And the first one is the scope. This is something that's not optional for member states. And you probably know this. The greenhouse gas quota is going to be extended from now covering only the street sector, and I think actually part of the of railway as well, to include also shipping and aviation. So this already increases the ambition as well, because if you set a percentage target for reduction on a given denominator, then and the denominator increases, then obviously the ambition level also increases. So this is something we're going to see anyways, and also in all member states. I think that's very helpful. The second one, something I'm a little bit excited about as well, is the time frame, because one of the problems with RED at the moment is that it sets a target for 2030, and 2030 is just not that far away. And we know that the business models for e-fuels, for RFNBOs, they need at least like 10 to 15 years and hopefully more to plan and really have a reliable regulatory basis for their plans and yeah, to go forward. And it's possible for member states, at least that's what the German ministry thinks, to go beyond this, so to set a national target that goes beyond the European target, and to already do that now. The third one is an overall ambition level increase, so it would be possible, and that's what Germany has done in the past, to also go beyond what the Renewable Energy Directive sets as minimum. This is a bit of a no-brainer. It's also possible as a member state to divert from the sub-quotas. That means both RFNBOs, but also for advanced biofuels. So do take a look at that. Sorry, and that brings me, of course, back to the FuelEU Maritime, where I said I would come back to this. This is something where the Renewable Energy Directive is quite concrete already, and hints that it would kind of like to see member states to have a national sub-quota. And it states that member states, I think, should think about something along those lines, and a target of 1.2% as a sub-quota for the maritime, for energy used in the maritime sector within their country. And as I said, I'm not happy with the FuelEU Maritime target because it's too vague, but it's really difficult. I think it would be really difficult politically to really implement this, because German ports will immediately rise up and say, are you crazy? We already have competition from Northern Africa. We will have competition from Turkey. We have all these new concepts coming up with logistics hub outside of Europe, and just, you know, having feeder ships doing the smaller routes just because of EU ETS and the legislation that is already in place. So I think for this to be politically feasible, the minimum would be a good coordination at the European level. So having at least the northern ports work together, but hopefully all of the European ports, which is even more difficult to negotiate. And had it been easy, I think it probably would have already been in regulation. But you know, you always have to try, and I do hope that Germany and other states with important ports within the EU will negotiate this. Even if I start with a really low quota, even something beyond 1.2%, it would send a better signal than we have at the moment, for a really binding target for off-takers in the maritime industry to really rely on this and know that this is actually coming and they can't, lay this off much longer. Yeah, that was actually covered, I think. There are some more details like the level and structure of fines, where, for example, there are some provisions set in red, but the member states then decide how exactly they implement this. And yeah, I think I will skip the other ones because they're not as relevant for you. And let me check. Those are the important aspects on the national level. So we will definitely be observing how this goes, and we will do so both within Germany, but also beyond, looking at the European level, because I think that's the next the most concrete chance to work more on the regulatory regime overall. And I have brought some resources with me. The supplemental I've shown you. We're also drafting fact sheets on important regulatory regimes if you're interested. And that's it for now. And I think we have 4 minutes here for questions.
Indeed, we do. So please go ahead with questions.
Are there any questions?
Any questions?
Are you tired or has everything been said already?
Just after lunch. So, okay, if there's no question, I think we just okay.
Thank you. A very French question, excuse me. What about nuclear industry and what about the low carbon fuel that is the specific SAF or fuel, let's say, that is made with nuclear electricity? How does it fit in that picture? Because we know that the whole picture is not as balanced or as equivalent for eSAF with renewable energy, RTBO, and low carbon fuel. And of course, we are advocating to have the same treatment agnostic as regards carbon-free energy.
Thank you. That's a very French question to ask a German.
Maybe I could add, because there are a lot of Nordic people here, Finlandish question also, and some nuclear energy.
It's welcome anyways. So this, first of all, this covers both. So synthetic aviation fuels here means both from renewable energy and nuclear energy. Looking at the bigger picture and politically, it was very hard for Germany, I think, to swallow that low carbon low carbon hydrogen and low carbon SAF sourced from nuclear energy would be included in refuel aviation. And I mean, I was not at the table for the negotiations, but I think part of the deal or the thinking was that it would continue to be outside of red, because this is something that I believe at the moment for Germany is a political red line, but we also have elections coming up in Germany, so you never really know. Yeah, I personally don't believe, it can have some niche applications. I don't think it's overall the way to go, but that's maybe part of my nationality as well. I'm happy to discuss further. But I mean, you're right, definitely to point out that this is already part of refuel aviation, and for red, yeah, not at the moment at least. Maybe in the next revision, you never know, but for now, yeah, I mean, it's just not, you can't account for it.
It's a very German answer to my very French question. Thank you anyway.
Is an English input.
Okay.
So I also wanted to have a bit more clarity around. So in the UK, the Department of Transport does include nuclear in net zero targets for aviation. So I think you basically said that isn't going to be strictly the case in Germany. It will be more, yeah, it's not included as such. It's just not excluded.
Well, so we're speaking about refuel aviation, so the aviation sector here, and that's where we don't have a directive as the renewable energy by the regulation.
So not necessarily refuel EU, so obviously that's EU, but then for yours, for Germany specific, for example, the transport, Department of Transport, would your Department of Transport include it in any supply chain developments for e-fuels, for example?
And well, for refugees, they don't have a check. They don't really have a choice. I'm not sure if they will attempt, to be honest. Maybe Ulf knows more about this. So because it's a regulation, that means it's in place directly. It's not like the RED that has to be implemented at member state level. And because it's in refuel aviation, I believe that the member states don't really have a choice to accept this for target department. So it's in there, and Germany can't really say much about it.
In there by default, but your Department of Transport won't explicitly go further, for example.
I mean, it wouldn't set incentives for additional fulfillment by low carbon.
Yeah, just because the UK is actually being quite, yes, this is here's the small print, yeah. I just want, and also on the SAF monitor, so I know Lufthansa also has some innovation hub. Have you worked with the team at Lufthansa innovation team on the SAF monitor?
Not on this, so
this is independent and accessible.
This is, I mean, what's not accessible is the backend Excel, basically, but this is completely accessible, and you can click around and get all those numbers. And this is, done by us together with Sena Hessen, who have a similar role, but on the state level, and it's supported by the ministry.
Okay, I think it's time's up. So we go to the next presentation from Ulf Neuling from the Agora Werkswende.
Hi, everybody. Thanks for having me. Maybe until the presentation came up, a few words about Agora Verkehrswende, as I assume most of you don't know us, maybe some of the German people here in the room. So Agora Verkehrswende is a non-profit think tank based in Germany, mainly Berlin. We're working on the German and European level and developing solutions on how to make the transport sector climate neutral within given climate targets like Germany until 2045 or the EU until 2050. It all started with Agora Energiewende, so that's the energy transition part of our think tank society. So maybe one of you or the one or the other knows them because they are more active also on an international level. They have been funded in 2012, then 2016, we joined as Verkehrswende, so transport transition. And for now, we are two different entities, but still working together because energy transition and transport transition are obviously linked, especially when talking about hydrogen, e-fuels and everything, which is, of course, well linked to energy. In my presentation, of course, on the afternoon of the second day, it's always hard to get some new stuff, some new informations. Maybe I have one thing in my pocket, so let's see if it's not too much of the information you already heard before. But to start with, I was wondering, so we heard very interesting presentations about project implementations of the actual state of e-fuels, but no one really spoke about why are we talking about e-fuels at all. So, of course, we are from the transport sector, so it is to reduce the emissions of the transport sector. And as you see here, especially in the EU, up to today, the transport sector was the only sector with still increasing emissions over the last decades. Every other sector reduced their emissions, energy sector, industry sector, mainly due to the implementation of renewable energies. But the transport sector is still way off track to achieve any of the given climate targets. And that is, of course, most of you may know that because of the energy mix in the transport sector. So all of the overall energy we use in transport, over 90% is provided by fossil sources like oil and petroleum products. And of those are roughly 70% used in road transport and roughly 1/4 used in aviation and shipping. So this directly has an impact on the emissions of the transport sector. So to reduce the emissions in transport, and this is also true for other sectors. At least in our opinion, there are two main ways to go. The one is be more efficient, so reduce the energy amount we need, reduce the primary energy demand by make transportation more and more efficient, change to or switch to more efficient solutions, and then try to make the remaining energy demand as climate neutral as it gets. And that is where e-fuels will come into play. So this is just a schematic. I think all of you know what e-fuels are, how they are produced. But there are different sectors and applications that are discussed for e-fuels. We already heard that at one or the other occasions. So most of the presentations here focused on the transport sector. That is what we also focus on. So the upper right part, so aviation, shipping, maybe also some parts of the road transport. I will come back to that later on. But there's also a competition with, for example, the chemical industry. We heard about that. There's until for today no strict regulation, but some parts of the industry also have their own sustainability goals. So they will have a big need of green molecules in the future, especially green carbon sources to defossilize their products. Also, so there's also competition on these sustainable carbon sources and also e-fuels. But when talking about the transport sector, I think most of you may have seen one of those figures in one or the other way. This is the efficiency of different transport drives. For road transport, it would be similar for a compact car, it would be similar for a truck. You will only see fewer trucks on the right-hand side. So that is how many cars one could supply with energy, with the energy from one windmill, just an exemplary calculation. So the efficiency for battery electric vehicles, some transmission losses, some charging infrastructure losses, some losses in the vehicle, but still pretty efficient. So pretty much of the initial energy lands on the road again. When talking about hydrogen as a direct car and in a fuel cell vehicle, it's getting even less. So only like roughly half of the amount of cars could be provided with the same amount of energy in the beginning. And when talking about e-fuels, it's even worse because we have the energy losses of the electrolyzers, of course, the synthesis process, and then, which is the biggest chunk of energy we lose, of course, the losses during combustion in the combustion engine, where roughly 2/3 of the energy are lost as thermal energy. What we try to include here, because that is also often part of the discussion, are the potential efficiency gains in especially electrolyzers, but also the synthesis processes. So that are the more lighter colored numbers and also cars. So for hydrogen cars and fuel cell cars, that might be some sort of game changer. Battery electric is still more efficient, but due to the efficiency increases in the supply chain, fuel cell electric cars may become better. But as it is for e-fuels, liquid e-fuels in cars, again, most of these efficiency gains are still consumed by the combustion engine, so not that much of a difference. It's still 4 to 5 times more efficient to go battery electric than to use e-fuels. Of course, that is a thought of experiment for new cars, so you have to get all the battery electric vehicles in the market. You have to build up the charging infrastructure. You have to apply the grid. You have to include the renewable electricity in the grid, but still it is more efficient. And then to reduce the amount of energy we need, the most efficient way should be the way to go. Still, e-fuels might have or will, of course, play a role when talking about the existing car fleet that is still on the road. The second part are the costs of such fuels. So these are the results of a study we did, I think, 2 years ago with TNO. I'm not sure if the colleagues of TNO are still in the room, where we analyzed the total cost of ownerships for trucks, battery electric trucks, hydrogen trucks, and diesel fuel trucks. And what we found, even with the state of art like 2 years ago, which is pretty much more advanced nowadays when it comes to battery efficiency, battery costs, and so on, that even 2020, like 20% of the use cases would have been more cost competitive with a battery electric truck than with a diesel one. And up to 2030, more than 99% of all use cases would be from a total cost of ownership perspective, so including the CapEx for the truck, but also the OpEx for the energy consumption, would be more competitive than relying on diesel fuels. So we also included like the potential range of such trucks, the breaks the drivers have to take in between to recharge and so on. But still, taking all this into consideration, it's more cost efficient to go to electric trucks also. So in our opinion, what we should focus on when talking about e-fuels, and I'm glad that most of the previous presentations and also the projects we heard about are thinking about the same direction, are to reduce or to get the projects, the e-fuel project, the plants, focusing on the aviation and the shipping sector. Of course, there will be byproducts, we heard about that, and they could play, of course, a role also to reduce the emissions of the existing car and truck fleet, the road transport at all, which is, we heard before, taken also by the Renewable Energy Directive, so which aims to increase the amount of renewable energies in the transport sector. But as the amount of battery electric vehicles will increase, so the demand for liquid fuels in the road transport will reduce in the next decades. For us, I think is the way to go is to focus on focus on aviation and shipping, as those are the long-term off-takers for e-fuels. I just brought some numbers with me. We heard about the ramp up of the production. I already come to that later on. But when we talk about, for example, the Refuel EU mandate, so we heard, okay, it's 1.2% in 2030. That doesn't sound like a big number. That equals to, depending on who you ask, 550 to 600,000 tons of e-SAF, which has to be produced. That is quite a number, but what does it mean? That means we need like more than 400,000 tons of hydrogen a year, more than 3 million tons of sustainable CO2 that fulfills the red criteria, the delegated act criteria. If we would want to supply that by direct air capture, that would be 80 times the biggest plant currently operational from Climeworks in Iceland. And depending on the load factor, you assume 2.5 to 5 gigawatt of additional electrolysis capacity. So that are quite some numbers that have been installed, that have been built, and then of course be powered by renewables. So depending on if you use only wind or only PV or a mix, then is also some 10 to 15 gigawatt of additional renewable electricities that have to be installed to produce these fuels. So that is quite a challenge, but I'm happy to see that there are many different projects already trying to solve this challenge. This is just an indicatory overview of projects that plan to come up into operation until 2026, 2027. We heard about most of them. As a disclaimer, we only included projects that tend to produce RFNBOs. So sorry for the French person, no low carbon fuels here, that have a specific site already chosen and a specific startup date. So that may differ from for example, the Sky Energy SAF monitor we had before, and also the SAF monitor of the NOW. But after our calculations, again, so we saw similar projections, that is just our case. It seems that at least for the Refuel EU mandate in 2030, it might be possible to produce enough e-SAF, but that would mean that we need all the SAF that is produced. So 2029 would be roughly a fit to the goal. If the other projects in 2030 come online, that could be enough but only if we use half of the worldwide produced e-SAF in the EU. So that's also, although only 1.2%, again, when compared to the production announcements, that is a challenge. And we heard also that only a few of those projects already have a FID or are even under construction. So those numbers are always have to be looked at seriously. And again here, so we heard about the Ørsted, but also in the aviation sector, there are some projects that have already been abandoned. So that was very small project initiated in 2022, on aiming to produce 10,000 tons of eSAF in Hamburg. But as you see on the project consortium on the bottom, there are quite some names gathered together from the energy supplier, over technology providers and suppliers, and also the off-taker with Airbus that want to off-take the fuel in Hamburg. So even for such a consortium, it was hard, or is still hard, to get such projects up and running. When talking about the maritime sector, it's pretty much the same. So when talking about e-methanol, the projections look a little bit better. I think we already heard about that, because the project is simpler than compared to Fischer-Tropsch. You need less space requirement. We have less space requirements. You have also a broader market, because you can shift from maritime industry to also chemical industry, where methanol is worldwide traded base commodity. So that gives you some more degrees of freedom. But when looking here, it looks quite good to fulfill the FuelEU Maritime mandate. But still, that is not as stringent as the ReFuelEU mandate. Corinna just mentioned it, so it's more like an indicative mandate. But still, again, here, I think I don't have to go into detail again. Also here, some of the most advanced projects are cancelled or terminated or postponed because of the challenging market conditions and also the offtake side. But so keeping all this in mind, so those were projects in Europe. It's understandable that the first of kind projects might be planned and built in Europe, but in the long term, I think that is also clear for most of you. We would like to produce these fuels in regions with high solar irradiation, high wind potential, so low cost of renewable electricity, and then also low levelized cost of hydrogen. That brings us to the question of e-fuel imports. So this again is also only an experiment of thoughts we did on what would be required to substitute the G20 fuel demand by e-fuels when only producing those e-fuels in sweet spot regions. So in the Southern Hemisphere, only by PV, just to make it more explicable. We also did the calculation for wind. And if what we already heard, there are less crowded areas like deserts in those areas that show a high solar potential, low cost potential. You could also solve the water issue by desalination plants, but still, if we only want to substitute the fuel demand for aviation and the maritime industry, which will most likely increase in the next decades, then we need maybe roughly 5 times additional installed PV capacity as is currently installed worldwide. And we then look on the continents that are discussed, like South America, Africa, and Australia. The bars are just shifted, scaled, related to the desert area that we underlaid, but still what we see on the left bar, there's barely any PV installed in these regions. So those regions also have a demand for electricity at all. They have to defossilize or decarbonize their existing electricity systems. So it is most likely that they at first would use the enormous potential they have for renewable electricity production to supply their own needs before going into large e-fuel production plants to support the EU or also North America with e-fuels to reduce our climate impact in the transportation sector. And that brings me to the last point I want to tackle. We also didn't talk about sustainability aspects. Of course, the overall idea of e-fuels, and I totally agree on that, is to reduce the climate impact of transport, to reduce the carbon impact. So that is more or less the environmental aspect of e-fuel production. So we talked about additionality of power production, about the closed carbon loop, so the CO2 that comes from the atmosphere, either via biomass or direct air capture, seawater desalination as water source, of course, avoidance of land use competition, we tackle that, and also circular raw material use. But especially when talking about e-fuel import from the Southern Hemisphere, we also have to tackle these economic and societal dimensions of sustainability. So how could those projects also help the economical development of the region itself? Also the energy transition at a local level, I discussed that shortly, and also the transport sector there, because they also might want to use hydrogen or e-fuels in their own transport sector. And of course, societal aspects like capacity building for in the country, so that they can reduce their own or realize their own projects, supply chains, add surplus electricity or supply of drinking water when installing such projects. Have a look on land use rise, include stakeholder participation. So there's a long list of sustainability aspects that should have been kept in mind when talking about e-fuel projects in those sweet spot regions. So to wrap up, I think we will definitely need e-fuels also in the long-term future, especially for the aviation and maritime sector. I think most of us agree on that. But also of parts of the chemical industry. There might be a competition that could also be an opportunity to work together. When talking about road transport, at least for most of the use cases in, let's say, Europe or the industrialized world, electrification is the most efficient and cost-effective option. Also for aviation, we will need aviation and sea transport will need liquid fuels, but also some types of hydrogen and direct electrification will be a part of the future energy mix. We also heard about that. And to achieve this, now the question was how to ramp up the e-fuel production. And I think it's just a summary of everything we heard before. And it makes me, it's good to see that we all are on the same page. So what we definitely need are internationally aligned sustainability criteria. I think there's work done on that. Of course, we need regulatory clarity, at least on the EU level, even better on international level, like on IMO level or ICAO level for aviation. And of course, financial security to get these projects up and running. That might be by risk mitigation due to state aids, by long-term offtake agreements. I think we discussed all of this in the past day. Yeah, that's it. Just to also, if you are interested in the analysis we did, the market ramp up, we have two recent publications, one on e-fuels in general as part of the transportation mix, energy mix, and one focusing on the eSAF production and eSAF pathways. Feel free to look up all the data behind the calculations. We also have a list with all the projects we included in our database. If you don't find your project, again, as Corona said, be happy to hear about your opinion and to include you in a newer version. And of course, I would also be happy if you have any questions now or later, just get in touch. I'm always happy to discuss these issues with you. Thank you.
Thank you. So, questions?
Okay.
Okay.
Not? Perfect. Thank you.
Thank you. Then next speaker up is Alexander Sedomanka from Marbanaft.
Hello, everyone. Thank you very much for having me here. And yes, indeed, I think it is nice to follow Carina and Ulf. They covered most of my presentation, so I can focus maybe on some more kind of Marbanaft related issues and less explaining what we have been talking about for the last 2 days. Just to give you a very brief idea who we are, Marbanaft is a large physical fuel supplier in Germany. We are on the market since 1947, family-owned company from Hamburg. with currently presence in Western Europe mostly, but also we have offices in US and in Singapore. So we are doing also some international trading. In the end, we are moving quite a lot of volumes between different regions, mostly importing liquid fuels into Germany and Northwest Europe, storing in our own storage assets, which we operate, and distributing it to our customers. We also operate a large network of truck stops. We supply bunker fuels to shipping companies. We supply a lot of different types of fuels to road transportation, and we also supply several airports with jet fuel. So basically present in all areas of transportation, where we also will have a need for e-fuels and clean fuels. Of course, we already have biofuels in our portfolio, but as we all know, this will not be enough at some point. So working on further, let's say, alternatives together with many of the companies in the industry, including some of you being here. Yeah, and to give you our idea, we are talking a lot about chicken and egg in this industry, right? That's producers and off-takers waiting for each other. But very often we forget about the hen house. Also, a lot of infrastructure needs to be prepared. Logistic chains needs to be prepared. So we need to do a lot in between, right? And to connect the dots basically between the producers, who are in many cases are newcomers in this industry, coming from the power generation, for instance, or renewable energies, who don't know much about logistics of liquid fuels. And on the other hand, off-takers also don't want to bother with all these logistics and storage and blending, and making sure that the fuel is has the right quality and supplied in a safe way. And speaking of safe, with these new alternatives like methanol and ammonia, this will play even higher kind of role, and being crucial to make it in a safe manner. So yeah, this is basically how we see ourselves getting eggs to the customers, basically providing this interim or a solution in between. And looking at this a bit from the value chain perspective, indeed you have production, transportation, blending and distribution. Marbanaft is currently in all parts of this value chain apart from production. But in a way, we are also making first steps towards that part, because we also recognize that we need for these clean new fuels, maybe start a bit earlier to make this happen. Okay, then to give you some specific examples of what we are currently working on and doing. One of them is a small demonstration plant. Our partner is finalizing in Hamburg. It's a small Ineratec container, which our partner Hansen Rosenthal is putting on their site, on the existing refinery site. They already have a green electrolyzer. They are operating for last, I believe, 5 years. So we are now adding this Fischer-Tropsch container with an expectation to produce small volumes of e-fuels, e-diesel, e-naphtha, and e-works, 100 tons per year of each of these products, just to test it, to try it out with first customers. That was the idea. I hope it will start producing these fuels by end of this year. Wax is also an interesting one from Fischer-Tropsch. You also get solid fraction. Not all of it can be then processed into liquid fuels, but our partner in this H&R specialty refinery, they're supplying wax and paraffins to pharma and cosmetics customers. And there is also potential, of course, for need for decarbonization at some point, and we also see potential there as well. Another example is our joint venture with the already named H&R P2X Europe, which is 50-50 joint venture where we aim to source these e-fuels for us and for our customers. On one hand, these guys developing their own projects around Europe, but also working with established potential e-fuels producers. Such as Nordic Electrofuel. We know Gunnar for many years and work together to make the project happen. And I think, again, as we mentioned a few times here today and yesterday, we shouldn't see each other as competitors. I think we should all do something to make this happen, because otherwise, as we have seen, there will be not enough, and then we go into the next round of discussions with the politicians. So are the quotas still required if there is not enough production? And we really don't want to have this discussion. Maybe to switch a bit to specific customers and solutions we're working on right now. You've seen this many times throughout this conference. I think I don't need to stop here for too long. This is an example of ReFuelEU Maritime, where we have specific requirements for greenhouse gas reduction in shipping industry. As has been mentioned, these are indeed not too strict and not too ambitious. We also agree with that. Before 2035, shipping companies can do many other things to achieve this 2% and then 6% without really having a necessity to switch to clean fuels. They can use green power in the ports. They can optimize the routes. Indeed, a sub-quota or some kind of quota for clean fuels would have been better. But okay, this is what we have. But at least some of the first movers are still trying, of course, to switch to these cleaner alternatives a bit earlier. Some of them are motivated by their intrinsic or internal ESG goals they have communicated. Others hope maybe to also attract some additional customers. We see particularly in the passenger shipping, but also shipping companies who transport cars between the regions, that they have a bit more kind of readiness to go this way a bit earlier before the real push from regulatory side kicks in. And here is another example. TUI Cruises, a company from international cruise operator, who has taken their first methanol-ready ship into operation this summer. And Mabanaft plans to supply them with carbon-reduced green methanol. We are preparing infrastructure for that in Hamburg. These guys operate their cruise ships in Nordics a lot and starting somewhere in the North German ports usually. And this is where we want to prepare corresponding infrastructure and supply for them. Basically, we have an advantage in Hamburg having our gasoline tanks there, which we can relatively easily convert into methanol or make them methanol ready, following the logic of our customers, right? This is what we're working on, and of course, discussing now with multiple potential producers how to source these fuels, when to start, what volumes, at what price and cost, of course. So connecting the dots, as I was telling before. Another example is our project in Australia. I think I have a separate slide on that one. Yes. It's a small demonstration plant we are also involved in, where we also want to test a combination of CSP, concentrated solar power, with methanization. It's a small 7,500 tons project we are working on with a partner from Australian side. And the hope is, or expectation is, that due to heat generation through CSP and heat requirement in the methanization process, there will be some advantages of this combination. And from Abanaft, in the end, we are not a technology company. We are not our primary aim is to get our hands on green molecules for our customers. And we hope that if this works and proves to be maybe a bit more efficient, that we can scale this with partners and produce larger volumes where we need them. Another example of what we're doing is a big project we have in Hamburg. Again, we have 2 storage terminals in Hamburg, and one of them is one of the largest import terminals for fossil fuels currently, and some share of biofuels, of course. But what we plan to do is to demolish 2 of our largest diesel tanks at this terminal, and to build an ammonia tank, and basically to create ammonia and hydrogen import infrastructure. We have a partner, anchor customer, in this project as well, who plans then to build the cracker to crack ammonia back into hydrogen, and probably either truck it out or put it into the pipeline, which is also will be connected to our terminal. But Mabanaft thinks that there is also potential to use ammonia, of course, as ammonia for our shipping customers potentially, and maybe in other areas. And for that matter, this is maybe another illustration. On the left side, you see the part of our storage terminal and 2 tanks we plan to convert or demolish actually, and build the ammonia one. And we're also in talks and discussions with Hapag-Lloyd on ammonia as a bunker fuel. And yeah, a lot has been talked and told about safety of ammonia. Thus, we don't see it for now, at least in the passenger shipping, but I think others are seriously looking towards this alternative because it has some advantages. It doesn't have carbon. It can be scaled in production because you don't need a source of CO2. And to be honest, if you do it in a safe and secure manner, it is doable, right? We within our group, we have also a sister company, a large storage terminal operator worldwide. They store ammonia for many, many years. It's not, let's say, rocket science. You can do it. You just need to do everything right. You need the right expertise and know-how. We also conducted some studies on ammonia bunkering in Hamburg. So yeah, of course, we need to take care that this is done in the right way, but it is not undoable. It's a known product. We transport it, we store it for many years and decades, but now it's just will be used for another application, and we need to make sure that it's done safely. Okay, maybe switching to aviation. As I mentioned, we do supply several airports with aviation fuel. We plan to expand these operations as well to other countries and airports in Europe. In Oslo, where we also supply jet, we already have a small SAF obligation ahead of the European one. For several years already, we blend and sell sustainable aviation fuels in Oslo. But of course, now everyone is preparing for 2025. And then, yeah, here again, something you have seen many times, but here we have our quotas coming up from 2025 for SAF and 2030, unfortunately, only from 2030 for eSAF. I think both myself and Gunnar would have loved to see the quota a bit earlier, because the project Gunnar is working on could produce the fuel much earlier than 2030. But of course, this again creates a certain uncertainty for those pioneers who have been planning this for many years ahead. And another problem we see with this regulation, apart from what Corina has already explained, is that it goes in stages, right? It's not a linear growth. It's 2% at 25, 6% at 2030, and the same for eSAF. And that means for 5 years, we will not have a change in demand, which is very unfortunate. But let's see, maybe there will be some adjustments. Yeah, well, this is from Concave, different routes, how to get there, showing basically that Fischer-Tropsch seems to be one of the most efficient routes, cost efficient, and in terms of greenhouse gas saving. But of course, there are also other alternatives like methanol to jet, where we also see some projects coming up. This route is not ASTM approved yet, but probably will be. One way or another, I think we will need all of them, and it will depend a bit on the local conditions. And yeah, we'll see, but I think both routes will be required. And what we are basically doing is combining this. In case of Fischer-Tropsch, let's say most of the planned projects end up with some kind of synthetic liquid or synthetic crude, let's say, which still needs to be processed into the final product, particularly if you don't have straight away a huge plant with 100,000 tons, which I think a bit big jump from having basically a few hundred tons demonstration plants today. So we will need some interim steps, and there we will need also some smart solutions how to process these synthetic materials, crudes, into aviation fuels or other fuels. And this is also something Mabanaft and particularly our joint venture PTX Europe is currently working on. Okay, coming to the final part of my presentation, what opportunities and challenges we see here still. Opportunities are obvious. We have very specific legislation. Again, some calculation I did myself, so don't blame me if there are some calculation mistakes here, but I think we will have quite substantial demand for eSAF in Europe in 2040, around 5 million tons, which is a very good market, right, to serve. So we will need all those projects and many more. I think for the methanol part in the shipping industry, I just took an example of Germany here. It's from the study, actually, also Rambo has done with NOV together. We were part of this as well. They forecast around 1.5 million tons of methanol required only in Germany in 2040 for shipping. And of course, it will not be, I hope, gray methanol. It will be green methanol. So again, a lot needs to be supplied and done here. And you can extrapolate this for Europe. Of course, it will be much more because Germany is not the largest consumer of bunker fuels in Europe. So yeah, the big question, of course, is around methanol and all other fuels, low carbon versus green. Europe is very much focused on green. I've heard this quote lately. Europe says the only clean is green, and outside of Europe, they say blue will also do. Let's see which thinking will prevail. Our customers, most of them are also telling us, at least for now, that they want only green. But of course, in the end, it comes down to economics and cost and price. Maybe if we get blue products with substantial CO2 reduction, it is also a way for as an interim solution. But for now, we are mostly focusing, of course, on green and particularly e-fuels. For methanol, maybe just a few more comments here. We also see some more flexibility, of course, because you can use it also to make then jet fuel potentially. You can blend it into gasoline. You can also use it as a chemical feedstock. You've seen as well from announcements that from the first e-methanol plant in Denmark, also chemical companies or let's say chemical applications like Novo Nordisk and Lego are also off-takers. So there is also potential there. But on the other hand, from Fischer-Tropsch, you can make many different products as well. You can go to the chemicals, you can go waxes or transportation fuels for any mode of transportation. So also a lot of flexibility there. So it's also always waiting which solutions you really need. Okay, and finishing off, yes, there are still a lot of challenges. We have seen some projects being cancelled, but I also think this is a bit a natural selection. Of course, everyone was or is very excited, and particularly if there are some support schemes announced, then straight away many projects are being announced. But yeah, some of them, of course, will not make it to the finish line. But of course, we also need projects that make to the finish line, and that is something we need to overcome. And I hope that Mabanaft can help here by this linking of customers with producers. Another topic is complexity and uncertainty of regulations. Again, we need to all keep talking at these kind of events with Brussels and in our case, Berlin as well, to make sure that the regulations are not getting more complicated, but rather maybe simplified. Or at least for the interim phase, a bit easier to fulfill. We also need to look at the production costs. Of course, I just decided, of course, to buy the SAF fuel from KLM flying back to Hamburg. Another example for you, maybe it's around 10 liters of or 10 kilograms of fuel, which is allocated to me, according to KLM, on this short flight from Amsterdam to Hamburg. And that, of course, means around 40 kilograms of CO2. And if I opt to buy this SAF fuel, which is really in case of KLM going into SAF projects, which is a good thing, then I pay 30 euros more for these 10 kilograms, basically. Okay, this is the full compensation, right, for the entire volume. If we talk about 1.2% or 2% of eSAF, even if eSAF may be 3-4 times more expensive than SAF, it's maybe a few euros on the ticket, right? It's digestible. It's not completely destroying the competitiveness of airlines. And then, but as we increase this percentage, of course, it is important to also work on reduction of costs. On the other hand, for off-takers like Mabanaft, it is not easy to commit for these first projects where we see high costs, because we know that later projects will probably be cheaper. And as we all know, these projects require long-term off-take commitments to fly. So this is also something we jointly need to overcome, but I'm sure we will get there. And finally, logistics, we shouldn't forget about that. The methanol example in Hamburg, it's not just producing methanol somewhere, let's say in Scandinavia, and then having a methanol-ready vessel. We also need to retrofit the tanks. In the case of methanol, it's easier than ammonia. We can use existing tanks, but even that takes 1.5 years at least to retrofit with all the permissions and technical issues and details we need to consider. So it's not done in 2 days. And then there needs to be a bunker barge, obviously able to bunker methanol. Again, everything is doable and not a rocket science, but it all takes time. And we also need to consider that. So yeah, my appeal to everyone here, let's keep talking and working on these projects and make it a reality. And let's hope that there will be also more support from regulatory side to do this. Thank you very much. I think that finishes my presentation, and happy to answer your questions if there are any.
I think we just have time for one quick question.
Well, I'll try to put it too. With regarding the penalties and the refuel aviation, how do you view it? Would you like to be in a short or long position in 2030? And the other one on your long-term demand, the price sensitivity of the jet, the air fuel market is quite price sensitive. Huh? If you're looking at the multiples that we see for e-fuels, have you done any sensitivity analysis on will really the demand increase as predicted by many here?
So maybe starting with the demand, I think it will always be, unfortunately, a regulatory topic. So unless there are quotas, there will be no demand, of course, even if even if we manage to reduce the cost of SAF and eSAF considerably, it will never be as cheap as fossil fuels. And that is, we need to be fair, we need to pay for CO2 we are emitting. So that is our cost, and so we need to bear it. But of course, as long as airlines and consumers and suppliers are not required to switch to clean fuels, they will not do it because it's too costly. Maybe a little bit from image perspective, or to attract a few more customers who may be a bit more environmentally conscious. But I think the only way to go, at least in the next 10 years, is quotas and regulations and penalties. Other way to do it is, of course, US way, giving tax exemptions and making it kind of benefits from the other side. But we will see what works better. Probably we will need both. And speaking of 2030, yeah, we are getting ready. I mean, we are a jet fuel supplier, so we are the obliged party. And I think we need to get ready. We need to make sure that we have enough fuel by then. In case of SAF, it's a bit easier. It seems that there is enough on the market, so we can more or less buy it on the spot basis. But if in case of eSAF, we don't see enough capacity get into FID. So I think that's why we are so much engaged in this value chain and going more and more towards this production part where we don't really belong as Mabanaft, but we see a necessity to do so. Yeah.
Yes, thank you very much, Alexander. So then we have our next speaker is Richard Gasamba, Market Development Manager of Andritz.
Thank you so much. So thanks for the introduction. I have a little bit of a difficult surname, so Richard is perfectly fine. I prepared a really interesting case study regarding the market expectations for methanol as an example for how this could look like in the future. Maybe a few words from my side. Within Andritz, I'm responsible for the market development activities. This means we understand customer business cases, we understand the economic impact of regulations, and we try to translate this into market expectations, and we try to understand which projects have a chance to fly and which don't. Why is this important? I mean, we hear a lot about ships today, and we all agree that shipping is a very interesting use case, and methanol, ammonia, e-LNG will play a role in the future in the shipping industry. The question is when this will happen and where's the market? And we talked a lot about today about hand-egg problems. And to answer this a little bit and also answer a little bit, will the market come or not? There's a really interesting anecdote from the shipping industry. Steamships were invented in the 1790s, but did not find widespread adoption until the 1870s. Does anybody know why? Because until 1869, sailing boats were the prevalent method to ship cargo around the globe. In 1879, actually, the Suez Canal was opened. And within 3 years, all steamboats were substituted or sailing boats were substituted by steamboats. So within a very short time frame, we saw an entire change of entire industry. And I think we will be able to see the same here, but we need to figure out where's the tipping point when this will happen. Couple words to Andritz before we deep dive into that. Andritz is a global company. We have 30,000 colleagues in 4 business units. We are really known in pulp and paper, metals, and hydropower. And last year, we consolidated our competencies in environment and energy to really foster the energy transition. Why did that make sense? All of our core industries are at the forefront of the energy transition. We heard a lot about pulp and paper today already. We did not hear so much about green steel yet. And of course, hydropower is required to power all of this. We have a vision to become a global power-to-X solution provider. And honestly, we could already celebrate quite a lot. So in 2022, we were able to put into operation our first biomethanol process in a pulp mill. In 2022, we also were doing our first pilots in carbon capture. And in 2023, we won a big contract with Salzgitter AG to produce green steel and to provide a 100 megawatt electrolyzer based on alkaline technology. And this year, we deep dived into e-fuels and power-to-X solutions. In this whole process, we are with our customer at every step. So we start in the ideation phase. We're there in the concept, feasibility, and FEED through the whole EPC life cycle and also in the operation and maintenance. So we also give performance guarantees, which was a big question yesterday, and we try to be there. We see it's a new technology, and it's incredibly important to disseminate knowledge and to be there with our customers through the whole life cycle. And coming back to our initial question, I mean, where's the market? Shipping industry has coined, and I haven't heard this in this round yet, has coined a very interesting word, so-called well-to-wake expectation. I had to Google what a wake is, to be honest, when I read the word first. The wake is the wave that the ship leaves in the sea. And there's something interesting in this term. This whole term entails the entire value chain. So this is not expectation about levelized cost of hydrogen. It's not an expectation about levelized cost of methanol. This entails what can the fuel cost in the tank of the ship and through the whole production, transport, margins, etc. And now we can discuss about the carrot and the stick, but it's quite clear because when we have a look at today, the bunkering prices, I think Port of Rotterdam was here before. I checked the bunkering prices before. At the moment, $626 per ton, so around about the same in euro. With the regulations have penalties. With the penalties on top, you come roundabout at a cost in a scenario for 2030 to $1,000 per ton, 1,000 euro per ton. If you now add a green premium, and I mean, if we talk about methanol, there will be a green premium. We talk about factor 2, 2.5. So we will talk about $2,000 per ton. Now we have an issue. Methanol, in this case, has half of the heating value. So we talk about a market expectation of below $1,000 per ton from well to the wake. And it's a problem. Exactly here, when we reach that, there will be a market. There will be a methanol industry. There will be the product for the shipping industry, green shipping. And the question is now, where are we today? And the colleagues from TNO, and I'm not sure if they're here still, they did tremendous work recently. They asked 14 Dutch projects regarding the project economics. And I took the freedom to adapt this a little bit to methanol. And the results are quite, I wouldn't say shocking, but also not surprising. When you plug all these numbers in, average values of Dutch projects, 75 euro per megawatt hour, 4,800 full load hours, capital cost of 9.5%, you come to cost of methanol today with these project parameters, 2,000 euro per ton. So we are 50% away from this target. And it's quite interesting. I mean, now we can discuss, okay, we have electricity costs in there. It's the first portion. We have the CO2 costs in there. So direct air capture, point air capture in our pulp mill used. You have the OPEX there, you have the CAPEX there. Question is now, how do these parameters have to change in order to reach the market expectation? And now, first thing we see, energy costs. So we discussed a lot about energy. We discussed a lot, we need the cheapest energy. So let's try out. So we have energy costs now of 4 cents per kilowatt hour. So you have a location with a lot of sun, a lot of wind. You have a very knowledgeable partner, utility side, that can reduce these costs. So if you do the same calculation, instead with a levelized cost of 75 euro per megawatt hour, but 40 euro, so 4 cents per kilowatt hour, you can reduce this cost by 20%. So we're still at 1,600 euro per ton. You can do the same now with the full load hours. So one is OpEx optimization, the other one you utilize your CapEx better. With that, you increase the CapEx portion. With this, you reduce your cost. You still, so this is calculated on the base of 2000, you're still at 1,200 euro per ton. So you still have to go at least 10% because you might see taxes, margins, etc. is all not included yet. So we have a quite significant gap. And I mean, this is the challenge. That's what we talk about. Without closing that gap, we won't have a market. Now, the question is, where can this gap be closed and how? And in Andritz has a quite straightforward answer to that. And we have discussed this already before. This is a pulp mill. So for those of you who don't know it, pulp mills are quite large plants. They're always a biorefinery. And in the regions they're also one of the most producers of renewable energy. So Metsä, for instance, produces 15% of the Finnish renewable energy. So quite significant. And this gap of 10% can be closed either by either cheaper electricity costs, so going down by 1 cent per kilowatt hour to 3 cents, increasing the full load hour even more, but this is a little bit difficult. Or by reducing the CapEx 25%, or find other levers in the OpEx. So overall, project optimization in really all aspects. So pulp mills, in our opinion, and this is just an example, so the goal is not to just use pulp mills, but the idea is that there is project locations where this can work, where you really can close the gap. And this is one of the candidates. Pulp mills are interesting. They are usually power utilities. So they have really good skills on the power market side. And this is, if you just come from the gas side, a really big plus. They regularly do the step out of their core business models. So pulp mills do byproduct utilization. They are already producing biofuels, etc. And I think this gap through smart project integration can really be closed here. And we are not only talking theory here, so we're also in there. And just before we tell you what we do there already, just one dimension point. So our whole Andritz fleet emits 200 megaton of biogenic CO2. So we talked about biogenic CO2 yesterday, huge amount. A standard, so large-scale pulp mill has run about 800 kilotons. This emits 2 million tons per CO2 per year. If you would just use 5% of these, so this number's hidden here, 117 kilotons per year, you could produce with a 100 megawatt electrolyzer around about 81 kilotons e-methanol. If we talk about the market expectations, I just did some math this morning, it's roughly 2% of what the colleague said. Nice thing, and we do this already, I said this in the beginning, you can also produce biomethanol, and this is a simple purification process. We have this in operation already. So this whole discussion about, oh, we need to learn how to argue with pulp, how to learn how to handle methanol. This is all ongoing already. So methanol is already one of the byproducts used in pulp mills. And as I said, this is not just theory. So we're already currently engineering the 600 KTA carbon capture based on amine technology. And the study is done end of this year. Our methanol process, biomethanol process, was first commissioned in 2022 and proof of concept 2020. First design 2020, then startup 2022. And Salzgitter, our 100 megawatt, which will be our blueprint to roll out to all of our Power-to-X projects. All of this, I mean, you see we discussed also a lot about stakeholders and about who's involved, and this is very complex projects. So we don't believe this can be done alone. So we think partnership, talking in all phases about all aspects is incredibly important to make this work. And with this, I'm open to questions and I'm happy to discuss.
So, questions, please. Any questions? Does not seem to be any, yes, coming question here.
Yeah, thank you. That's really interesting. I was just wondering, so the intention would be to mostly use renewables, but then use some of the power from the mill to like fill in the full load hours, essentially.
I mean, you need a location with cheap, accessible, continuously running renewable power. And a nice thing about where these pulp mills are is usually Scandinavia. So they're already in locations where you can access this. And if you just check the numbers, you can already choose the location because you don't need so much of the resources there. So you can already choose the locations which have the best prerequisites. Is there enough also power connection available? So from the grid connection, is there maybe already other facilities you can use? Is there infrastructure there to transport the methanol or the other products? So, but with this approach, you can really choose what is the good locations and find the business cases because it's still difficult. I mean, 10% still difficult. With this, you can really find the business cases that can work and that really achieve these market expectations.
Further questions?
And thanks a lot.
So thank you very much. And then we have our next speaker is Piyush Khatkar. I hope I get this right. And he's the senior business developer for the Vattenfall. He's to talk about decarbonization, how to bait sectors with end-to-end value chains.
So in the 1 minute for the preparation of the speaker, I would like to remind you to fill in the evaluation form. Please don't forget to rate our speakers so they know how it was their performance and also the organization of the event. Thank you.
Good. Well, good afternoon, everyone. So good to have your attention back and just before the break, so it's going to be hard for me. I'll try to keep the text on the slide as minimum as possible and also the content, but I apologize if with the flow I dive into the content. So my name is Piyush. Till yesterday, I was the business developer at Vattenfall for hydrogen. But as of today, I'm also the product and contract manager for hydrogen at Vattenfall. In that role, I basically support Vattenfall's journey in commercializing the offtake contract to FID, but also towards future asset optimization when large-scale hydrogen plants are up and running. So before I jump in the topic, the key enablers to large-scale hydrogen production, please bear with me to give you a short introduction about Vattenfall. Vattenfall is a 100% Swedish state-owned organization. We have a portfolio access to 8 million electricity customers and 2 million each heat and gas customers. As of today, I have around 21,000 colleagues. As a regional player, we are operating in big parts of Europe, primarily in Nordic, with our head office based in Sweden, and of course in continental as well as in UK. In these countries, we have portfolio of operations and assets. With that regard, primarily what you see here on the graph, the green ones being our hydro assets in Sweden, the large-scale nuclear assets, followed by district heating, for example, in Amsterdam, also in Sweden, solar assets, growing portfolio in Germany, and definitely our vastly growing wind portfolio in continental, especially in North Sea. Apart from the operations of these plants, we have a huge expertise in trading and market realization towards intraday, day-ahead market, and also PPAs for our current and upcoming assets. And that is very important for the wind and also to leverage our renewable pipelines to support our customers on their decarbonization journey. Over the last year, Vattenfall committed to net zero 2040 target and also certified by SBTi, which not only means that we have to completely eliminate our scope 1 and scope 2 operations, but we have to work with our suppliers and customers to help realize the complete reduction of scope 1 and scope 2. Here we start with increasing our renewable power supply, and that entails our current portfolio of 17 gigawatt of installed renewables facility, majorly consisting of hydro, and future portfolio of towards 30 gigawatt that has a massive ambition in wind and solar PV, especially in Germany. At this moment, we have almost 2 gigawatt each in Netherlands, Germany, Denmark, UK, with several gigawatt in development as well when it comes to wind, and a massive portfolio of wind development also in Sweden being our home base. Having spoken about the first piece of the puzzle towards hydrogen and e-fuels, that is the renewable power supply, the next piece is hydrogen production and storage. Although the electrolyzer technology have been around for quite some time, we as Vattenfall, for us is new. It's a new technology. And also the access of hydrogen towards the market, given the uncertainties, we believe that pilots are key enablers for us to mature our organization, both from technical and commercial perspective. That is why, as of today, we are operating hydrogen breakthrough iron technology with 6 years of operational research into fossil-free steel production. The goal here is to completely eliminate CO2 emissions, scope 1 and scope 2, with our partners, SSAB, that is the steel producer, LKAB, that is the mining company in Sweden. As of today, around 5,000 hydrogen-reduced iron or sponge iron have been produced in the market, which has been supplied to companies like Volvo Group, who are already using it in their machineries, be it transport, heavy machineries, or consumer goods, for example. Especially when it comes to technical perspective, we realized that with hybrid, it was the first industrialized hydrogen-based iron technology with 4.5 megawatt of dedicated alkaline electrolyzer. In this project, one of the biggest learning for us was that with dispatch optimization, including a storage facility, we were able to reduce variable cost of hydrogen production by 40% as compared to directly procuring the electricity prices from the market, in this case, the Swedish market. That was one of the biggest learning that helped us realize the key lever that is needed to further in future optimize the large-scale green hydrogen production cost. Apart from hybrid, Deep Purple, that is the consortium led by Technip FMC with other players like Nel. We have been participating in that consortium to learn about the conditions that are out there in the North Sea, in the offshore industry, and what impact does it has on offshore hydrogen production. Although the demonstration takes place on the land, the simulated conditions are realized for offshore bases that helps us gather operational data on electrolyzer performance if it's to be operated in offshore conditions. So with these two projects, we are now having intensive knowledge together with our partners on the pilots. That helps us now to work on our next large-scale project, that is the Zeewolde project in Netherlands. The Zeewolde in English means sea sparkle. Together with our partners from Denmark, Copenhagen Infrastructure Partner /CIP, we are now busy realizing a 2 gigawatt offshore wind park in North Sea in the Netherlands. As part of this realization, there's also a system integration component that is integrated with it. One of that is offshore floating solar park, reasonably smaller size, 50 megawatt, and up to 1 gigawatt of green hydrogen production. So with Zeewolde, we are now entering the era of gigawatt scale or large scale hydrogen production. This is where we see that we are at the stage of utilizing the learnings from our pilot and build towards next stage with our partners, CIP. Essentially, when it comes to Zeewolde, what you see here is basically a demonstration of what a gigawatt hydrogen facility in future would look like, which is to be realized in Port of Rotterdam area. And at Port of Rotterdam, we have accessibility to offshore landing, but also large scale off-takers that could potentially consume the volume, as well as the first hydrogen pipeline that is being built today by Gasunie in that area. That was the second piece of the puzzle, that is the hydrogen production, especially large scale, which we are investing most over time, especially for my colleagues who are working on hydrogen. Essentially now looking at hydrogen offtake and end use. Earlier today, I gave an example of HYBRIT. We submitted our 6 years research to the Swedish government because we received funding from them. We also received funding, I think, from EU Innovation Fund. And for HYBRIT, now the next stage would be large-scale deployment together with our partners. Next to that, we are also analyzing and monitoring the eSAF industry. We believe that partnership, especially with complementary skills, where we can help mature the industry, is a key enabler to end-to-end value chain of eSAF, apart from regulation or infrastructure. This is where earlier this year, with likes of Airbus and Scandinavian Airlines, we signed a memorandum to undertake feasibility study of hydrogen infrastructure in Norway and Sweden, that's roughly accounting for 50 airports. This is the first step to a 1-year feasibility study that would cover the two countries, and it reflects the shared ambitions of our partners. And especially when it comes to e-fuel, one of the key learnings, one of the key things that I want to know is that if I want to escape the depressing Dutch winter, what it would cost me to pay for the eSAF if I, as a consumer, let's say flying from Netherlands to India to visit my family, for example. And earlier, we had a presentation from Agora where we saw a nice summary of the sustainable, economic, and societal challenges that comes with eSAF. Thank you for that. And I decided to take another example to dive into it further. So what happens when we talk about translation of RED III into national regulation? And how would that affect a consumer like me, like you, and would that be bearable? Keep in mind that implementation of RED III is still impending. Member states need to do it next year, but of course there could be potential delay that could take place in several member states. We do know that we need quotas. I work with a lot of off-takers. We need quotas to realize the off-take contract, and the off-take contracts are extremely critical to make a FID. Apart from the demand quotas, we need to know if these quotas would keep the industries in Europe secured and not lead to any deindustrialization, especially for the critical fuels that we have in Germany, in Netherlands, for example. Additionally, the socioeconomic cost of realizing green quotas should be bearable by end customer like us. And what's the best way to find a solution to distribute this socioeconomic cost? As of today, EU has put a minimum share of SAF, and that's the sustainable aviation fuel and synthetic fuels. You might have seen this slide a lot of times over the course of 2 days, with the minimum target binding in 2030, 2035, 2040. So the line below is synthetic, and the line above is sustainable aviation fuels, so SAF and eSAF, for example. EIA has of today concluded that the e-kerosene route is almost 338 times higher than the current kerosene fuel. That could be between $600 and $800 per ton, depending on the region as well. While in future, that cost might subside, but you all know that the future cost predictions are always quite ambitious. We already see that in hydrogen and electrolyzer industry as of today. And then the question is, when you look at from an aviation industry or companies where we as a consumer are participated in, 25 to 30% of their operating cost are the fuel cost. So how does that translate to a ticket price? Let's say a ticket price from flying from Amsterdam to Stockholm. As of today, or let's say a couple of weeks ago, the cost of that ticket was €400. If we consider BioSAF, then there are options with KLM that you have to pay certain premiums and that cost escalate to 550. If that to completely transition in e-kerosene based on today's cost assumptions, we as customers would pay almost 72% more. That's roughly speaking, 280 euros more. And that could be unbearable for most of us, especially if you're frequently on business price and stuff like that. However, when it comes to blending, that is where the key enabler is. We spoke also earlier about that, the blending, how do we start small and then hopefully in future, make the cost more bearable on socioeconomic perspective. Blending with 5% kerosene has remarkably low difference, and we're only talking about 1450 euro per ton, but these are all my calculations, so please don't justify it to make your financial advice. And just 5% blending leads to 2.3 million ton of e-kerosene production only in the EU. And that is a massive number. As of today, the SAF industry in 2024, only the SAF industry accounts for 1.5 million ton. That is only 0.5% target of, 0.5% of the overall jet fuel consumption in 2024. So we are already talking about a big number, and these projects have a massive lead time to realize that even in 2030 for them to be up and running. So in a nutshell, I think having looked at the renewable power supply, having looked at the hydrogen production, and now the end use, be steel or eSAF, I think the main question is also what cost is bearable for the consumer, especially in Europe. From Vattenfall perspective, we will play a role in it, either as an electricity provider, electricity generator, or a hydrogen producer. We will not do it without partnership because we recognize the complexity of the project from technical side and from commercial side, starting from offtake realization to asset optimization. And hopefully in future, we will see the costs are more and more bearable to the consumers like us. Thank you for your time.
Thank you. Do we have any questions?
Thank you very much for the presentation. I know you said they were not your numbers. I think they were from the International Energy Agency.
Yeah.
What do you think about those numbers? For example, $3,500 per ton for eSAF today, $2,100 per ton for eSAF in 2030. To me, it seems a bit low. But what do you think about that? Because this is the International Energy Agency, and if they say it, this might be something that policymakers consider when they put the mandates. But it seemed quite low to me. What do you think about that?
You mean the cost price of?
Yeah, the cost of production of eSAF.
Of 2030.
And today, 2024 and 2030.
It's a very good question. So I don't have the numbers in head on the projects that we are working, but in past, we have seen the same challenges with hydrogen production, especially how the costs have risen up over the past year with inflation, with interest rate, and in general, the supply chain. We have seen escalation in overall hydrogen production costs rather than reduction. 5 years in hindsight, those costs were supposed to go down, not increase. Nowhere in Europe, we see realization of €5 per kg hydrogen as of today, even for 2030. So we are skeptical about these numbers, but of course, no one has a crystal ball. And we continue learning with the industry.
Quick questions for you on the given that you're an energy company, I mean, you understand electrons more than you understand maybe as of today the molecules. So how do you see the dilemma between trying to maximize your capacity factor of the electrolyzer vis-a-vis the cost of electricity, which is 70 to 80%? I mean, do you see that there has to be more flexibility on the use of the hydrogen or derivative? Do you see that you have to do something else with batteries or whatever you on the electricity side? I mean, where are you in your thinking to try and optimize that cost, which is a bit of a killer today?
Yeah, especially for the hydrogen market. Right, so as of today, Vattenfall is also working on hybrid concepts. That means mix of solar battery and that is majorly for electricity market. We see that the current contracts that people are talking about, be it a non-binding offer or term sheet when it comes to hydrogen, are linked towards pay as produce. And that's primarily because limited facilities when it comes to storage and other assets. Going ahead, we see storage as a key enabler, especially when we're talking about heavy industries that needs base load source, for example, steel or chemical, while certain industries like refinery, for example, can consume pay as produce because of their existing SMR technologies. So that question and the business model behind is very much customer centric on what they want. And that's why we also see a different willingness to pay for different industrial sector. Does that answer your question?
A comment on the question of the IEA pricing, and we looked at this last quarter again, all the old assumptions from scientific institutes and organizations like IEA, and we had a medium of like about 4,200 for the market price with our own assumptions. And when we speak to producers, we come to a range of between 6,000 and 9,000, and that's euro per ton. So we concluded very obviously that the assumptions that we still see in scientific papers and from consultancies and so on, they are just not accurate. And I think there are several reasons. It's because since they were done, several price factors increased, like the cost of capital and so on. And also they are just very optimistic. Also, they come from the large hydrogen hype era. And I think what we have to take from it, as in addition to this realization, is that maybe also the predictions how quickly the prices can fall in the coming years, those may also be too optimistic. So they really have to be taken with a grain of salt.
So one of the e-fuel producers in Europe has, I don't know if this has been asked in the last day or so, but just I'll refresh it anyway. So the e-fuel producer was saying that they would like to have a price of 20 euros per megawatt hour for their electricity supply for their e-fuel production. And recently Microsoft has just done a 20-year offtake, which was $100 per megawatt hour from nuclear power. So obviously that's a prediction for e-fuels, which seems okay. Well, it's a stake in the ground.
Yeah.
So, and obviously maybe the Microsoft one is seeming much higher. But do you have a current price that you're looking at for the economics for your e-fuel production in the future?
It's a very good question. So yes, I think let me take a step back. It's also the same relevance for hydrogen production as well, especially when you're competing against gray hydrogen. And it's very much regional dependent. For example, in Sweden, there are regions, especially SE1 and SE2, the northmost part of Sweden, where the grid is already 90% or more green. And there, the cost of hydrogen production, which we have also seen in the papers, could in 2030 reach towards 4 to 5 euro per kg. Now, I don't know what would that translate to e-fuel production, but of course, we are not looking at 20 euro per megawatt hour. Those figures, especially with the recent boom in offshore wind industry, which we believe is temporary, does not indicate that that figure of 20 euro would be achievable at least towards 2030. And now when you look at Netherlands, where we are also having a couple of developments of e-fuel, for example, Sky Energy in Amsterdam, which also took a step back. And there were 3 reasons. One is limited CO2, biogenic CO2, lack of hydrogen infrastructure, especially in Amsterdam. And third, in general, the hydrogen production price. As compared to Germany, in Netherlands, we have to pay grid fee for electricity that we would use for hydrogen production. That does add more cost factor. And in Netherlands, we don't have 90% renewable grid as compared to northern part of Sweden. So we have to there rely on storage, dispatch optimization. So these factors are very much regional oriented. And I'm sorry, I don't have a definite answer for you.
Yeah, no, it's good to know some figures.
Yeah.
Yeah, no, it's good to see the ranges coming up and then makes them have some ideas basically what offtake should be in the future. Oh yeah, sorry.
Thank you. was it.
Any further questions? Okay, thank you so much for the good presentation. Then we're heading for lunch and start again then in 30 minutes. So basically at 16:35. We are struggling a bit to get you in here, but I think we just need to start in order to keep our schedule. The next presentation coming up is green hydrogen in the UK and the opportunity for e-fuel producer, where we would have Aisling Brazel from Hyro presenting that. So if you can go ahead, thank you.
So before I get started on this, I just wanted to say thank you to everybody here for hanging on in there. I think our numbers are slightly diminished and hopefully the people outside can hear me and come in. I've got exciting news. I'll try and keep this energetic as we start. Yeah, I've got some exciting things to share with you. So yeah, I promise that this is going to be engaging. So we'll start with an introduction. My name's Aisling Brazel, and I like to describe myself as a recovering oil and gas engineer, atoning for my past carbon footprint. I started my career in ExxonMobil, where I worked in major project development, operation support, environmental engineering, and decarbonisation strategy. And last year, I saw the light and came across to Hyro to work in their project development team for predominantly green hydrogen projects in the UK. But we're starting to pivot into e-fuels project development too. So what I'm here today to talk to you guys about is the unique opportunity that developing projects for e-fuels in the UK can offer you. So as an Irish person, I never thought I'd be standing up here advocating on behalf of the UK, but that really says a lot about what we're trying to bring to the table here. So let's just check, is the clicker working? Maybe if I press the right button, let me see if this works. Brilliant. And so first of all, let's start with an introduction of who Hyro is. I will forgive all of you for maybe not being familiar with what our company is, but I'm sure you won't forget it after this presentation. So we are a joint venture set up by two of the UK's largest, keep talking, okay, UK's largest energy companies to decarbonise the hard to electrify sectors with green hydrogen. So the joint venture is formed between RES and Octopus Energy Generation. RES, Renewable Energy Systems, is the world's largest independent renewable energy company. So we have a huge amount of assets. We're pioneers in the project development space for renewable energy. We've got 40 years of experience in energy project development and operation. That's 26 gigawatts in over 14 countries, so a pretty global footprint. And we're widely seen as a pioneer in the renewable energy sector. We were one of the first people to get involved with wind turbine development, project development in the UK, and we've kind of grown from then. So we're a fast mover in new renewable energy technologies, and we're really excited to now start our journey in green hydrogen. The other part of the puzzle is Octopus Energy Generation. If any of you have spent any time in London or the UK or the tube system, you'll be familiar with that nice pink octopus that is everywhere. They've got a great marketing strategy, and we do benefit quite a lot from their footprint. And they are one of Europe's largest investors in renewable energy. So we've spoken a lot about trying to bring investors on board. This is one of the unique advantages that Hyro has, in that we're bringing them on this journey with us. They've got access to over 3 gigawatts of renewable assets, and they are a tech innovator. Really, really exciting. When I first started working with Octopus, that was what I was told. They're not an energy company, they're a tech company. And I'm going to talk to you today a little bit about how we're using that to our advantage and providing that competitive advantage. So together we're Hyro, and we really think we're going to be able to move the needle in this space. We've got substantial experience in energy investment, commercial structuring, renewable energy project development and operation. Have to read that list because we've got experience everywhere. And what we're trying to do is use our expertise to try and make some movement in this area. Now, before I move on to the main bulk of the presentation, actually, I'm going to move to the next slide. We're in quite a nice position being renewable energy developers because it allows us to be quite picky and protective of the electron. So we've seen in the green hydrogen space that there's a lot of use cases that are, green hydrogen is being seen as a silver bullet in a lot of areas. And because we have kind of renewables background, we can say, we think it's better to electrify in some areas, and we only want to convert that electron to a molecule in the areas that really make sense. And so our strategy, although we originally started with pure play green hydrogen, we've started to move into areas like e-fuels, where we think that the hydrogen can make the most difference. So responsible use of that electron, but also now where I was learning this presentation, responsible use of that biogenic CO2, which is going to become a scarce resource. I was a little bit intimidated when I saw my slot on this schedule, but after listening to all the presentations today, I've started to tailor my approach to what I'm going to talk about. So I'm going to skip through a few of the next slides. There's a lot of information on here. Let's not go too far. Okay, we're good. That you can read into. But there's just a few areas in the UK policy landscape that I really wanted to hone in on. Now, although I was an avid opposer of Brexit, the UK having the ability to develop its own UK policy is really, really adding to, firstly, the diversity of the conversations we're having here today, but also providing a new place where people can start to investigate some renewable energy and e-fuels development projects. So I just want to highlight a couple of these areas. I'm not going to go through, I had planned to go through everything, but we've heard a lot today. But the main things I want to highlight on this slide, firstly, I'm going to start with the clean energy. The UK have set some bold claims with regards to their energy targets. I think they are slightly more aggressive than in the EU. And what does that mean for e-fuels producers? Well, it cleans up our grid. So if we start to see these green energy projects coming online, there's more renewable electricity available to start to convert into these e-fuels products. So hopefully we'll start to see that being actualized through the mechanisms that are listed there. Hydrogen, I'm going to talk a little bit about. I'm actually going to talk a lot about later, so we'll actually skim across that. Sustainable aviation fuel I wanted to touch upon. Now, I'm certainly not an expert in this space, but after hearing some of the discussions that have been going on over EU policy, some uncertainties around the penalties for involved in the SAF mandate, I wanted to spend a little bit of time talking about this. Now, at the start of the conference, we heard a little bit about how the UK's targets were less than the EU, and that's true. But what I will say is that the UK addressable market for jet fuel is relatively quite high. I've got some numbers in my head. I'm not going to state them because I'm definitely not the most qualified person in the room to talk about that. But if you think about it, you can produce the eSAF in the UK, and there's still a relatively large addressable market for that. The SAF mandate in the UK is similar in terms of it sets targets for consumption of these sustainable aviation fuels. But the key difference is that that uncertainty with regards to the penalty is gone. The UK government have come out and they've already set the buyout rate for eSAF and SAF in the UK. And that buy rate is about £5 per litre. So in terms of investability, that uncertainty is no longer there in the UK. So if you wanted to take advantage of that, you've got a benefit there. There is also, this is relatively new, so take this with a pinch of salt for the moment, but I would feel remiss to not mention it. There's also conversations happening around the SAF revenue certainty mechanism. I think Jean-Philippe, you mentioned it in your panel the other day. I appreciated that. And essentially, the Department of Energy Security and Net Zero went out to industry and asked, how can we help to incentivize these projects? And the suggestion of a contracts for difference mechanism was suggested. So it's still very early days. They've only just gone out for consultation, but we're expecting to have something. I think their target is to have something in place by the end of 2026. I'm actually going to kind of skim over the other two because I don't see them as hugely attractive incentives. And the real incentive that I want to talk to you about today is the hydrogen production business model and what that might mean for you as e-fuels producers and hydrogen off-takers. Let me just take a break. Oh yeah, before we get into that, so that's the policy landscape. The UK is also incredibly attractive from an investment perspective. So there's money going around, there's people wanting to spend money on these projects. I think we saw yesterday during the panel on the finance side of things that people want to invest in this, and the UK is really ready for that transition. So it's the first ranked best global green finance centre. It's the best in Europe for value of startup and scale up ecosystem. And it's the second in Europe for foreign direct investment attractiveness. So, you know, the numbers are already there. People are interested in spending money in this space. We're already a renewable energy leader. We're a world leader in offshore wind capacity and fifth globally in total wind energy production, which for a relatively small island, I think is pretty impressive. And you've got a skilled workforce. So I'm proud to include myself in that. We've got 6.9 million people employed by engineering. We've got 40,000 high-skilled transferable workers ready to start working on these projects due to our background in oil and gas. And there's a lot of money for research and development in these areas too. So hopefully from these two slides, you've seen that the UK is really taking this seriously. We've got ambitious targets and we've also got policy landscape to support meeting those targets too. So Let's talk about the UK hydrogen production business model. Now, I've been learning a lot about the different incentives in the EU for e-fuels. I've got some notes here to kind of make sure that I'm answering some of the questions that are out there. But I'm going to make a bold claim here. I think the UK hydrogen production business model is one of the world leading, if not the best in the world, for subsidizing the green premium for hydrogen production. So what this does, it's based on a contract for difference model, and it pays the producer the difference between a negotiated strike price, I'll talk a little bit about what that includes, and the reference price, which is usually natural gas. So if we look at some numbers, take this again with a pinch of salt, this is just a snapshot in time, but if we use September 2024's natural gas floor price, the e-fuels consumer would pay £30 per megawatt hour for green hydrogen. Now, if we convert that into kilograms, I'm much more comfortable with kilograms as well, being a chemical engineer. That's around 1.4 to 1.6 euros per kilogram of hydrogen, which I think we can all agree is pretty aggressive. Looking at a lot of the presentations that I've seen here today, in those kind of stacked bar charts, I see a big chunk going towards electrolysis, including CapEx and energy OpEx. This shrinks that right down. So if we're starting to try and talk about how are we going to incentivize these projects, how are we going to bring the cost of e-methanol, e-SAF down, we think this is a great mechanism to do that. I'm going to take a pause here and say, one thing that I do have to put my hands up and say is the UK government at the moment has said you cannot stack subsidies. So if you benefit from the UK hydrogen production business model, you can't also then benefit from the UK SAF mandate. We'll see if that changes. But the way that we see it is there's a techno-economic assessment to be done based on your technology, based on your projects, based on your foreseeable market, and see you can produce in the UK, export that e-methanol for your consumption elsewhere. So we think this is really what's going to change, and we'll see what happens in the policy landscape for those other fuels. The way this works as well, I'm just looking at my notes here because I think there's been a lot of discussions about offtake agreements, long-term contracts. The contract for difference is a 15-year term. So we essentially sign a contract with a government mechanism, a body that works on behalf of the government. So we've got a fixed 15-year agreement with the government who will subsidize the offtake of the fuel. So if we're looking at investability, I don't think any of the bankers are left in the room now, but I think you really can't get much better than that in terms of 15 years certainty. They started off with hydrogen allocation round one. That was 275 megawatts worth of green hydrogen. Hydro was lucky enough to secure one of those contracts, and we're currently working on those projects. I'll talk about that a little bit later on. But we're starting to rapidly scale up. So I think it's going to be a yearly basis, and we'll see what happens with the change in government. But hydrogen allocation round two is 875 megawatts, and we're expecting that to continue to increase to meet that 5 gigawatts of green hydrogen capacity in the UK by 2030. Now, Klaus mentioned in his presentation for Liquid Wind that there's no such thing as free money. You're not just going to say, hello, can I have some of this? Can I have some of this subsidy? There's a lot of work to be done in order to secure that. The eligibility criteria for hydrogen production in the UK is different for that in the EU. And what that really focuses on is the deliverability of the project. So if you say you're going to build this project, how can you prove to me that you're able to deliver it when you say you can? And also, how are we sure that this is green? So if we just go through those, it needs to be in the UK, it needs to be operational with specific delivery years, it needs to be capable of meeting the requirements of the low carbon hydrogen standard. I'll come back to that in a moment. It needs to use a qualifying technology, so it needs to have a TRL of at least 7, which is the background behind some of my questions these last 2 days. It needs to be new, and it needs to be at least 5 megawatts. And after seeing some of these presentations, I don't think we'd have any issue with making a hydrogen plant greater than 5 megawatts for some of the e-fuels producers. So talking a little bit about the low carbon hydrogen standard, this is essentially what sets eligibility from a green perspective for applicability to the business model. It sets a carbon intensity requirement of 20 grams of CO2 equivalent per megajoule LHV. I'm not going to try and do that conversion in my head now, but that's essentially agnostic between blue and green hydrogen. And the way in which that you can prove that is through temporal matching on your purchase power agreement. So you can have a direct wire connection to your renewable energy supplier, but you can also connect directly to the grid and prove that your energy is green through virtual purchase power agreements and temporal matching on a half-hourly basis, and certified REGOs, which prove that your energy is green. So there's no additionality requirement in the UK for that. In terms of temporal matching, the UK has a deregulated energy market, so we're used to trading on a half-hourly basis. So we're already used to doing that kind of temporal matching. So again, we've got the expertise there that maybe some countries don't necessarily have. Just looking through my notes here. And I think, yeah, the takeaway is that we can give you hydrogen for natural gas prices, which I think is pretty attractive. So again, coming back to that point in which, you know, people, they're not just going to give these contracts to anyone. We've managed to negotiate our first contracts. We've got ambitions, pretty big ambitions for later ones, but how do we prove that we can deliver on these projects and meet these requirements? So accurate modelling of competitive strike price is key to success in the UK hydrogen allocation rounds. Let's just focus on that line here. So in order for us to have a good conversation with DESNZ, we need to go to them and say, this is how we're going to build this project. This is the technology that we're using. This is the investment mechanism that we're going to be using. This is how we're getting funding. This is a CapEx estimation. This is the OpEx estimation. This is the energy cost estimation. So we think we're pretty good at that. We've got experience in all of these fields. And what we use is a proprietary modeling tool that takes into account all of these different factors and can calculate what we think we can produce hydrogen for. So it's run and built by somebody far cleverer than I. It uses regenerative data analysis. Please don't ask me any questions about that. I really don't know what happens under the bonnet, but I do interact with it quite a lot, and it's very powerful in analysing the transitions in energy production, the transitions in pricing, taking into account forecasting, looking at performance of electrolyzers, and also taking into account the guarantees. So when you speak to electrolyzers, I'm sure there's people in the room, electrolyzer OEMs rather, they can sell you the world. And what we try to do is get the guaranteed values and build that into this model. And so with this tool, we can pull all of that together and we can provide evidence to DESNZ who underwrite these contracts and say, this is how we can deliver this to you. And so we're able to do those negotiations quite successfully. And we've already proven how we can do that. So I guess everybody has their own kind of motive in coming to these. And I guess our motive as HYRO is we want to talk to e-fuels producers. We want to work with you and we want to develop e-fuels projects in the UK. So what can we offer you? Why would you work with us? What can we bring to the table? Hopefully I've convinced you that we've at least got some knowledge in this space, but I'll go into a little bit more detail as to what each of our partners can bring. So RES, Renewable Energy Systems, our site finding, origination, grid connections, planning and permits, procurement, construction management. We've been doing that for years. We can magic a grid connection out of thin air. I certainly can't, but we've got really proven track record in being able to secure these things. And we've also got technical development expertise. We've got a really strong team now covering a range of different areas. And we think we know what we're talking about in the space, but again, always eager to learn. And then in terms of Octopus Energy Generation, we've spoken about their ability to structure these PPAs, really get good pricing on energy. And also, of course, they bring the development and construction funding, which I think is a big question that a lot of people were asking yesterday. And of course, that tool that I just spoke about, the ability to do very clever modeling and optimization and inform the operational strategy for these plants, we can help you out with that too. So it's very well me saying this is all that we can do, but we've actually already been doing it. And I want to talk to you about one of our green hydrogen projects that was awarded one of the first subsidy contracts. It is a baby project relative to some of the numbers that we're hearing today in terms of megawatt capacity. But if I go back to what the financiers were saying yesterday, we needed to start small. We needed to cut our teeth and really make sure we knew what we were getting into. And when I tell you we've got a list of lessons learned as long as me, from this experience and that we can apply to future projects. I've actually got a workshop on that on Monday where we're going to be applying those lessons learned and really embedding them into processes. So what is the project? 15 megawatts of hydrogen. We're supplying that directly to an industrial heat user, Kimberly-Clark, if any of you are familiar with them. They produce Andrex. Andrex is their main products, but they're a tissue producer. So we're supplying them with hydrogen for their industrial boiler, relatively small scale, but in terms of where we are with the project, we finished FEED, we're this close to sorting out land. Well, we've got the land sorted pretty much. We've got the offtake agreement sorted. We've got the PPA sorted. We've got the planning already signed off, and we're waiting on the contracts from the government to sign that. So we're in a really strong position, and we've managed to get through that. There's been a lot of learnings, but definitely all applicable. So all I want to say is we're not just talk. We have done a project in this space. Again, we've yet to reach FID, I think, like a lot of the projects that have been talking here, but we're this close, and hopefully we'll start producing that hydrogen in 2026. So again, we're just looking to talk to people at the moment and see what sort of work that we can do with you or for you to enable and unlock some of these e-fuels, leaning on the experience that we have with being awarded one of these projects. So in summary, I think the UK holds huge opportunities for e-fuels producers due to the competitive policy landscape and investment opportunities. The production business model is amongst the most generous in the world, subsidizing both supply and demand, and we're offering expertise in both project development and energy procurement to support e-fuels opportunities in the UK. And yeah, I would encourage anybody here who's interested, has learned a little bit, or just wants to learn a little bit more about what's happening in the UK to reach out to Denise or Tracy. They're our project directors, and we're really keen to hear from you. That was a bit of a whistle-stop tour. I probably spoke about 1,000,000 miles an hour despite telling myself not to. But now that I've got that over with, I'll try and speak a little bit more slowly for the questions.
Yes, thank you. Any questions?
Yeah, I'm glad to see guys from Hydro over here. I would only add that I don't think that you can sell that price for natural gas equivalent because it will be feedstock for the e-fuel plant. So I think that coefficient is 1.2. And I think, yes, as a bank, we would be probably willing to finance that in the UK. And we're open to see some facilities coming to us, but unfortunately, they are too small. So I think it's the blue hydrogen in the UK as a lender.
You know, having transitioned from oil and gas, I'm a little bit sad to hear that about the blue hydrogen, but I'll accept it. No, it's a good point that you raised. It's a good point that you raised. That number that I actually had up there, I think it actually takes into account the 1.2 factor. But no, it's a good point. And we'll obviously need to have conversations with all the e-fuels producers about what that number actually is like. I wanted to put a number up there, but knew that I was opening myself up to something like that. Thank you.
Hi, Ashton. You mentioned if you avail of the hydrogen business model, you will not qualify to supply the SAF mandate. Could you just clarify that, or am I hearing that right?
Yeah.
Okay.
Yeah, that's totally correct. And please don't be put off by that. So what we've been informed so far is that you can't double stack subsidies. I don't really see a mandate the same as subsidies, but that's the message that we're getting. So our answer to that in terms of eSAF is you could produce in the UK and export to somewhere else because you then get to take advantage of the low hydrogen costs. But obviously you'd need to do a techno-economic assessment of the, multiple different factors in that. And I'm not going to speak on behalf of DESNZ, but if you're looking purely at eSAF, the eSAF revenue support mechanism might be something to look into, but that's still very early days on that. So we'll see what happens in that space.
Yeah, thanks for the energetic presentation.
Fast.
Not entirely sure whether you would, as a Hydro, also invest in the, say, eSAF project, or would you just be part of the sourcing of electricity and optimization? And I wasn't entirely sure where you could, up to where could you fit, essentially, because it might be, still in the making.
So I'm going to keep my answer relatively vague on this because I am an engineer, so I've got a nice get out of jail clause. But from what I've been talking to my colleagues in the commercial structuring side of things, I think there's potential for many different options, and we'd need to understand kind of who is coming to the table and what that might look like. I can put you in touch with those to kind of explore that a little bit more, but I don't want to say too much because I don't know what that would look like. But there's many different ways that we could work. We're fairly flexible as to what extent we get involved in these things, to be honest, because we're relatively new to the game.
Sorry for the repetition, I think it's because late. So you're saying you cannot account for you if you got the subsidy, but
No. So you cannot account for the SAF, so you cannot double stack UK subsidies. Actually, thank you for bringing that up because that's something that I meant to mention on that slide. So you could produce under the UK hydrogen business model, and then you can export and take advantage of the SAF mandate or the different mechanisms in the EU. Definitely not an expert in here, and I know I'm surrounded by them, so I won't pretend to know exactly what that is. But yeah, it's purely on a UK basis. So you can't double stack UK subsidies, but if you export from the UK, you can take advantage of those incentives in the EU. There's a question around additionality, so you don't necessarily require that in the UK. However, if you were to sell those fuels in the EU, you may be required to do that. And what I can say on Octopus's partnership and involvement in this is we have experience doing very innovative packaging of purchase power agreements that would kind of take that into consideration and facilitate that for any e-fuels producers that wanted to take it into Europe.
Yeah,
Does that make sense?
Absolutely, I agree. We have to be in line with your criteria.
Yeah.
And then, okay, thanks.
Yeah, I think we take just one question and then we move on.
Hi, thank you. That was really great. I'm just wondering, so you say you can stack subsidies, but like the UK SAF mandate is just a mandate, right? Like, does that still count in their eyes?
Yeah.
What about, like, the ETS?
Ooh, I don't know, actually.
Like,
I don't. I actually don't know the answer to that. It's a good question. I was thinking about it yesterday, but I won't claim to know the answer for that. I think biogenic CO2 under the ETS in the UK, I don't know whether they actually have to comply with the ETS, but I'm not entirely sure. And we would be sourcing biogenic CO2. That's one thing that I actually forgot to mention. We're in conversation with a few biogenic CO2 sources and looking to build relationships there to be able to provide that service as well. But yeah, I don't know the answer. Yeah.
Okay, thank you. I think we need to move on. Also, I need to say that I'm not able to stay for the entirety of this conference. So I will do my sort of closing remarks a bit ahead of closing the conference. I think all in all, it's been a very, very good conference. I think the feedback I had from many of you was that it started a bit sort of, what can you say, depressing. I wouldn't say it depressing, but with the speak from Tobias and that the companies in our business not taking FID, and we're aware of that, and we should have been taking FID before. But I think we've seen from all we heard today from the NGOs and everybody that really this industry is wanted and needed. And also we got sort of very good confidence that the banks are here and want to finance this. So I think it's sort of, we are an industry which is a little bit delayed. There's been realism hitting the industry and that's how it should be. There was a belief that e-fuel and eSAF would be very cheap and realistically cheap. I don't think one shouldn't imagine that the energy transition come for free. That's not how it be. This is a cost we all will have. So I think now we are looking for several product developments, which all presented very positively and with a ambitious and positive outlook. And I think we're all heading in the right direction. And I think maybe next time we meet, it's more going to be this fear of missing out, that when we and a couple of others are getting the funding and start to build, then a lot of more people want to join this journey. So thank you very much from me. And I think that Therese and the team will manage the rest very well themselves. Thank you. So yes, Sarah, you present yourself.
Hi there. Thank you for sticking around, and actually thank you to the eFuel Summit. And actually, as I've been working in bio-based SAFs, And some major departments have actually reduced a lot. I'm finding this conference very inspiring, actually. So it's good to kind of understand that there's a whole new part of the SAF conversation starting to develop. My name is Sarah Wilkin. I'm founder of Fly Green Alliance. I did actually ask the summit if I could speak. I was asked to speak at a conference in February on SAF. And as I've been developing some comms work with the Norwegian Armed Forces and Norwegian Airline, which involves e-fuels, I wanted to present the mechanism and the contract that they have been using. As a little bit of background, yeah, a few years ago, I have been working with the University of Amsterdam. We got a Booking.com grant 2018 to work on a SAF R&D project. It was quite a new initiative back then. There was probably only Sky Energy. Our business is based in the Netherlands as well. And so we've basically been part of the development of the interest in SAF. I've spoken on 45 different panels in the last 5 years. Yeah, we're 5 years old now. So it's really been a development phase. We've been involved with making mechanisms, part of the book and claim consultations, and making all of these mechanisms to essentially make the market for SAF. So that's and people have said pioneers and all these words. So so what I wanted to do today is not really concentrate on us, is more actually, how can a mechanism support the e-fuel market to develop? And there's been a lot of discussion today on regulations and a really great presentation by Eshlin. Now, this is a kind of different approach, which is from the banking perspective. We put this, it's from banking and contracting perspective. So the legal perspective, making it flexible enough to essentially to contract, really. So we put it, we have created a report called SAF Mechanisms, and we created that in 2022, and we listed all of the top 10 mechanisms or frameworks in SAF, and it listed the World Economic Forum, Sky Energy, ourselves, Saba. I put a call out on LinkedIn to ask for new mechanisms because now there's been a lot of development since. The Norwegian Armed Forces came back to me and said, we have an approach. Is it relevant? Is it a mechanism? Yes, it absolutely is. So it isn't digital. It isn't quite like Saba, but it is a different approach. So we decided to put this to a webinar, as the Norwegian Armed Forces is really interested in disseminating it. Norwegian Airline also said, we're happy to disseminate it. It's not perfect, but they want to have this very open approach to stimulating the conversation, but also progressing the topics. So they were very open, please critique us, etc. So we got a lot of interest in this webinar. We had 200 people sign up. And we, as it says, SAF mechanisms and modeling and scope 1 and 3 discussion. We also had Fredrik Kampfer, who is the Director of Industry at the Swedish Transport Association, and he's the Director of Aviation, and Arvid Loppen is the Senior Advisor at the Avinor Group, which is the, I'm sure you, as you know, is the airport group in Norway. And Anders from Norwegian Airline. So we discussed the mechanism. It is a mechanism that went out to public tender. So as you may, well, it is the government body. So the Norwegian Armed Forces is, I can't actually see, sorry. As a government body, they have January 2024, this year, and basically it was legislated that the Norwegian government was going to bring in a 30% weighting towards sustainability in all procurement. So this was so they had a contract coming up. It was a 4-year contract for all of the business travel for the Norwegian Armed Forces, and this was to have the troops move around domestically and go to training, etc. So they'd previously had a 4-year contract. This was going into a new contract, as I said, government tender, new roles. So ahead of the new roles, they decided they would comply with this 30% sustainability. So when they put the tender out, they got at least 2 offers. One of them was from Norwegian Airline, and it included a degree of SAF. It included a degree of CO2 reduction, and it was worth 130 million over those 4 years. So they, of course, it is a valuable contract, and this is that contract is for travel. So they're essentially buying travel from Norwegian Airline. Now, what they found is that they couldn't say really whether it was more expensive because of inflation. And as we know, prices have really changed, feedstock, everything. But it is, you know, they were recognizing that it was going to cost more to be more sustainable. So they kind of took that on board as part of, you know, their decision making. And as the government organization, they knew it would cost more. So that was an acknowledgement. And this was for 30,000 tickets per year. So they decided through the process, they understood that it was a 4-year contract. They did have the typical rules for if you didn't meet the contract, there would be sanctions. And they were aggregating, what they were doing was delivering the business travel contract, but as well as SAF. Now, some of the figures they haven't disclosed, and actually it was going to be flexible. It was some estimates within that agreement. And then with regards to the sanction, what they wrote into it is that if they didn't meet it within 6 months after the 4 years, they would still have to buy SAF with the sanction. It wasn't to pay a fine, and they were not able to pay to get out of it. And this was also what the Norwegian Armed Forces decided was also a carbon positive sanction. So it was also kind of a new initiative. As Anders said earlier from Ramboll, he was saying the reason that things were not possible within e-fuels and SAFs is that the contracts were very short term. Now that was an issue, and he wasn't able to secure finance, go to banks with this kind of offer. Now with this 4-year agreement, it basically gave a lot more security for Norwegian Airline because they were able to go through the fluctuations of pricing. It meant, for example, when Norwegian Airline put the amount out to tender, they had that 4 years to deliver it. There was no yearly reporting. The volume of SAF needed would aggregate towards the end of the 4 years. It also meant that, for example, late delivery, which does happen, that say it was tendered in year 1, then they had at least 3 years to deliver it. So it gave a lot of flexibility. And it was enough flexibility for Norwegian Airline to basically take on that risk. And it definitely was a new approach. Norwegian Armed Forces had to get the Chief of Defence to sign it off. The Norwegian government had to have, the head of the Ministry of Environment to sign it off, of course, because it's such a high profile group. It needed to be really make sure it was signed off fully. Now that did happen, and it meant that that was a first in its kind of contracting approach. And it has meant that we can do things like go to banks, and we can, as you may know, that airlines typically have bad credit. So if an airline tries to go to a bank to try and also find finance to make SAF production themselves, they are likely not to do that. We've tried it before with a few different airlines through aircraft leasing companies. The banks come back and say, no, it's not going to happen. It's not secure enough. So this approach with the Norwegian Armed Forces as a customer gave a very good assurance, basically. And it meant that they were going to have a paying customer. Say it was to, they take this now to the banks. It means they've got a very reliable paying customer. They know, they know they're going to get the money. The credit rating, of course, of a government agency is very high. So it really also is better viewed in the eyes of banks. So this now opens up different conversations. So it's an interesting approach. That 4 years does give that flexibility. And it's basically opening up the Financial Times. We've spoken to the Financial Times about this because it can support, of course, the market. As I said earlier, the bio-based SAF market is suffering a lot. It's kind of, there's some fluctuations. There may be a first round of interest, but with energy crisis, there has kind of been up and down in the market. So what this also does with this contract is it's agnostic to fuel. It doesn't matter if it's bio-based fuel, e-fuels, and even electric aviation is written into this contract, which of course isn't probably going to be relevant in this 4 years, but actually it means this legal contract can probably go on. So no need for rewriting this contract. Basically, it's also efficient in legal terms. So there's quite a lot of benefits to this approach. Now, Anders was also saying things like, well, actually, Ashlyn's mentioned this revenue certainty mechanism. So that is in place. And I know that certain groups are already finding that there's teething problems around it. Another approach that we are developing, and as our name says, Fly Green Alliance, we are creating alliances. And these are alliances to basically aggregate interest. So there's quite a few buyers alliances coming online now. Sabra I mentioned, World Economic Forum has first movers. We are an alliance. So what we are doing now is also building our membership. We have a net zero framework, and Innovate UK have said, you are market makers, your business model disruptors, and you're bringing that aggregated market together. So kind of just wanted to mention that because all of these mechanisms are essentially making the market for e-fuels. So there is different approaches, and as Norwegian Airlines said themselves, they're open, they are busy. I'm going to their press launch next week in Norway. They're having their first delivery of SAF successfully as part of this contract. So the Chief of Defence is going to this to really support this initiative. It's of course great for Norway to have a Norwegian-focused mechanism that really can be used in other offtake approaches. So it is an offtake approach, it is a legal contract, it's a mechanism. Yeah, and essentially, of course, what the off-takers are concerned about is that, which has been mentioned today, is that the price changes significantly. So if you off-take and then need to deliver very quickly, obviously it puts the business at risk. So this approach, for Norwegian Airline just gives them that ability to look at the market, see what's coming up, no need to purchase immediately, kind of also get better credit pricing, get better credit opportunities for negotiation and flexibility. They don't need to get locked in too early. And it was basically a manageable risk. They were happy to take on that risk and keep evolving it. So I think basically that is Norwegian Airlines advice. Do not be asking for 6 months, 12 months off takes. 4 years is a decent amount of time. It's not going to be 10, 15, 20 years probably at the moment. KLM was presenting at The Economist yesterday where I attended, and they were saying they bought the most SAF in the world They've basically purchased every amount of it. So I think there's definitely, the airlines are definitely needing the e-fuels. That is as soon as SAF seems to be coming online, the airlines are there to buy it. So of course, it's, you know, if once that is already now in Norwegian Airlines kind of portfolio of options, then I think it'll be a process. So this is my first e-fuels conference. I've been going to a lot of the other SAF ones. I am now learning the technicalities of e-fuels because I want our group to be part of that. As I said, I've spoken at a lot of different conferences. What I've personally done is gone across different sectors. We work with sports. I've presented at the 50 advertising agencies, the business travel sector. I've worked with Amex Global Business Travel to give them their strategy for SAF, lots of travel management companies. So there is a lot of groups out there that have net zero plans. They are working on scope 3. And it's really a case of, as we've said, aggregating them, making sure the mechanisms are in place, and also matching. I've got a couple of clients at the moment where it seems like even from the comms point of view, they're not speaking in the same language as the customers. So what we've also been doing is kind of even tweaking communication, creating new communication, and why they've come to me, us Fly Green Alliances, because they say you're speaking to different markets, niche markets. So our goal is to open up those markets, and that's what we're doing for our customer base. We've just opened our membership this year. We've developed our business model with University of Amsterdam and University of Utrecht, and now we're going into building that so it really does start to aggregate. As I was mentioning, Innovate UK, given us grants. We've just put a consortium together to answer the European Commission's latest mobility, and we've proposed an approach for a policies and governance grant. And then we've developed a expert panel of 20, working with some of the major oil companies, and they are seeing that this kind of development work is building their market. So what we say we've got our framework to help the buyers, the business travelers, but then on the other side, what we do is can help the suppliers and solutions is connect, and as Port of Rotterdam say, match make to basically bring supply and demand closer together. That's what I've been doing lately. I'm going the wrong way. So actually, the Norwegian Armed Forces is also, sorry. No. So yeah, and then the Norwegian Armed Forces has a tender out for a SAF, for SAF. So they are, if you're interested in tendering for e-SAFs, it may not be obviously anytime soon. There are some producers here that have said they've already got off-takers. They are producing. If anyone is interested in tendering, let me know. I will send you the link. So they are able to test. The military obviously is very good at being able to be a test bed. And I've just discussed this a little bit today. Because I've been to so many conferences, and what I have been doing is on the demand side more, as I said, sports, business travel. So I've been to a lot of those conferences, hearing that people are not really technical. They don't know really about mechanisms, how to off-take or inset, and how to discuss that, but then also get access to these fuels. So we've put this report together to help everybody navigate, but then in many ways, it's also to help the market. Once people can navigate, they understand which mechanisms, offsetting, insetting, book and claim, they can then embed this into their net zero strategies and then eventually purchase fuel. So please sign up to get this report. It's out in 2 weeks' time. We have a webinar coming up as well to present this. We have a lawyer that is part of compliance going to speak. And then Earthly, which is one of the offset groups. I will talk about SAF, and then we'll have a biodiesel producer as well. So thank you for slotting me in at the end. Appreciate it.
You, any questions?
Hi, thank you. My question is, to what extent are, like the purchasers or, people trying to reduce their emissions, sensitive to like the life cycle emissions of the different fuel types? Or are they not really in the weeds like that?
No, they definitely are. This is why if you get, so I've been working with groups like Formula E, and they are very, because they're also high profile. So there's the benefits of having high profile members, customers, but they, of course, they're going out very publicly with their reports. So they are definitely making sure they have certificates and LCAs. And I would say that, yeah, it's very important. So that's what, I can advise them of what to get and how to buy stuff and things like that and what to look out for. It's definitely important. And as I've also been at the World Nuclear Association events recently, talk about the need of nuclear for e-fuels. I've also asked today as well, what is the LCA for? Because that will be the immediate, have you got an LCA? What is the GHG reduction? It's not going to be 100%. How is that? So it's definitely those that are very technical sustainability managers, net zero managers will ask you for all the detail, of course.
That's great. Thank you.
Any more questions? Okay, this is it. Thank you. And we can move to the panel discussion. And for the panel discussion, I would like to invite to stage Bian Kohl as our moderator, Geir de Kock and Aisling Fraser. Please take your seat. And if anyone from the audience, our participants or speaker would like to join the panel discussion as well with some ideas, feel free to do so, and please keep the engagement with the questions. Thank you.
Does it work? No. Hi, does it work? Yeah? Okay. Hi, so maybe I first introduce myself. I'm from Hitachi, it's also Innova. Our company is historically has been in the waste to energy business and then has developed into biogas and also power to gas. And we are an EPC player, so we deliver EPC and proprietary technologies to the to these different three fields, I would say. And in the power to gas, we are mostly today focusing on methanation, starting to do methanol as well. So yeah, very interesting 2 days for me, very intense. We don't have all the four planned speakers, so we're going to make it a bit shorter maybe, but I had, I guess the topic here is how to bridge the gap for these e-fuels. And I think I had, if I can recap, for these projects to start going live, I would see, I guess, 4 conditions, and that's pretty much universal, I guess. You need to have technology which is sufficiently de-risked at the size that is the target size that you want to do. You need to have stable and clear regulation. You need to have willingness to pay for from the off-takers. They need to exist, but there needs to be willingness to pay. And you need to have access to a feedstock that is guaranteed for the life of your plant. So that's both, I guess, power and biogenic CO2, or CO2 in the case that we're discussing. And so my first question would be, if we take one of each of these conditions, do we think we have them, and what's the gap to get them? So starting with the first one, technology de-risked. I mean, I'm in EPC business, so I know that as an EPC provider, you need to be able to provide a complete solution, performance guarantees, and you can do all the pre-feed and feed study you want, but at the end of the day, somebody's going to have to take the risks. Yeah, I'm a bit impressed by the sizes that we're all targeting here. And my first question would be, should we, would it help to go through, let's say, an intermediate size? So would be maybe a first question to you, because I saw that's a bit.
Yeah, absolutely. That was certainly part of our strategy when we started pulling together HYRO. I think I was saying to a couple of people, when you attend green hydrogen conferences, the scale of some of the projects with no defined off-taker is huge. And our approach was to start with an off-taker-led origination strategy. So speaking to people who would be guaranteed to buy the hydrogen from us rather, and that led us down relatively small projects. Specifically containerized solution, where a lot of the technical aspect is built into the container that contains the electrolyzer, and the risk associated with the engineering of the balance of plant is minimized that way. So you're kind of spreading your risk between the EPC, your OEM provider, and that's how you can kind of get slightly more comfortable with the guarantees that are being offered. Saying that, a small project was still incredibly hard. I don't know whether it's a good idea to share that, but I'm just being open and honest. And I think, all of these projects are going to continue to be hard, but the lessons that we've learned through kind of almost achieving FID with that project, we can apply to the larger one. So yeah, I think starting small was a good idea for us. And we've got ambitions then to scale up with the right partners to share that risk.
Anybody want to maybe comment or? Yeah.
Yeah, I just have a question. If anybody actually knows the answer of what's the largest scale operating e-fuels right now? I should know, but so I'm wondering if anybody here does.
No. Yeah, what's the largest scale e-fuel?
There's none operating at all. Yeah, you do. Like with the process that we've been discussing.
Yeah.
So.
I'm not sure.
Okay. Well, that's, yeah.
1,000 tons per year. I don't remember. Like small. That's one of the marathon ones, and maybe it's 2,000 a year. I'm not sure, but that's
the ballpark.
And maybe there are others, but that's the one.
Observation, I guess.
Maybe I could just add, because we have a Fischer truck, and we have really tried to scale it so much down as we could. And that is still much higher. And we cannot scale it down 10 times more, because then the pipes are simply too small with this the bags which are in there. So it's also a minimum scale.
Absolutely. So just speaking on behalf of HYRO, I guess we wanted to start. So we come from a renewable energy generation and renewable energy project development background. So if you compare the projects that we're trying to do now with the projects that we've historically done, you look at storage projects, you look at wind turbines, you look at solar PV, there is a limited amount of engineering involved with that. I think my engineering colleagues, those non-process engineers, might argue with me, but I think in the process engineering space that we're talking about, there is a lot more engineering involved with that. So we said, okay, let's start with something containerized. Let's learn about that. And meanwhile, so a large part of my job at the moment, I'm the senior or lead process engineer for HYRO. A large part of my job is engaging with OEMs, different suppliers, different EPCs, and learning and understanding how to scale up effectively. How do we want to resource these projects? Who do we need to get involved? What are the partners that we want to play with? And also relying heavily on consultants in areas where we have recognized that we've got a skills gap. So my background is oil and gas, so I like talking about kilograms per hour and things like that, but there's still a big gap there, and I think we need to I mean, I might not have given it off in my presentation, but we need to maintain humility and recognize that we're all learning. And that's one thing that I've recognized in this conference is that the environment that we're fostering, that we're all willing to learn together and work together is really exciting to be part of.
Okay, so I propose we move to the next point. So were you talking about, sorry, about Veltre or Veltre, the power to gas plant, or? Okay, okay. Yeah, second condition would be stable regulation, clear with rules that are set that investors can rely on, I would say. So here I would turn to you, Geert, maybe. I guess there's quite a bit of things we've seen and we've talked about several times in the 2 days. Do we really have something, I mean, some set of rules that allow us to have a 5 to 7 year development time up to commissioning, I would say, plus a 15-year payback period at least? Do we have that with RFNBO? Do we have that with RED? Do we have that with the multipliers that can help? So is that enough, or is there still a few gaps to bridge and to lobby or to support or to encourage, because that's your role? How do we ensure that also, I guess the European Commission understands what stones are on the way?
The very short answer would be yes. I think the regulatory framework is there. There are mandates. There are mandates on like to also ensure there's a demand for these expensive fuels. There's a mandate to supply them. There are penalties. There's also a long-term perspective. I mean, the ESAF mandate stretches out into 2050. So there is, there's not like with the IRA sort of a cliff edge waiting in 2032, not knowing whether there will be support down the line for this for these products. So I think a lot is in place. The RFNBO rules are in place. The one missing piece is maybe the low carbon fuels. So that's still a question out there, whether whether the rules hopefully will come soon and on time. Whether the rules are always as workable as people would like. One of the main takeaways at this conference is really about the carbon sourcing. For me, that's one of the main takeaways in terms of, will there be enough carbon to make these fuels in terms of like the eligible carbon sources that are in this delegated act, and whether there will be enough sort of runway to make a project work. So that's a takeaway for me. We're not dogmatic about this. The rules are in place; they are clear. But yeah, there's a discussion going forward about, and there is a review coming in 2028 when we might have to review some of these rules. So short answer, yes, some gaps around low carbon fuels. And also these rules are not set in stone forever. I mean, there will be reviews coming up in July 2028 when we'll have to revisit all these issues again.
Okay, any comment from anyone? No?
If I could?
Yeah.
So the rules are there, not in place. And then it starts to and it seems like the concern is that if we come to that drastic ramp up and we don't have the projects ready, we don't have the fuel ready, there's nothing for the people that have mandates to buy. And then you think, nothing to buy, what can I do? Cannot penalize not buying something that doesn't exist. So is there something we can do sooner to kind of get that goal? Because the 2% is really not, doesn't have any teeth, right? In the shipping side where we are, I mean, our customers, they say, yeah, in 2030, 2032, then it's time to really do something. And then we can just, float along and then it's all going to be fine. And then we're getting more.
I mean, I agree in my own presentation. I also highlighted that on the shipping side, it is specifically for e-fuels, it is more complicated because you're competing with other options. The targets are quite low. And so, yeah, there's an issue there but again, there's an opportunity at the national level in these RED implementation to have a mandatory sub-target to supply e-fuels to shipping, which is something that Transport and Environment is really pushing for, to make sure that there will be fuels and that ship operators that want to invest in e-fuels or that want to offtake e-fuels, that they are certain that there will be a supply coming forward. And then I think even with those mandates dedicated to shipping, I mean, the Commission is also, like, in the next hydrogen bank auction, there will be a dedicated basket for the maritime sector, because they also recognize in the first auction, there was a lot of like ammonia focused projects. Some of that may go to the maritime sector. It's not a given, but yeah, there is a concern that the maritime sector will be a bit left out. So additional work is needed there. I would agree. But it's also a function of the low level of ambition in FuelEU Maritime. And that's what you get when you have to agree with 27 countries.
But I would have actually a comment on that, and that leads to the third point, willingness to pay of the off-takers. I guess there's two ways to do this. Either you increase the percentage of green fuels that they need to put in the tank, and you increase it progressively over the years. But if the penalty for not doing so is not high enough, there's a high risk that either the scenario you described will happen because they are going to delay their decisions, or they're going to go for another solution or just pay the penalty. So I'm really wondering if it would not be more efficient in order to start the industry and show that this can happen, to really have much more generous multipliers for a period that allows return on investments, with maybe less volumes in terms of quantities of quotas, so that at least the first comers can see a business case, because they're the most difficult ones. The first step is always going to be the most difficult one. And as soon as 1 or 2 or 3 projects will come on live and prove to be profitable, then the others will come, and that will generate, because offer generates demand and demand generates offer. So I don't know, that's maybe a question, wouldn't that work better?
I'm not sure I can answer that.
My comment on the multiplier is that it just drives even less volume. It should provide too much benefit on the little volume we do when it makes so much. Now, maybe that's
but it helps the willingness to pay.
Yeah.
Which is what you need to pay back your single project, because you need the first project to come on live before you can get the next ones.
I mean, just a comment on the multiplier. I think there are multipliers in various texts that make, e-fuels more attractive option to comply with certain mandates. I think still, like, a sub-target, like a mandate to supply a certain amount of fuels is a stronger instrument than multipliers, because then, yeah, I mean, we all have our projections on costs and how cost competitive are e-fuels compared to advanced biofuels. I mean, we don't know what happens in that market in terms of feedstock price. So I think a mandate puts a lot more certainty in place. As I said, like, I think the RefuelEU, like the e-kerosene, the synthetic hydrocarbon mandate gives a lot more visibility and gives a lot more, like, long-term perspective. And I think that's, I think you can count more on that, or an investor will maybe feel more reassured by a mandate than by a multiplier, not knowing, because it only improves your position relatively to other options. And that's where I think a mandate is clearer, like saying, like, this is the road to travel. And in the shipping sector, again, like, there is no mandate yet, and we'll discuss again in 2031 whether enough RFNBOs are on the market. you have multipliers and maybe a discussion in 2031. It's not enough to really drive a market, I think, yeah.
Yeah, the mandates definitely do work. Literally all of the big oil and gas companies are working very hard to get to these mandates, but they're not. When I do questions, will you make more than the mandate? Then generally, because I say, really, so what I did got to say in my presentation is that obviously there's regulatory versus voluntary. So there is a lot happening in voluntary with science-based targets, and our net zero framework is a voluntary version of a framework to make it's a market maker. So there's more initiatives coming online and buyers alliances, which have been discussed today as well. And now obviously it's part of the conversation, because that can be valuable. If you look at, we wrote one report a few years ago, and it was how did the renewable electricity from wind market develop? And it was mechanisms such as Google and Apple doing obviously large PPAs. It was pretty high profile companies, and that these ones obviously can. I work with Formula E, Amex, all these. Quite, they're high profile. I also work with not high profile groups as well, but it does really help once you kind of get that influence going. And there's a big sports conference this week that I'm not going to, but there's such big sectors that are really getting quite, actually moving. What's the word? You kind of
momentum.
Yeah, they're talking about it. It is high profile. They're posting it. It's gaining that momentum, and then eventually commitment, green sponsorship. So it is kind of it's a different approach, and it's not all of our approach, because we've done market work, industry work, have contributed to the net zero 2035 plan for Wales, and there's all sorts going on. But it is it's definitely the off-taker. It's some of the offtake. And some of these are the ones that are willing to pay a high price. Like I mentioned before, the Microsoft paying $100 per megawatt hour for a 20-year offtake. Now that's higher than some may be willing to pay, but because they're in that position to do that little first mover, and they promoted it at Climate Week in New York, it was a promotion as well. So it's also how are these niche markets? Or can you also understand the psychology or the strategy of some of these companies? Then there's quite a different approach, and it's not your standard group that is looking to just about comply or so. It's I wanted to bring that. Thank you.
Thank you. And the last condition, feedstock, so both power and CO2, if we're talking about, let's say, carbonized e-fuel, I would call them. So we touched upon the biogenic source, the fact that, I guess, beyond 2040, there's a deadline for CO2 coming from fossil. Is that giving sufficient visibility for the investors, or is that killing a lot of projects from day one, so they don't even start? So how do we work on that? Maybe that's.
I don't know how we're going to work on it, so I don't have an answer from that perspective. But I've been thinking about it a lot since joining this conference, and I just want to draw the parallel with my point that I made during my presentation. It's responsible use of the molecules, making sure that we're using the molecules where it makes most sense and there is no viable alternative. So coming from a kind of green hydrogen space, Michael Liebrich has set out his green hydrogen ladder, where there is, you can use, you see mad things saying using hydrogen for home heating. Resin Octopus are very much against that, but it really sets out, okay, these are the areas where there's very few viable alternatives. And I think we need to start looking at CO2, the use of CO2 and converting it into those molecules and making sure we're using them responsibly would be my take on it. saying that, that's only kind of a thought I've had over the last 2 days. So, you know, if you want to challenge that, please do. Maybe not in public. Let's take me aside after this conversation. But that would be my take, is really understand what are the alternatives to using this biogenic CO2, what can we do with it, and yeah, make sure we're using it responsibly.
One of the ideas that as TNE that we sponsored or that we promoted in the Refuel EU discussions, because we saw this problem kind of coming, was this idea of attaching like also a direct air capture mandate, very small, very, very small, like 10% of the 1% e-kerosene, to kind of like create that market, and again to get sort of an S-curve going, to like at least support the technology very early on and then scale it later on. And that didn't make it into the final decision or the final regulation. I still think that's one of the better ideas out there, but I'm open to other suggestions. But yeah, like at some point we'll have to say goodbye to the fossil carbon, and once the ETS runs out of allowances, there should be other options on the table. But I agree that the situation is difficult, and a lot of the DAC companies have also turned away from the e-fuels because it's also like it's a slow developing industry, and it seems like just it's already a complicated industry. To add more obligations on top is not going to help. So, but it is something that I take away from this conference, that we need to really pay attention to this so we don't hit like a barrier or future upscaling of e-kerosene production.
And what about this debate of CCS using biogenic CO2?
Well, I mean,
because that's in competition to
clearly
doing something with the molecules.
I mean, on the biogenic CO2, I mean, again, like bioethanol made from corn, or like we're not particularly in favor of that. But yeah, and if it would be a waste if sustainable feedstock, biogenic feedstocks are used for CCS. I think that there is a better use for that carbon. If it's from a sustainable biomass source, then it would be a waste to put that underground and not make that available for an e-fuels industry. So I would definitely support that. But with biomass, it's always about like the feedstock, and then there's varying opinions on what's sustainable and what isn't.
Okay, I have a last question, and then I think we can. So we're mostly focused on producing e-fuels. There's, I guess, I see two benefits. One is the environment, obviously, but the other one is, I think, and I'm not sure it's addressed enough, or whether it will become more of a topic in the coming years, which is energy security of Europe. Because e-fuels, any molecule you produce locally, if it is locally, or if it is coming from a more variety of imports, let's say, helps your energy security. And how does that fit in the push towards e-fuels, and as an argument to push towards producing more? So that would be a point where, I mean, how do you see this as something that is seen by the European Commission or the legislator as something that they should focus more on?
There's great, or I would rephrase, there was great enthusiasm for hydrogen imports or hydrogen derivative imports into the EU, and at the height of the war in Ukraine. I think that initial enthusiasm has cooled a bit. I mean, we published a study, Transport and Environment, on hydrogen imports. I mean, we are not against this per se. I think but there is something to be said for developing this initially in Europe. First of all, also making sure that there is a bit of a made in Europe kind of resilient industry criteria attached to support offered to this industry. So we support like electrolyzer manufacturing in the EU. I mean, synthesis production facilities like that. We build a European industry around this, so that we are leaders in this area. And well, from this conference, I mean, there's a lot of European players. So I think there's that element, like local production, local industrial base. And then when it comes to imports, I mean, maybe down the line, we are not against this. I mean, there's green shipping corridors and all those kinds of ideas that we're not against this. I think for us, when we looked at 6 countries where we could potentially import from, the local electricity is almost all fossil based, whether it's Chile, Morocco, Egypt, Oman, it's all very fossil based electricity. And so I think if we're going to import from those places, I think Namibia was another one, because they're connected to South African coal. I think there needs to be also a requirement from the European side, if we're going to import, that there is a commitment to local decarbonization, or that it brings some local benefits. So this idea, we'll just import it and then forget about the local impacts. As TNE, we do not see that as the right way forward. The sort of picture from the eFuels Alliance of there's 20,000 places around the world that we can source this from. This is not the sort of mantra that we're not against it, but it needs to be done in a more sustainable way.
So I think in the UK, there has definitely been a huge shift towards talking about energy security since the invasion of the Ukraine. I'm struggling to remember what they were called beforehand, but we've got the Net Zero department is called the Department of Energy Security and Net Zero. It was rebranded a couple of years ago, so that really sends a very strong message. And from a UK perspective, there is a huge amount of focus on supporting UK industry and providing incentives for that. So we've got things like Great British Energy. Until a couple of days ago, that was still a very much a changing concept, but that's really supporting supply chains in the UK, making sure that both from an economic perspective, but also a security perspective, that we're able to hold ourselves up. And I guess a question to the room I've been thinking about a lot, but I don't know what the answer is. But in terms of importing from other places, how do you think things like CBAM might play into the e-fuels, like importing and transportation of e-fuels? So the carbon border adjustment mechanism. It's been on my mind to say, okay, well, if we're importing from these countries, how do we take into account the fact that they may not have regulation, they may not have carbon taxes or emissions trading schemes, and how might that play into it? I don't have the answer, it's just a thought.
Thank you. Anybody want to comment? I don't know.
I don't know, just curious.
Just, I mean, on importing like RFMBOs from outside Europe, I mean, it wouldn't be like, it would be carbon neutral or zero carbon fuels, so they would be not subject to CBAM, so CBAM wouldn't really be a barrier there. I mean, CBAM would encourage that kind of trade. So yeah, I also feel that the discussion has gone like, let's do everything domestically. I don't think that's a good idea either. So yeah, we're kind of like a diversified supply, but yeah, start in Europe and then move out. I mean, a bit like, I mean, I liked the banking sector's approach of like, yeah, let's develop some small projects, make sure that they operate, and then, you know, then we'll go for bigger and then maybe we can take it somewhere else. But for now, let's start here and now.
If I may just also in looking at the alternative between import and producing in Europe, I mean, the elephant in the room is the cost of electricity in a number of European countries. I mean, let's just be realistic. Except Iberia and the Nordics, the rest of the country with the current rules, they won't make it unless there's a support. So it's all great, but today, if you are in the middle of Europe, you won't be able to produce, a sustainable, competitive hydrogen or any e-fuel unless you have massive support. And this is not 0.5 euro per ton, which I call massive support. That's not enough, but this is too much money. So either the rules are relaxed one way or the other, so that you can produce and with renewables and low carbon and the like. But today it just doesn't work. If you look at the map, if you look at the numbers, that just doesn't work.
And is that because of the merit order and how the price of electricity is fixed, or is that because the levelized cost of power from renewables is going to remain high and too high for the?
Well, it's because of the way the rules are set past the
you know, the delegated act plus the exemption years. It's because of the fact that, you know, there's a lot of debate on low carbon, you know, hydrogen. Will it include nuke? Will not be, I mean, but if you look at all of that and you put it in the model, it just doesn't work today. And, you know, the subsidies, you cannot rely on subsidies forever, for sure, but it's not with, you know, clearing at 0.5 euro per kilo that you will help the project fly. It's just not going to work, at least for the first few projects. So just a bit of a realistic check on the numbers. I mean, as an investor, doesn't work.
So we need price for difference.
I'm glad you said it. I was just going to say, I mean, if you're looking to import from anywhere, the UK is a good place. But no, it's all good points.
Okay, thank you, everyone. Yeah.
Thank you.
Yeah,
Okay.
So we can improvise. Yeah, exactly.
Okay, ladies and gentlemen, just last word from me. Thank you very much for coming and staying till the very end. Please stay with us even longer for the networking, have a coffee, whatever you need. And as I mentioned, all the presentations will be shared with you approximately within 1 or 2 weeks' time, depending on the fastness of our speakers for any updates. And please don't forget to fill in the evaluation form and hand it to my colleagues here in the room or at the registration desk. But don't you worry, I will be also sending an online editable version. Thank you very much for coming and hopefully see you in the future. Thank you and goodbye.